Oh god. That was
What?
good. That was right at the start. There's a big sound. There's a big sound. Okay, I can hear myself. Okay, we're good. We're live. Okay, pause that so I'm not rewatching my stream. We're good. Now I gotta make an announcement.
God. Oh God, that happened to Agma once. I
Oh,
remember. Oh
oh.
no.
Okay. Be
Good
sure
God.
to, if you're just tuning in, be sure to join the Discord. Be a buddy. It's fun. Look at this. We have Pepe. Look at this clown Pepe. You get to see this today. Join the Discord. It's fun. This is a good Pepe. I already wrote this because I knew I would forget it.
Oh,
Because I've screwed them up the past like 3 times, and I hate looking back at them because they're just wrong. So
oh
I,
dear.
I, I wrote it in advance. I'm
That's
not
good.
I'm not screwing it up this time.
That's good.
Anyway, we have an announcement now, so we should be officially live, and we are ready to go. Maybe give plumbing a chance. C# devs, am I right?
God.
King Buns is just killer. Hitting him with the roast, his coworker. Okay, what are we doing? We're doing the merge. We're not even in
Yep.
Emacs at first, right?
Hmm.
A terrific table 55.
We'll probably be in a browser window for the next 2 hours.
What? No. When have I done that? That doesn't sound
Oh,
like me.
you're right. It's usually 3. It's usually 3. My bad.
I mean, 10 minutes of work.
Oh God.
Do I? I suck at pressing buttons, man. Okay. Yes, we're here. We're not here. I went to the wrong spot. We're good.
There, but not there.
How's it going, Terrific Table 55? He says hi. Or they say, I should say. What do you say?
On sauce.
I don't know. Oh no. Okay, we have a new PR.
2 PRs are still there since like September. There's still an algol test framework in there, you know.
We're gonna do it. We're gonna use it. We're just not there yet. Because we gotta implement
Right.
that at some point. I suck with time. And I like doing this low level stuff a lot more. Look at that diff.
Yeah, that diff is pretty good.
more more lines removed.
Exactly the same, but unfortunately I didn't manage to do that.
Okay. Should I look at commits in a row or just files changed?
Don't look at commits in a row, preferably.
Okay. You said don't look at them?
Don't.
Okay.
It doesn't make sense often. Like sometimes I'm not particularly clean with my commits because I know they're all going to be one huge PR anyway. So
That's true.
yeah, error handling has been overhauled.
Oh. So we now have error, which issues a diagnostic, which sounds scary. Does this get rid of that warning I get all the time?
Yes.
Awesome.
The one in the assert.
Awesome. That's great. Yeah, I get that in the to-do assert.
Mm-hmm.
That's beautiful. Okay, so we have what? We just added target link options. Okay, I was like, is this the same?
Yeah, if you think this diff formatting is bad, wait till you see op.c. Like git butchered op.c. We'll get to it.
Oh no. Oh no, Terrific Table 55 says I can't use CMake. Oh no. What happened? What's going on? There's always the Discord help me. If you wanna post some exact errors and stuff, or a dump from your shell or whatever. Terrific Table 55 says did that. You did that? Okay. A few days ago. Oh man. Okay.
Yeah, we need to scroll up now. That's gonna take a while. Oh,
Okay.
never mind.
I get this.
Error.
Oh, okay. So this is
another project.
This is yeah. So what's your CMake lists? You know what I mean?
Yeah.
There's a lot more data we need because this is the error from Ninja.
stupid thing that you will run into, which is something that you have to know, otherwise you'll never figure it out with CMake, and that's the only thing I can think of because it says after 100 tries, is maybe it into an infinite loop, and that can happen if, for instance, you set the CMake C compiler in on the command line, but then you also set it in the CMake
Oh yeah.
lists. And then it will overwrite it and it thinks, oh, it needs to rerun CMake. It will overwrite it again, it needs to rerun CMake, and so on. You get that if, like, or I think if multiple CMake files, if a submodule sets a different C compiler or something like that, and then it just keeps looping and it never stops. So you need to be careful if you set a compiler in, so if you set CMake C compiler or CMake CXX compiler, you need to set it to the same value everywhere.
Huh.
CXX98? Why are you doing that to yourself? Okay, good. 17. That's better. I was gonna say plus 98. Don't use C plus 98, please.
Yeah,
Don't.
that would be crazy. First time chat from Anshul XYZ. I feel like I've seen you before. Is it a first time chat? I feel like I've seen you before. You use C at work? No, I don't. I'm not a professional programmer. I'm a hobby programmer. I set it to 98 for C Lion to reload the project. Oh no.
You know you can just do either right click on the CMake lists and click reload CMake project, or do shift and then do what's it? It's just reload CMake project again. Yeah, just run reload CMake project. There's a command for that.
Nice. Terrific Table says no until now I
All the
didn't.
time.
Legendary. Well, that's awesome. We're spreading the like low level tricks of Sea Lion.
Wouldn't call C line that low level, but alright.
Fair enough. That's low level for a lot of people.
What we're looking at. This is going to be a boring diff because it's basically just going to be error handling.
I like errors. What happens when stuff goes wrong is always interesting.
So yeah, I'm starting to replace panic with ice, and because like I'm not sure if panic needs to exist anymore.
What did I? Okay. Right.
And
Because
what we should also do is make it so assert and what's the other one? I think to do and unreachable that they should
yes,
also call ice, basically. So
that's true. That's
I
a good
haven't done
idea.
that yet. So we'll do that.
So there's going to be a major refactoring of errors again. After this major
No, no,
refactoring of errors.
it's not really. It's just gonna. The only thing that's gonna change is the internal implementation of assert.
That's
That's
true.
the only thing that's gonna change because all of that is just implemented in terms of assert. So if we change that, we change everything.
Yay. Terrific Table says, I just always change the version to reload or just use make. Oh no.
Christ.
And Anshul says,
Okay.
maybe it's my first time chat. Think. Who knows? Who knows? Can I make this go away? Go. Okay, I can't. It didn't work.
I don't know. I don't think you can. I'm not sure. Maybe. I don't think you can. You can move it around. That's all I know. What is that? Is that
Oh no.
is that a makefile?
This.
It's weirdly formatted. I think it might be a makefile.
Yeah, there's tabs. That's why it's a big issue.
Yeah.
Oh
I think it's a
no.
makefile, yes.
So
Why are you using a makefile and CMake?
that would be
Or is
my
that the
question.
makefile that it generated? If so, why are you looking at that?
And it's so you're using Sigwin. Is that the default by Sea Lion? I'm pretty sure is what this means.
I have no idea. I
Okay.
haven't used C-Line on Windows in like years.
Sea Lion used CMake files. I
Used
don't.
CMake, yeah.
So I use make and
Okay,
terminal.
that's a bad idea.
That's a
I
bad
would
idea.
recommend using CMake.
So do this.
I
CMake,
used to be pretty good with make files, but I can't tell what's going on here. I
right?
have no idea what minus at make the out does, honestly. Also, don't forget about dash s something, or do you not need it if it's in the current directory? I think you don't.
Yeah, you don't need it if it's in the current. I used to not know that, so I put dash s dot all
Yes,
the
I
time.
also just write dash s dot all the time because sometimes I'm in the build directory, so then I need dash s dot dot. So I'm just used to that.
With CMake lists. I'll just make it explicit.
And then you can cmake build with cmake -- build.
Yeah. If you don't want to find the makefile every time. That's somewhat the command cline uses. Oh
Yes,
no.
it is, because cline uses cmake. If you click on the build button, it does that.
Oh no. Okay.
Oh yeah.
That's okay, 1 sec. We're gonna keep going through this. Errors. Default 0, that's good. Issue diagnostic instead of this statically allocated 1 kilobyte error message.
Yeah, that's a lot better. Not. Oh, it is statically allocated. That's even worse. Yep.
Yeah. It's just a kilobyte.
Yeah. I mean, it's fine, but still, it's scuffed. It's very scuffed.
Also, shout out to Zoft Fei, Taxborn, Vivu Huang, Lucas Almeida 026, and Willie John 2003.
One person.
Thank you to all of you for following while I was offline. I really appreciate it. I should keep up to date on that. I love Willie John. I hope that's his real name.
We also have no discard now because GCC has a built-in attribute for that. So
Oh, that's good. Nice.
Yeah, and you can also see that there's some random formatting changes all over the place.
Yeah, that's
the
fine.
default break.
In D, default break is actually recognized by the compiler, which makes so much sense. D is actually it's a cool language. I will say, when reading C, you go a lot like, oh, I could do that a lot easier in D. You know what I mean?
Yeah.
Which I'm sure is how you feel about C++. It's a similar language. Oh, Zoftface says, I'm actually May on Discord. Thanks for the help. Awesome. We're used to people with 2 names around here, so don't worry about it. Zoftface is May. Am I saying your name right? Zoftface? Is it Zoftfi? The AE always gets me. Is it Zoftfi?
Pronounced Fey. It's just that the word Fey has 20,000 different spellings. Yeah, that looks like what C-line does. It invokes its bundled CMake, and that's basically what it does, yeah?
Okay.
It also does --J something. In this case, you probably have
10
doesn't
cores.
do. Yeah, I have 32 threads, but it also the default is J24 for some reason on my machine. So
it's probably the max amount.
How many cores to use?
I mean, some cores are like meant for different things, right? You have like 6 fast ones and like 8 parallel. I don't know how it works. That's why all the Intel CPUs have like 14 now instead of an even number. Didn't that start happening?
I don't know. I have an AMD CPU. I'm not up to date with
AMD, Linux. What's next? You're like the biggest GigaChad programmer.
An AMD GPU, so that's that.
Oh, I'm sorry. Did you write a driver for it, or is it still slow?
Well, with the AMD GPU, I can actually see my TTY because the NVIDIA GPU would not show the TTY. I'd have to log in with just a black screen. I hope that I typed everything correctly. I could not see what I was typing. With the AMD GPU, I can actually see my screen. So yes,
it does function better.
See my screen over not being able to do so.
It's
that's
true.
why I have an AMD GPU.
Zoftface says, yes, it's German. Okay, I feel much better about that then. I always feel crazy if I just continually mispronounce someone's name. I'm just bad with names in general, so I'm really spooked about it. So they passed -- here.
No, it's --build. That's just
I was like, wait a second. -- passes everything. Okay, so let's build this specific project.
Debug is the default name of the output directory for the debug build.
Okay. Yeah.
Yeah, that looks like the command that C-line uses typically.
So that doesn't look insane. The CMake lists doesn't look insane, right?
Yeah.
So I don't know what's going on. Have you tried? You said it's using. If I change from Ninja to Unix makefiles, it can't find the makefile and crashes. And it uses Unix makefiles, but for some reason doesn't show -G Unix makefiles.
That's not the generator command, that's the build command.
Yes.
Crashes. We need to invoke CMake twice because CMake isn't a build system, it's a build system generator.
That's right. You need to invoke it once and then invoke it as many times as you want on that build tree.
Yeah.
however much it changes, until you change the build tree, like the
I usually
sources.
just do like both, and I like CMake, for instance, to build the fun compiler. I do CMake dash s dot dash b dot and CMake dash dash build. I always do that like in one command.
I see. Yeah, I almost never regenerate because there's an auto zero. They check if like the CMake list has changed and automatically regenerate it during the build.
Yeah, but the thing is, it takes no time at all in for most
You're
projects.
correct.
So I just run it all. I just always run it. That way it works.
You are correct. It doesn't slow anything down, and it actually adds a beneficial feature. So arguably, it's the thing to do.
Mm.
How's everybody doing? Thank you so much for tuning in. We are merging a PR that does a lot of it. Basically, overhauls all of our error handling, which is amazing. With we now have no discard, which is probably a big deal. But we also discard a lot. Don't worry
Yeah,
about it.
but we don't discard a lot. It's like in two places. Here we don't care about it. And what's funny is if you just cast it to void, it still warns about it. So that's why we have this scuffed variable there.
It really still warns if you cast that to void.
Yes, it does. Otherwise, I
Okay.
would not have done this because this is stupid.
It's always the compiler.
Mm.
Direct call should store a reference to a function, not its name. So this is what
Yeah,
we're
I
doing
found it.
today,
Yeah.
right?
Yeah.
We're gonna work on that. Okay. And then where are we? That's confusing, but it looks like the error just got handled
This is
differently.
confusing. Just you wait till you see op.c. It's much worse. So yeah, we can now do this everywhere because cogent expression returns false if there was an error. We can just return false.
That's
like
right.
the common
Oh,
pattern that we have
okay.
everywhere now.
I hit the wrong button again.
Oh dear.
I'm back. Okay, where were we? That's gonna make things hard if I keep doing that. Oh man. If anybody has any questions, just put them in the chat, put them in the Discord. Oh, okay. Crashes. And that's why I use make, simple and easy make build to run gcc source main -o out /main. I mean, when it's that simple, you're correct. It is simpler to do it that way. But when you're
I mean, the problem is that what
a
you're
little
missing in
different.
this invocation in particular is warnings. And if you want to add all 47 warnings every time you call the compiler, then have fun with that.
It's true.
Like,
So, what was the error?
invoking the compiler from the
Said
command line
ninja.
is something I rarely ever. I think it's important to know how to do that, but I rarely ever do that. It's only when I'm testing something.
I'd say I use it a lot in because I write toy assemblers for testing.
Mm.
So when testing the output of that, or like object dump, or trying to compile an object file into an
Yeah, I see.
executable.
I mean, that's the same thing for me. Like, my 99% of my manual invocations of GCC is just to compile code.s right now, so.
I like how lispy this is. That's that's fair. Zoftface says, if the function returns false, how do you get the output of the function? How do you just not do pure functions? Oh, well, welcome to C.
This is a parser too, so there's not going to be a lot of pure functions here because there's all of the parser state going on.
Yeah.
And no, we don't do pure functions in
Where
here
are they?
because otherwise you can't quite return an error and the result. And also, yep.
So when we code-gen an expression, we're generating intermediate representation, which, as you can see, we create an IR direct call, and then down here, we basically code-gen, no, where do we do? We code-gen the expression of the iterator, which is the thing, and then we add function call argument to the call, the argument. That's basically just argument handling. And finally, we insert the call instruction. So the call instruction, when we call IR insert, you see it inserts into the codegen context. The codegen context is a parameter, pointer parameter that can be altered, which is often how functions work in C when they have multiple return values or complex return values, because you can't do tuples.
You can see that quite prominently in the interpreter I'm working on right now, the C API.
Yes.
Is that all place? C API is currently commented out, at least the implementation, because I changed everything.
Yes. But the codegen function doesn't really return anything, or codegen expression function. It returns an error if there is one. That's it. Hence the bool.
Yeah.
The side effect of it is that you have now cogened the expression that you passed it into the context, into an IR, and then you keep going. If you can think of another way to do it, I'd love to see a PR or a recommendation even.
Yeah, the other way of doing it is writing it in Haskell. That way would be pure.
Monads.
Yeah.
Just name everything monad, it'll fix it. What is happening? Typedef struct
What is
value, some type value, more thingies result.
You can return a struct from a function, yes, and that is what I'm doing. Not here, I think, but
We do
that's
that.
also, I'm doing that in one place.
I mean, that's
Oh, we are doing that somewhere where we do like address lookup, I think.
yeah, with
Something
the
like
symbol address.
Mm-hmm.
It's a very common pattern, but it's not usable everywhere.
Yeah.
Like if we did that here, what would we return? What goes there except for a bool? Tell me. If we're just generating IR into the context,
yeah.
there's so in this case,
This only has side effects.
I like the suggestion though. I love seeing code because that shows like you're thinking about it. You're not just going, "Hey, that's wrong." You're going, "What if you did this instead?" Which is much easier to, much more approachable.
Still episode 3. So it's gonna take you a week to watch the rest. So
more than if you played it 24/7. Yeah, I should just update everybody. I did a compiler stats like terrible website, and I put in the playlist. There's 7 days of video. That's not even all the work. It's most of the work, but it's not all of it. There's 7 days of video of me working on this compiler.
7 days. It might not sound like. I mean, it is a lot, but it might not sound like as. It might seem like it's less than it actually is, but to put this in perspective, unless all you do is watch the series all day, sure. But if you have other things to do as well, I watched all of Supernatural. I started in I think November last year, and I got done. It took me 6 months or so. Supernatural is 15 seasons, and watching all of it it's like 13 days worth of just episodes.
Wait,
this is 7 days.
I'm over half of
6 months to watch that. It would take someone like me 3 months to watch all of this if I started now.
I didn't know that. Oh no. Oh, I should do the calculation for like It's Always Sunny in Philadelphia.
God.
I can't believe I'm at 7 days of this crap. That's incredible. Oh, to give perspective, that's 168 hours. How many games on Steam do you have 168 hours or more on? I only have like 5.
Oh God.
I know, I played a lot of games as a kid. I still do.
Skyrim and the Anno series, probably. That's about it.
I played Skyrim on the Xbox. What did you say other than Skyrim? I'm sorry, I cut you off.
The Anno series. Like Anno 1404 mostly. Played that a lot.
Are those the trains?
Trains?
Are you saying Anno? A-N-N-O?
Yeah. Yeah.
All I know about that is I feel like I've seen a train on the cover. I literally know nothing about the game.
It's Anno 1800. It's like a series of strategy games, and the main gimmick nowadays is with the names that the numbers, the digits add up to 9. So it's Anno 1800 or Anno 1404. So 1 + 4 + 4 is 9, and that was an accident originally, but they then just kept it going. The first one in the series was 1602. I've never played that. Then 1503. Yeah, 1503 is incredibly complicated. No one gets 1503. Like, I am too stupid to play that game. Then 1701 is fun. 1404 is the first one I ever played. 2070 is also fun. 2205 is a train wreck and a disgrace to the entire series. I refuse to acknowledge that as a game. It is atrocious. And 1800 is like a step back into the right direction, but still not good. The graphics are great, but the game itself is subpar compared to 1404.
I
So
feel you.
And 1800 is the one with the trains that you mentioned.
Okay.
Do nothing but deliver, but like the train's also horrible the way that
It's train logistics.
Yeah, it's horrible because you have a set of streets connecting everything. Suddenly,
And
you also
then-
need for one thing, just one thing, you just need to deliver oil. Trains only deliver oil; they do nothing else. And you need an extra set of train tracks everywhere,
Oh no.
in addition to all of your streets.
That sounds like
If you
Factorio.
haven't been planning your city around that from the start,
Mhm.
well, good luck tearing everything down now.
That's right. Or just restart and do it better.
Jeez.
That's what a lot of those games expect you to do, which is why I have a hard
ranted
time.
about 1800 for a while. I'm 2205, but I'm not gonna.
Everything's looking good here. There's just changes from the error handling, which is fine. Did we get rid of Last Expert? I don't think we ever used it. Yeah.
Yeah, it told like I got an unused warning, so I just yeeted it.
That's perfect. Cast now has braces instead of the terrible F0.
I've also removed the F0, whatever.
It works. That's all I know.
Remove all of them. Maybe there's still some left, but whenever I see one, I just remove it immediately, no matter what I'm doing.
It's a good idea.
It's just kind of certain refactorings that I just apply whenever I encounter them. Well, apparently we have no more instances of that, so that's good.
Hey. Okay, that's much simpler now.
Yeah. Generally, like if you look at the file, it's like, oh, this is code, let's see, but if you look at the parser, it's like 400 lines removed, 200 added.
That's incredible. Okay, Terrific Table 55 says, I'm watching like 5 series at a time. Currently, I'm watching Live Overflow's Binary Exploitation series, his Pwn Island series, nice, your compiler series, and a playlist about algorithms by mostly Sebastian Legg. Nice, that's a good one. Sebastian Legg has some very good visualizations. He's a great, like, visual demonstrator of problems. A lot like 3 Blue 1 Brown, honestly.
I see.
I have 300 hours in DaVinci Resolve and 10k hours in Spotify. Oh no.
Well, I probably have a few thousand hours on YouTube at this point, so that's that.
Yeah, I'm up there.
Terrific Table. All I usually watch is either YouTube or CPP talks or the conferences or just anime. That's most of what I watch.
Oh, and I'm watching Ben Eater's videos, but not really a specific series. Nice. I watched those when I was doing electrical engineering. They're fun. They're great videos. Very informative.
Yeah, and they always remind me why I'm a software engineer, not a hardware engineer.
I've designed in like PCBs and stuff. It's fun. It's fun. Honestly, I could do it. It's like, it's easy.
I can see how it would be fun, but I also really don't want to debug hardware, so I'm not going to do that.
Well, you want to die because they also take 3 weeks to get there and be made. And so yeah, make something, wait 3 weeks, which is just killer, until you get it. And then you get it and it doesn't work and you have to figure out why, even though you did everything a month ago.
So this here, in preparation of like replacing
auto
current implementation of assertions with internal compiler errors, I've replaced all the panic functions with the panic macro. At least all that I could find. I think I've even removed the panic function.
That's a good idea.
Macro now.
In full honesty. Did we remove it? I don't know.
Well, it's in error.c and error.h. We'll get to that.
That's right. That's right.
It's in that order, apparently.
Okay. Mr. Mugume says, until auto router fails, then you want to cry. If you're using auto router, you deserve the failure. That's all I'm going to say. I never use the auto router. Screw the auto router. It's wrong. Terrific Table says, I'm just soldering cables together in the air while inhaling that soldering smoke.
Honestly, if I ever do any hardware stuff, I'll just write a circuit in Verilog and then just generate it.
So I would make a circuit simulation within... Man, I don't even remember what it's called at this point. Is it Sprite or I don't even remember.
I couldn't tell you. I
I
don't
really
know.
don't. It's like, so it's a circuit simulation software where you can put in like a resistor, enter its value, and then
I've
it'll,
seen
and then you
this
can
is yeah,
connect
I've
wires.
seen stuff like that being used before, but I've never used one myself.
And then it like outputs an oscilloscope, basically. You can put oscilloscope probes at any point in the wires and see what it's doing over time. So with an audio amplifier, that's super important because you can actually see how the amplitude changes as you vary the volume and stuff like that. Which is
Just to
just,
remind me, I think if you're interested in like how CPUs work internally, the NAND game, I'm not sure if you know about that, is a
oh, I
pretty
do.
good
I've
thing to go through.
yeah. Yeah. You can make anything with a NAND. Uh I really don't I don't
There
like
we go.
the English
This is
ambiguity.
the fact that again.
I don't like the English ambiguity of when you say an item or a nitum. Those aren't words, but when a word starts with n, we should have a different article, indefinite article.
That's how. Isn't that how like? Wasn't it nuncle originally, and then it got reanalyzed as an uncle or something like that?
Yeah, yes.
I think it was that one.
It might have been Nant. I can't, like Naunt.
Let me
Naunt.
check the etymology of uncle.
You're probably
Also,
right.
this is like this was in the IR pass, so this is now here.
That's what I was going to say. I was like, this all looks familiar. I feel like we've seen this. So this just
Okay,
moved.
so I don't think it was uncle, but it was some other word. I'm pretty sure it's got to happen.
Oh, no.
Yeah, it's got to happen. So this is what was this was stack traces if you scroll up a bit again.
I know.
This is how you get a stack trace in Windows.
I was skipping past it because it's terrifying.
Yes. So what we're doing here is because it is easier to load debug help.dll at runtime than to link against it. So we're doing that. I couldn't get it to link against it, so we're doing this.
Raw. Oh no. Where's print raw?
That's in the if.
Oh.
That. This is something I do all the time. I use goto to avoid code duplication when it's not worth it.
Yeah.
When it's not worth it, refactoring it into a separate function, and when it's not possible because I need to return here. And I can't. First of all, putting 2 lines of code in a separate function is not worth it, and secondly, if one of them is a return, then that doesn't work. So I can't write a separate function to avoid code duplication. I have to use this.
It's true.
Yeah.
Otherwise, you'd have to pass. It'd be a horrible function. You're right. It'd be 2 lines and have 4 parameters.
It would still have to be 2 lines of code because I'd still have to return from this function after calling it. That's
you could just return it.
You can return it if it returns void. I suppose that works sometimes, but it doesn't work if a function has to return a value. In this case, it might work. That is true, but
that's true.
So this is generally a pattern that I use all the time. Have some condition, like a label in an if, and then jump to that if to that label.
No.
You'll see that all over the place. Yeah, get code.
Dword. I love Dword. Dword is my favorite word. It's one of them.
Not just Dword. DWord64.
Mr. Mugu. Yeah, that doesn't.
DWord and DWord64.
Totally makes sense. Dword
Code on
60.
paper and it's Java. Yeah, that reminds me of an exam I had at uni. We had to write Java code on paper. Suffice it to say, I only got halfway done.
See, the problem with me in school is that I switch between 2 mindsets, which is like, I'm going to get everything done before it's even known that it's needed. Like, I ask the teacher every day, like, hey, what are we doing next? Can I get a head start in what we're doing next? And I just constantly do that and stay ahead.
Mm-hmm.
And the teacher really likes you when you do stuff like that. So it helps out when you don't have your homework or something. You're like, yeah, sorry. And they're like, well, you're usually pretty good. I'm sure it's something bad.
I did that with Latin. I had 6 years of Latin in school, and
Oh
pretty
no.
much we were supposed to learn the grammar in across 2 years. I did it in 1 year, and I was done with the entire book after 1.5. To the point where my teacher had to give me extra texts in class.
Yeah.
I
That's
had stuff
awesome.
to translate, and I never did any homework because when she asked me to translate something, I just did it on the fly because I
Exactly.
wasn't. I'm still pretty good at Latin, so that's that.
See, the tests in America are a joke, so you don't actually have to learn anything. That's the cool part. College is different. University, it gets different. But in America, if you're not in college or university, it's like they're not tests of your knowledge.
Yeah,
It's
it's not
just
bad.
it's like remember that thing we talked about 2 weeks ago? What was that somewhat related to? And you're like, horses. And they're like, yeah, that's correct. It's good enough. Like it's not you know what I mean? It's not a
Hmm.
high bar. At least at the
Did
school
you
I
guys
went
get
to.
points just for spelling your name correctly?
So it depends on I mean, I never encountered that. I
Because my
I
English teacher was American and he did that.
it's like I mean if you spelled your own name wrong, you would definitely get points docked off because it
The
shows
thing is,
that
we had to like sometimes he had us correct each other's tests a bit. Like he'd still look at them, obviously, but he'd have us look at them. And I there was this time when I didn't know someone's name and I had to ask him, did they spell it correctly?
that's so funny.
I once someone misspelled a name, so I didn't give him the point.
Oh, it hurts to do, but it's like it's what I was
Mm.
told. I'm just
Yeah,
following orders.
in case you can't tell what the diff is doing here,
It's a
all the
yeah.
error stuff is gone now, yeeted and deleted.
That's what I was thinking. It's just being very
Again, op.c is much worse.
oh no. We're probably just gonna skip it. It works
No,
now.
well,
We've tested it.
oh god. This is
Tur-
IR.c. I've just removed the diagnostics from the that's now in error.c
That's
because
right.
it's also used by the rest of the compiler basically. Oh, this is how you handle how you catch a segfault on Linux with a signal handler, and then you can just in this case it calls ice signal, which is does the same thing as ice, it just removes two more stack frames from the backtrace.
We should fix this. We should call this abrupted.
God.
Abruptly quit. Exited abruptly. Segfault's fine. That was
Even
in the
print the
paper.
address.
There was a whole
Even
paper.
print the address, look at that.
That's pretty pog. What is percentage %LX?
Long hex. X but a long, because normal X
Okay.
is just for ints, I think.
This is my ultimate quip with C. Why is OX not output automatically when you do the hex format? That's
And
like
lit format is
killer.
a way of doing that if you do colon, what's it, hash sign. We have
Yeah.
that in OS. It's used all over the place to print addresses.
Yes, it's beautiful. But this is not.
Maybe it has a way of doing that. I wouldn't know. There's so many printf specifiers, I don't know.
There's a lot these days. Okay, I'm late on chat. Terrific Table says, I do that code on paper. I do that when I have no ideas in school. Oh, God. I'm going to restart. Terrific Table, responding to Mr. Mugume, code on paper. I do that when I have ideas in school so I don't forget them. Then I forget I wrote them on paper. Yeah, I'm the exact opposite of what you just said. I don't do anything because I forget it, and I don't learn because I forget it, or just don't want to read that German lecture 3 more times. That's fair. I think you do learn, whether or not you believe it or not. You gotta learn something. Even just walking down the street, you learn something. It may be it's cold outside and my nose is cold, but you learned something. You know what I mean?
Okay, Mr. Boomis is reading Faust right now, and they're saying if anybody wrote this book today, they would put in a side one. Are you talking about part 2 or part 1? Because if you're saying part 2, then yeah, I agree. Part 2 is something, but part 1 is like fairly normal. I've read Faust 1.
Terrific Table says the tests in my class are chill. That's good. I would guess you're American, but I don't want to assume. They're very lax here. Terrific Table says I'm German. Nice. We had a lot of people from Germany over here, to the point like where we added German language to the like curriculum. There was now classes,
Mhm.
but that changed while I was there. Things are weird. Oh no.
Okay. Op.c.
Oh my.
Just look for a second what it did the diff in op.c.
We okay, I'm scared. We're gonna open it.
Try and make sense of what changed.
This was here. Oh no. This was all here. What? It's just added? Wasn't this all here? Am I insane? We had the Dominator tree, did we not? The fuck? What has
Sure.
happened? Oh no. Oh no.
Look at this.
There. Oh, what?
Yeah, we're in opt-inline global vars.
Obviously, we've removed the Dominator tree implementation from
From
opt-in.
inside that function, exactly.
What is GitHub doing, man? Okay, so
Oh god.
opt-inline global vars now returns bool.
Yeah,
That makes sense. What is all
that's
this?
the change here. Obviously. I mean, can't you tell?
There's only 100 lines in between that don't make any sense.
It's worse. Look at
There's
that. Look at opt-check pure.
what? What? It continues? Git is awesome. Is awesome. You know what I mean? They're not doing too well. What is happening? Why are these not reversed? This is insane. Now we're in opt check pure, and we've removed. Oh no! What is this? So now we're
having a stroke is what it is.
okay. Jesus, this I don't think I could ever understand this.
Yeah.
What is
This
this?
is why I said don't look at the commits, because the first commit is this. This
Yeah,
is
it'd
why
be
I
a
told you not to look at them.
that'd be rough to start with. What is this?
Yeah.
Yeah, we don't free anything anymore. We deleted the function. We added function is not pure instead. Genius diff. Oh god.
And we also, instead of
What?
dominate to not check if a function is pure. Yeah.
Yes.
So what happened here, in case you can't tell, is I rearranged things and also added functions. I moved all the dominator stuff to the top of the file. And somehow this happened. I should have done it in 2 commits, probably.
You'd think Git would have a way to like move blocks within a file around.
Yeah, well, you'd think.
I mean, at this point, they should just show all the red and then all the green. It would be more helpful.
Can't tell what was added. We're now checking for attributes, like, as in we're checking if a function is pure, a leaf function, or no return. And we're doing something, and leaf functions are handled at the back differently in the back end. We currently don't do anything with pure because we can't really do much with it because we first need an interpreter for it, and we also need to have access to the function. And that's what the parser thing is about.
I mean, names are good enough. But they're not. Avoid iterator invalidation. I wonder why this was added. I mean, this seems like it was just put in here at the last second.
Yeah,
You know what I mean? Almost.
Yeah.
So good. This is looking good. At least this diff is understandable.
Yeah.
We have a little bit at the end, you know? Oh, instead of removing and freeing, we add it to a... yeah, that makes sense.
And yeah.
The
It
rest...
makes sense. Moving it like 5 lines down.
Yeah.
That's what we're actually calling remove.
Yeah. It's true. We now no longer optimize function. The hell?
Yeah, optimized function is no longer a thing. We just do that in the main loop for each function. We just loop over all functions in the main loop.
Oh, nice. It is actually no longer a thing.
Yes, because we also
I just
now
figured Git was freaking out.
we have optimizations that are per function and global optimizations, and we also rerun the global optimizations now. So that's why.
Ooh, very nice. I
You
see.
can tell at the very bottom, it's a do while, and you have the while at the very bottom there.
Oh, okay. Okay. This really messes with me. So for each putter, function, for every function, build and prune a dominator tree, reorder its blocks, while we can still do stuff like const folding and strength reduction, dead code elimination, memory to registers, jump threading, tail call elimination, and inline comparisons, then build and prune the dominator tree again, and reorder the blocks again, right?
Yeah, basically, because an optimization might enable further optimizations. For instance, if you inline comparisons, that means some values might, oh, well, no, that's a bad example. But if, for instance, if we optimize something away because it's unused, then other values might end up unused as well, or stuff like that.
So then we get out of here once.
Especially if we, a good example of that is the mem to reg pass. If we do that, then that eliminates the need for some local variables, and then the DCE pass removes them because they're not used anymore.
That's true. That's true. So once we apply all the optimizations we think we can do, we free the DOM info, and then that exits this inner for each. Oh no, yeah. Then okay. So then we exit this do while, free the DOM info, and then go to the next putter, iterate in the vector.
Yes, and once we're done with all of that, we go to the while of the outer do loop and do some more optimizations. That's all the way at the bottom.
Okay, yep. And then okay, yeah. So then we fall through to here. We get
Really
after
cool, isn't it?
So after every function is handled, then we check that, oh man, global optimizations, cross function.
Yeah.
And then if those change anything,
And we do everything all over again.
Oh my god.
Yes.
That's cool. That's impressive. I like this little, it's not little, but I like this control flow. It hurts my head a little bit, but it's such a nice way to do it. Like if you told me to write this in C, like if you described this control flow on paper, it would be more complicated than this.
What do you mean if I told you to write this is C?
That's what I'm saying. You wrote a really cool way to do it. I wouldn't come up with this. My brain breaks when by putting both optimizations in the do and the while. It's very cool to do that. How you swap back and forth between two.
I didn't come up with that. I've seen that before, just so you know.
Right. I mean, I didn't come up with for loops or while loops.
In the condition of the while.
That's cool. It's cool. I like the organization of it. Terrific table 50. Go ahead.
No. Continue.
Okay, terrific table 55. There's a reason why my biggest C project was 3 files and 400 lines big, and my biggest embedded C++ project is 2,000 lines and 5 files big. 2,000 lines total between the 5 files, or 2,000 lines each?
That would be 2,000 lines each.
That's reasonable, I guess.
Yeah.
But 2,000 total.
You do a clock.
Oh yeah, not WC.
Okay.
Not Toke. Not WC. Streama. I'm gonna do the same thing. I'm just curious if we get the same results.
Right.
There we go. What'd you get?
I got 9,000 lines of code, almost 10,000 lines of code in total, 7,800 lines of C, 1,000 lines of headers.
Yeah, we're almost exactly the same.
Same thing, more or less, yeah.
Very cool.
Yeah, lines of code is exactly the same, 7,821.
And this has been a while. This has been 4 months, 5 months. I don't even know how long at this point. Where was I?
A while. Currently also have 580 lines of tech.
I like that we have like more Emacs Lisp than org mode, which is like the README documentation. Like,
God.
Yeah, it's more important to have editor support than to actually have user documentation. I mean, who really uses a compiler that isn't a developer? Is a fair point.
Yeah, see, that's why I say we should just call it ir.c and ir.h. No? I mean, we do have ir.c and ir.h now, actually, in the IR backend. So that's that.
Oh no.
What is it? Oh, this is the parser. This is the actual parser. It's basically the same thing as in CodeGen, just error handling everyone.
Yes.
Lex doesn't fail anymore. It can only ice.
Which makes a lot of sense. Because why are we trying to lex when there's an empty file or from a null string? Or that's definitely like a developer programming error. Lex.
Similarly, Lex extend only calls Lex, so it can't fail anymore either.
Oh yeah, this was for binary operators. That's right. That's right.
I don't think it's being used. It's commented out right now because it's unused. I didn't want to delete it, but it's unused. I even wrote currently unused. So if you can't tell from the formatting, the entire thing is commented out right now.
That's right.
I didn't want to delete it because maybe we'll need it, but
I don't think we do.
Right now.
Because what happened was I wrote this, and then it didn't work, and then I'm remembering now. I'm serious. And then I changed the lex function itself to this, where it does like a *C spin at the end. So it'll actually skip to the next delimiter, which means an operator, it'll like eat.
I would have thought that putting operator passing all in the same place would make things simpler.
Right? Right? It's crazy. It's crazy how much like up there when we loop over everything, this looks simpler and it is simpler, but it's something like all the optimizations are in one place with this crazy control flow going back and forth, but it produces optimized programs and there's no infinite loops. It's amazing.
Yep. So long as you make sure that there's always progress, like every optimization either has to ensure that there's progress or return false. Otherwise, you could end up with infinite loops if you do it poorly.
Yes. Translation, we will end up with infinite code loops as we develop the compiler, and we'll fix them.
That happens.
Okay, the infinite loops in Light are not as... nothing's as bad as that. It literally allocated 16 gigabytes, all of my memory, and then I couldn't move my mouse. My screens were frozen. And guess what?
That happened to me with ClangD when I was editing format in LenserOS. It allocated 100 gigs of memory, 40 of that is swap space. My desktop environment was on the swap. Yeah, good luck trying to get anything to do. I tried to turn off the swap. The OOM killer killed swap off. I couldn't turn off the swap because the OOM killer killed the program that was supposed to turn off the swap.
That's so funny.
And I turned up the swap so the OOM killer would kill ClangD instead, but it was too stupid for that. So I had to reboot. Kill it with btop or something.
Doesn't C have immediate evaluation, so stuff like foo or hello both get evaluated, even if foo is truthy? No.
It's lazy evaluation, so hello would only get evaluated if foo is true. That is... So in this case, we might want to use like... Well,
I think it'd be fine.
There's like... You have to benchmark this for like a large program to see which is better, like... logical or bitwise OR here. There's definitely a case for that. That you might want to try all optimizations on every pass instead of rebuilding the dominator tree over and over and over and over again, even if one thing changes. There's definitely a case for that, but you'd have to benchmark which one is better, and right now I don't think it matters. That is a reason why you might want to use a bitwise OR instead, so that everything gets evaluated every time.
I see the point. So all of these don't get run if one of them fails?
Yeah. If one of them succeeds, the rest
That's
of
right.
them run.
That's right. So we do one optimization, rebuild, keep going. Which seems like the best way to do things, right?
Well, we're rebuilding the dominated tree every time. That's a bit... I mean, depends on how expensive that is.
It shouldn't be.
Again, I don't see a point in optimizing this right now, so long as it's not slow.
I agree.
Surely it doesn't really help much. So if we ever get to the point where compiling a file takes 10 minutes, or well, hopefully not, but or 10 seconds, and 80% of CPU time is in that loop, then we know that we need to try something else. But until then, I think we're good.
Yes. Zoftface says, "Oh, really? Time to go simplify some code." Okay. I don't know. Yes.
Yeah, it's
Yes.
guaranteed by the language that if the left-hand side of the OR operator is true, the right-hand side will not get evaluated. And the same thing, the converse actually is true for AND.
That's why you can do things like if not pointer or dereferenced
Yeah.
pointer thing.
Exactly, that's a pretty common thing.
Yes. It's not what we're doing here, but it's close. Not pointer. Because you can dereference it as long as it's that one.
Yep.
Yep. Just shorter because no longer returning anything. Explicit returns, all fine.
Yeah, this is next, so we've already looked at
I was already here. Thank you.
Oh, there we go. This is now a bit simpler. If you scroll down a bit.
This may be slightly more simpler. Terrific Table says, oh god. I've tried creating a new project with the exact same code, just only using printf, and it worked fine until I restarted my PC. Then I got the same problem again. Oh no. That's some environment stuff.
Then again, I say that all the time, so that's that.
And then he says, oh, another nice thing about my PC is I can play MW2 on the highest graphics settings without any problems, but when my brother wants to play Roblox with me, my PC crashes after 5 minutes. That's Roblox's fault. That's not on you, brother.
Oh, God.
Roblox is built on Lua.
Roblox crashing your PC, then there's something going wrong somewhere, and don't think it's on Roblox if Roblox can crash your entire PC.
I mean, it's Lua. But
okay, fair enough.
It's written by the users. So
okay.
Custom game modes,
Fair
you have to download their custom Lua.
Yeah.
They just do it loops all over the place. And then they're like, why is it laggy?
Put a fork bomb in a Roblox mod and see what happens.
So Lex expect now.
Yeah.
Okay. We used to have a very complicated expect. We no longer have that. It now just returns bool. And then there's another out parameter, which we could probably do in the Doxygen comments with param out.
Yeah, I typically, if you look at my interpreter, I do use Doxygen, but this is an internal function, so I didn't do that here. And I sometimes just don't bother with it. I was refactoring like
everything.
The error handling all over the place. I didn't really want to do that.
Oh yeah, it's bike shedding for sure. If done equals true, false. Yes, so this basically checks if the pointer is not null, aka whoever called expect wants the done bool because it needs to check it, then it sets that.
And here, this might not be true because we might be able to get data from the passing state. If we get the location from the state, we can put it here. So right now, this prints just a dummy because issue diagnostic needs two things in order to print a location. It needs the source code of the file, and it needs the actual location. Currently, we're only storing the source code in, I think, the passing context.
Yes, the parsing state only has it's basically the current token, and that's it, the beginning end. Yeah. Okay. Man, remember all this terribleness? Ugh. Okay. Parse get type now returns a bool instead of an error, just more error handling. I'm going to trust.
The reason why some of these don't have no discard is because if no discard is already in the header, then we don't need it again here.
Nice, because this is the C.
Mm-hmm.
Perfect. And the header's coming up. Thanks for that. Thank you.
It's not an error, it's just unnecessary.
If not may fail, error at return. Okay.
So this is basically sometimes we allow them to fail.
Oh yeah.
But sometimes they're not supposed to fail, and when they're not supposed to fail, we want to print the error. But we don't want to print the error if they're allowed to fail. But we need to print the error here. So that's the thing.
I get it. I like it. That way we don't have to handle it every time. We just pass the bool. Could be an enum, but it really doesn't matter. I'm into the passing char as bool, so the fact we even have bool is probably it's like high tech.
High tech. Yeah, from C99 high tech.
It's true.
Rule I think is C99, isn't it? I'm not wrong about that.
Also, for anyone keeping track, Surrey'd got a new chair. Thanks to your amazing donation. So keep it up. We're gonna get him some new stuff.
Jesus Christ. That's not quite how it works. But all right.
No, that's totally why. It was only because of your guys' donations that he was able to do this.
I somehow doubt that with this chair. Anyway, yes, bool as a type is a C99 thing, so that's that.
It's now enum.
Oh yeah, that is still, yeah. It's not, yeah.
Which is fair. Okay, so this is the stack handler. Lambda parameters. That's a fun one. So that expects no params. Parses lambda body right away. Otherwise, we parse.
I have no idea what this does. I just replaced if expected done with expect. So
you don't know? It's easy.
I can sort of tell what it does, but I don't
like
really
in
want
context.
To look at it. I see, oh god, there's another working result down there. I don't want to look at that anymore.
Stack result, first expression, working result, first expression. So this confused me for a long time, but this.
I wonder why.
Well,
look at that. I wonder why it's confusing.
It's simple.
Yeah, totally. This is totally easier than a recursive descent parser. Totally.
It's not easier, but it's more efficient.
Oh yeah, because recursive descent parsers for complicated languages such as C and C++ are known to overflow all the time, definitely.
When you have infinitely nested functions allowed in the language, it's definitely going to be a problem.
Yes, because there's definitely programs out there that have 10,000 nested functions inside of each other.
Well, we want them to be able to. No, but our parsing state and context is probably big enough where we'd run out of stack pretty fast. At least if I wrote it. I'm sure if you wrote it, it'd be a really good parser.
I think you grossly underestimate how much you can actually put on the stack before it overflows.
See, I do because I used to get stack overflows all the time. Because I would put things on the, like, arrays on the stack.
Yeah, okay, if you put huge arrays on the stack, then yeah, but just don't do that.
That's true. That's true.
And also with the recursive descent parser, you don't have 10,000 copies of the parsing state. You have one parsing state, and the rest is stack frames and local variables.
I mean, that's all we have as well. There's one parsing state struct, and then the parsing context is like the scope, the tree structure. Anyway, these are the three results. Result is passed to like evaluate expression, and it's what is actually returned. And then like, oh god, I went to the wrong spot. I'm good at this, I swear. And then working result is like whatever is currently being parsed into. So like at the beginning when we're parsing 4 plus 4, result is nil, stack result is nil, and then working result just points to the same place result does. So these are equal. And then once we parse something like 4, if there's more parsing to be done, then we may need to use this result and copy it into a child of the result, right? Hear me out. So once result, see it's integer 4. So if there was just a 4, we'd return result and everything would be good. We parsed an integer. But because there's a binary operator, we look ahead for that and we go, oh, this is actually a binary operation. So then it sets result to a plus, and then it makes the left-hand side what we just parsed it in result. And then working result now gets updated to the right-hand side. So now we parse whatever's next into working result, and it's the integer 4, so we end up with 4 plus 4. Incredible, right? And then the stack result, it's just, it's basically a pointer to plus, because when we, for example, if the right-hand side was another binary operation, we would then have to write that result, that binary operation result into the right-hand side, or not if it's a precedence thing. So we need this pointer to keep track of things.
Considering that you're so worried about stack overflows, you like stacks way too much.
I like
It's
implementing
like
them
you
myself.
use them, they can't overflow.
It's true. It can't overflow, but it definitely uses many stacks, like in Light, the 4.2 million const allocations from the parser stacks.
Yeah.
But it doesn't overflow. I understand how ridiculous that is.
Also, if you're honestly so worried about stack size, you know that you can increase the stack size. Fun fact. You
Not
can
if
allocate a new stack and use that.
so. The whole
You
the
can malloc a stack and use that instead. Just malloc a gigabyte and you're good.
the scary part is that works. That's what I hate.
Yeah.
It's I like to do is like keep it minimal and simple, which arguably that is simpler,
Yeah,
but
that
it's
graphic is
not minimal.
definitely more simple.
It's minimal for sure, representing how to parse
I mean,
like
it's
4 plus
minimal, but
4
I
with
wouldn't
3
call it
pointers.
simple. This is too many arrows to be called simple.
That's fair. I mean, this arrow doesn't even need to be there, and it confuses a lot of things. Most things are just straight down. Da-da-da-da-da-da.
Box also doesn't help, I think. It just makes it seem like there's more stuff.
This box.
Yeah.
Well, then that's the result now. It includes
Yeah.
all of this.
Oh no, it's worse than I thought. Okay. Oh no.
Yeah, see,
Okay.
the integer 4 was the result. Now it's plus integer 4 on the left and working result on the right, which is to be parsed, basically. And then it gets parsed.
The way I do this, I pass expression just passes the left-hand side, then it sees an operator, then it calls itself recursively to pass the right-hand side,
And that,
and then you
he-
combine the.
here's the cool thing. If you rename your parameters in your function, it will match this exactly. Did you know that? It'll match this control flow. Because you'll
Also,
parse
right?
4, you'll get the result 4, and then you'll find a binary operator and you'll call yourself, but this time with a new result, aka this plus, right? The plus with the thing on the left-hand side, or you'll just call it with like the stack frame
Yeah,
of 4.
I see. So basically, what you're doing is you're using a separate stack, whereas I just use the call stack.
Yes, that's exactly right. Which arguably is smarter.
You can tell that I like using the call stack also by the fact that I have stuff like temp set, which sets a value until the end of the scope, which only makes sense if you're going to call all the stuff recursively.
That's true. That's
It's
terrifying.
using the call stack to store a value and reset it. So you have a stack of basically values of whether we're in a loop or not currently, or contexts that are just on the call stack.
True. I came from Lisp where it's like expected that you call 1800 nested lambdas.
Yes, I can tell.
Okay, so now in the parser, handle the if else body. Oh, by the way, which part of the control flow we're in? This
I
is
have no idea.
we've parsed 4. We're in this arrow here. So we've parsed 4 and we've done something like for example, we check ahead for a binary operator, result gets replaced and a stack gets made. Then when we're done parsing the right hand side, we come here and go, oh, we can actually pop this stack now when we're done. Like stack result, where is it? Pop stack. I don't even know. Stack equals stack parent, and that's what we call it. So that's where this stack gets removed in this step, which is it's complicated, but it is.
The thing is also
It does
this is
work.
really more of a like LR parser or whatever it's called. I'm not perfectly familiar with theory in that regard. What's like an LL parser, an LALR parser, and all of that. But it looks a lot more like that, where you have like a table-based approach, basically, and those are typically machine-generated because they're painful to write.
I see. I am I'm the machine.
Yeah, like there's not a lot of people writing LR parsers by hand.
Well, welcome to welcome to Lenzer's channel. How may I help you? We're gonna write everything by hand from scratch for no reason. It is true though. That is kind of the motto of the channel. Parse type. Okay. Nothing changed. We just return a bool. Everything's fine. Also, we no longer need the expect crap. I'm assuming we can still parse types. Did we test? Did we test like the external?
No, I didn't test much. I only tested factorial, I think.
Okay, we're going to do it while I see it.
I only broke the parser in one place and I fixed that. That was that missing knot we talked about.
That's true.
There was one missing knot in the entire file and that screwed everything over.
Examples. What is it? External?
I think it's does external even work at the moment?
It should. It worked. Almost all of them worked. Even arrays worked. Now, right? I guess some.
What the hell is DLL? Oh god, it's like the backtrace thing. Don't worry about that.
Yeah, I was like, I'm not worried about that.
I see DLL input. I like a PESD immediately.
It says attribute ignored, which is terrifying.
Yeah.
Yeah. I don't know why I think that's so funny.
So does it print A? That's the question.
It looks like it will.
At first glance, it looks about right.
Yeah. There's no nulls in here.
That's good. That's always good.
Hey!
Hey, there we go. Okay, I somehow didn't break it. Ow. I mean, I did, but then I fixed it. I didn't break this part of it, I suppose.
That's right. That's right. First time chat from New Duck. Heyo. What's up, New Duck? How's it going? Thanks for tuning in. We're merging a PR that has to do with optimizations and diagnostics. How are you?
1 hour in, I told you we'd be looking at this for 2 hours. I mean, we're only 1 hour in, but still close enough.
That's about 3 minutes of work.
God.
New Duck says, I'm also programming, but not in pure C. What are you programming in? What are you programming? What kind of program? What are you making? What's shaking bacon? Lex Advanced no longer errors. That's nice.
Mm-hmm.
Oh no. New Duck said that language that shall not be named.
My condolences.
I'm so sorry, New Duck.
At least use TypeScript.
I know. I mean, Richard Stallman himself disowned JavaScript and said it was the reason that the internet is not free anymore. Which it was a bold statement, but he's kind of right. If you listen to him.
Mm.
You have to listen to him. Just listen to his full 20-minute talk on what he wants to see in Emacs going forward. And he actually has a lot of good points. I mean, he's also an old man and is kind of stubborn. He's RMS, you know what I mean? He's Richard Stallman. He's himself.
Yes.
He's proven it. But
really, I never would have figured that he was himself.
He's stubborn in that way, is what I mean. He's proven himself to be like that guy.
Definitely.
But if you listen through all that stuff, he does have some good points, which is like in the 90s, JavaScript was introduced so that companies can control what is on the user's screen. And so that the user can no longer control what's on their screen, which is a removal of freedom. Which is like, you can't argue that very much. That's very true. And CSS only furthered that problem. It should be user-based CSS, user-based JavaScript, and then HTML only.
Everyone wants to write CSS and JavaScript themselves.
Well, here's the thing. OSs could provide their own default themes, like they already do.
I mean, I suppose. For every website, though.
I mean, every browser has default tags.
I mean, I suppose, yeah. The web is a mess in general. Let's just agree that it's just a mess, and it's a wonder that it's not falling apart and going up in flames.
Yes.
There's not a single part about it that is not somehow scuffed.
It's true. The character 5 plus 4 plus the string of 3. Good luck. New Duck says, but you're using JavaScript right now. Horror. It's true. It's sad. There's just
JavaScript, one thing. And there's URIs. HTML is a pain to parse, and the HTML parser is one of the most horrible things in existence. Normal parsers report syntax errors. HTML parsers
Keep
ignore
going.
syntax errors and just make stuff up on the fly. You can remove end tags from a HTML file and it will still work, more or less, depending on where you remove them. Because the parser will just insert them and say, okay, I know more or less what you meant, I'm just going to do this.
Oh god.
HTML parsers are horrible in that regard. Like,
I
if you
think. Go ahead.
it will find a way to turn whatever garbage you feed to it into something it can display on the screen. That's what a HTML parser does. So yeah, we're doing this now.
Nice. That's much better. New Doug says HTML parsers are not parsers; they are guesstimators.
Something like that, yeah.
Very good. Very good. Let's advance the state. Parse the type. We should like implement an arena allocator.
There's also something that's weird. We expect, and in expect we roll back the state and then we advance past it. Something like that. Because expect like uses the Lexa, but then like undoes whatever it does sometimes. Like we have rollback all over the place.
A little bit, but expect doesn't roll back if it finds what it finds, right?
Yeah. So it's really more consume or try consume than expect is what I usually call this primitive.
Yeah, that would be a more accurate term, I'd say.
Expect is usually when it needs to be this, and if it's not, it's an error.
Which normally that's what it is, and then that's what it's used for. But in this case, we're using it to check that something isn't there. We need like a not expect. So we just say if expect error, but then because we expect and it rolls it back, we have to advance. It's complicated. Yeah, because we parse the. Oh yeah, parse type. So that's why we have to advance. Parse type expects that you're already. It doesn't advance at the beginning. So you have to advance, then call parse type, so that the current token in the state is actually the type we want to parse.
Yeah, it makes sense. Like generally, I used to not do that when I started writing parsers, and I would always mess up horribly. But generally, my invariant for writing functions in the parser is that if a function parses a certain thing, then when it's called, it's on the first token of that thing, and when it's done, it has advanced past the last token of the thing.
That's very good. See, our issue
And
is
if you
that.
do that always, then you don't have problems. It just works.
That's right. That's right. But I think I didn't always do that. I did that half the time with parse type, and then I think
I
the
used
other
to do that
ones.
when I started writing parsers, and I just gave up all the time because I couldn't keep track of what was going on.
Yep. I mean, that's kind of this parser. I've just kind of brute forced it into my head where I know how it works.
You can always rewrite it, you know. It's always an option.
We're going to. That's okay. I have a paper list that I always rewrite, which helps me keep like my goals oriented for the compiler. Right now it says long-term parser code cleanup. That's like the goal. Is clean up all of this code and make it not insane because there's like 8 nested ifs and it's really not ideal.
I mean, if you're ever interested in having a recursive descent parser, I can help with that. Just saying. Just saying.
So what we could do is have options for different parsers
Oh my god.
where we have like a parser subdirectory and then a CMake variable that that like means a subdirectory within the parser subdirectory to use as the parser.
God. I can write a recursive descent parser for this if you're interested, if you can provide me with. I mean, we do have the BNF of the language, sort of, because we did that like a few days ago, a few weeks.
It's
I don't
true.
remember when it was.
It doesn't have like typecasting because I forgot about that.
Yeah, I mean, typecasting isn't even implemented in the backend, so it just only sort of exists.
Yes. New Duck, thank you so much for the
If you want
follow.
the recursive descent parser, I can easily do that. It'll just look the same as the IR parser, just with a different grammar. Because
mean,
all my
it's
parsers look the same.
it's not a bad idea that way, but I feel like I don't know. So what if we used different parsers based on the size of the input program?
I mean, I don't see how different parsing.
Because one of these doesn't Stack Overflow, is my point.
If you can find me a reasonable program that overflows the compiler that overflows the C++ compiler, then I'll agree to that.
I'm
If you
gonna
can find a program in the world that overflows the C++ compiler, because C++ is vastly more complicated than this, and C++ compilers never overflow unless you have an infinite loop in a const expr function or something like that.
but they're
And then it
smart.
won't even Stack Overflow. It will just tell you template instantiation depth exceeded. You have instantiated 1024 recursive templates. Like the compiler will tell you it won't do more than that. But there is a parameter you can pass it to allow more. So, yeah. I got that error recently when I was working on template Lisp. The
That's
template
so good.
instantiation depth exceeded.
It's
An error
it's
you
the
don't
C++
get very
Stack
often.
Overflow.
Yeah, basically the compiler, yeah, the template instantiation code overflowed more or less. Yeah.
Oh no.
Yeah, the only Stack Overflows that you get are like these absurd compile time things. Otherwise, it just doesn't.
I see. New Duck says GCC or Clang though. Oh. I'll let Sorry to answer this one. With silence. That's the answer.
What? Sorry.
It's okay.
Was that a question for me?
Yes.
Oh, if I use GCC or Clang, okay, typically just use GCC because it's the default in my system and I can't be bothered to turn on Clang. But it depends on what I'm doing. Sometimes I might use Clang, especially if I use LVM.
So there's your answer, New Duck. GCC. Clang sucks.
Clang is also great. It depends. I mean, sometimes Clang is better, sometimes GCC. Like with GCC 12, I'm now using GCC because I somehow get the feeling that compilation speed has improved a lot from GCC 11 to GCC 12. Maybe that's just me, but
No, they did a lot.
I think so. So that's why I'm using GCC 12 right now. Clang is also great. And Clang has features that GCC doesn't. Like Clang can be used on Windows instead of MSVC, which I recommend we should do. By the way, just to mention that again. And Clang also has built-in dump struct, which you might be able to use for reflection, which is like a horrible thing to do, but still, because built-in dump struct is const expr now. That's just mind-boggling.
That is. Much better errors.
Yeah.
Okay.
Yeah, again, I would recommend using Clang CL instead of MSVC because that would make a lot of things easy. For instance, we'd not have to specify the type. Oh, actually, I can't write a proper vector contains or vector find or vector find if that's an expression. It's impossible to write that in standard C without statement expressions.
New Duck says MSVC makes me cry.
The code is just very clunky in places.
Not actually, just fuels great rage. Oh, it does. At the same time, it means that people can just download the program and run it. They don't really have to know too much. They can click a green button and it runs. You know what I mean?
If MSVC is the thing they need, then they'd have to figure out how to install Visual Studio. And if you can figure out how to install Visual Studio, that it like
people are scared of the terminal.
There's a checkbox you can tick to install Clang CL. That is all you need to do, and then you need to just and then you need to click on a drop down and say use Clang CL, and that's all there is to it. It is incredibly simple to do.
But it's not the default, is my point. People can't just like open it and it works, which is really important. As far as like the mental.
Yeah, because being able to open it and it just works without reading the README is definitely something that projects I expect to be able to do. That's what the README is for, you know?
I mean, they read the README and it says run CMake, and they're like, oh, okay. And then.
I mean, it should say on Windows, use clang.msvc.
But then Then imagine to use this compiler that you just heard about, you're not really invested in it. Then not only do you have to like download it by git cloning, you have to like generate a build system. Then you have to download a new build system. It'd be killer. Because the default isn't to have CL downloaded. Like, I don't have it downloaded. I'd have to go install it. It's an inconvenience from default. You know what I mean?
It's much more of an inconvenience for the developer to have to support MSVC.
Inconvenience for the developer is worth it in this case.
I disagree.
I value the user's time too much.
I think with this program, it's more like if you want to work on a compiler or use this compiler, then you probably can figure out how to install CL.
I don't like stuff like that because I fail at doing simple stuff all the time, man. I just suck. I suck at some things, you know? And everybody sucks at something. So making it as simple as possible, where even if you suck, it still works. That means that even the people that don't suck, it still works for them too.
But then the code sucks.
That's fine.
Just look at how horrible it is every time we need to use vector contains. It's painful. Or vector findif. It just hurts.
It's not that bad, especially when writing C.
Declare an extra variable, and then it's 3 lines of code instead of 1, all over the place.
That doesn't matter.
An extra variable that's in scope.
See, we have different philosophies. I don't care how long the code is. It could be 8 gigabytes. Doesn't matter. Like, why not have everything spaced out, a line separated? It doesn't matter to me. It's just format. Everything can be on 1 line. I don't care. It's just code. We'll figure it out.
I do put things on 1 line all the time that reduces the number of lines.
I meant like all of it on 1 line. But you're right. Imagine if we didn't have huge storage, everything would be different. I mean, we have relatively small storage for the files that are used. Like, there are 100 gigabyte games, and a terabyte is still seen as large. Which is confusing, kind of backwards. 10 games isn't a lot amount of games. There's many more games than that.
Storage, get a tape drive. Those are like 100 terabytes. Sure, it's going to take you a few years to boot up the game, but still, you can have a 100 terabyte drive, no problem.
Yeah, and it's only 3K for the thing to write and read and write from it.
That's true. You actually need a separate machine probably to write to the tape drive.
You do.
But that I never call with that. That is true.
I've looked into data storage a lot. It's a sad world we live in. Hey, factorial of 5 is still 120. That's good. I'm just doing random tests. Oh, good. Unexpected end of file. There we go.
What are you compiling?
Pointers.
Oh, yeah, I suppose that doesn't work. Interesting.
Because we just have a variable at the end. Oh no.
See, if this were a recursive descent pass, I could figure out very easily what was going wrong. But with this, I can't. I have no idea what's going on.
That's like, okay, listen, I understand what you're on about. But at the same time, I didn't know what intermediate representation was 2 months ago. I put a lot of effort into learning what intermediate representation is, how you can write one, how you wrote one, and how I can understand it, right? It's just a parser on one, right? Can we admit that? It's not that much more complicated. It's just that instead of doing things through the language features, you do them through malloc, basically, on your own stack. But I'm pretty sure you understand more than you think. Red Candy Eater says, hi! Also, Nuduck says, I mean, like, if you have at least 6 versions of Chromium installed on your system at the moment. Probably. I have, yeah. Internet Explorer, Brave. I probably have Firefox. Oh, my stream's crapping out.
Firefox isn't Chromium. Firefox is not Chromium.
That's true. I forget.
The whole point of Firefox that it's not Chromium. One browser that isn't Chromium.
Firefox grew into Chromium. It's not Chromium, but it's basically the same thing. Red Candy Eater says, hi, do you get headaches?
Like, the JavaScript engine is different. Like, Chromium uses V8, Mozilla uses... I think he uses CommonJS or something, I don't know. I need to check, actually.
I'm just laughing at, hi, do you get headaches?
I
don't know why.
SpiderMonkey, that's the JavaScript engine, yeah.
I see.
I mean, CommonJS is used by something. I think Safari uses CommonJS. or
I'm
whatever
so
it's called.
sorry, Red Candy Eater. It's not even funny. I don't know why I'm laughing, but it's just it's making me laugh. How do you get headaches? I don't. I do pretty good. I probably deserve headaches, but I don't get them.
I've been looking at. Oh, this is the parser, but the header.
Yes.
Also, by the way, all of these parser functions should probably just be at the top of parser.c unless you expect other functions to call into the parser from outside. This is a bit, yeah, I think half of these are unnecessary. That was just prototyping.
Yes. So something broke.
Something broke.
What's different semantically? Not source, not token, error. If token, that's literally the same conditional. We're fine.
So you're compiling pointers. Let me see if it works on my Mac. God damn it, I'm in the wrong directory again.
So if token end equals blah, return error. That's fine.
Expect in the file. Okay, fine. Let's see what that is.
Get the location of a token.
Okay.
Mine just says input error.
Input error. That's yeah. The input is because it doesn't have enough information to
Okay.
the file name. Apparently, that's what happens.
What is
This is
happening?
why there's no line. Why it doesn't report the line? It doesn't know where it is. Okay, let's see. Okay, so we are in Lex expect called from parse expression on line 1330. That's what it's erroring,
Parse
and we're hitting any
expression
file
1330.
somehow. 1330. Yeah, that.
Look ahead
That's
for
what it's
function
erroring.
call.
In the call to expect, we're
Yeah, you can't see. This is why I was scared. See, so we can't. We have to check for done here, above here. Because if we're done,
yeah.
then we've created a variable access, and that's the end. So we're good.
All right, then we just what exactly? Hold on. What do we need to do? So
So
we need to. What are we doing now that we need to do differently?
so we are. Okay, hold on. So we have a variable parsed, a variable access at the end of a file. We've parsed that, right? But then when we look ahead using expect, it errors if it's done and there's no more to Lex.
I
But
see.
the end of the file may happen after. So we have to check for the previous parsing. We have to check, we have to get the done bool from Lex.
Ah, okay. Where was that?
Well, it's a parameter to Lex, so maybe something in
my
expect.
God.
I don't know how you rewrote it
Well, one
exactly.
call to expect. It's like, oh my God, there's too many ifs here. So this is in this if. And we only hit that if we hit none of these ifs.
Yes.
So we are in this else. So we need to look before the
Else. Yeah.
So where's the if here? So here. So we don't call expect in here. Like the closest thing is pass base type is the thing that we call.
Right,
Then
but
based
then
on whether that returns true or false, we're either in the if or in the else.
of a
And
recognized
between
symbol,
that
right?
and us passing the variables, there's no call to expect.
So yeah, so a variable access, I can't type, is where the issue is. So where are we? One of these, right here. Right? Nope. Okay. Next. Somewhere.
Some
Where's the look
line
ahead?
1330 was
Oh,
what we
it's
did.
right above
What
here.
the other is.
That's right. Okay.
Basically, the problem is we're calling up, yeah, here expect here, but there's no call to expect before that in this function. There's no direct call.
So working result is set from what? Because that always has to be set. So we have var binary. It's probably just result then. So result is a variable access, which is the symbol of symbol. Where do we get symbol? Oh man. Whee. Okay. Symbol. Node symbol from... Yeah, we're in this else. So when we get the node symbol from buffer of the current token, that means we've already called the parse thing. So we're up here, which means that...
Yeah, that's why I traced it back to. This is the most recent thing we get.
So we advance the
Lex-
state. No integer. We parse base type, but we don't get anything here.
Yeah, this returns false, then we'll land in the else. And that's what we check for variables. Here, that's...
So current token is set from lex advance up here. Then, yeah. Which is how we get symbol. This is why we checked for done before.
Possibly.
Oh, possibly. Oh, it's so good. It's so good. So when we...
how do we check for done here?
I don't know. I'm getting to it.
Check for done in the parser. There's got to be a way to find out if you're at end of file.
You just removed that. What are you talking about? That was the whole PR that we had a discussion about. You made it fail instead, right?
Yeah, because you said so.
No, I didn't. I argued a bunch.
Always check for done and fail if it's done.
I said most of the time, but there are times when we're not. This is horrible.
I asked you whether we should just make it check for done every time, and you said okay.
I figured you were looking at the parser and knew what was happening. I didn't know it was like a blind change.
Any of this.
I thought that was like playing it up for fun. Like, I don't get any of this.
Through the code in detail, this would have taken a few days, I think. I just wanted to replace errors, not refactor the entire parser.
That's fair. Well, that's what you get yourself into. It's called, what do they call those? Like Heisenberg problems? Like you're doing one thing and then it changes this other thing and you have to go fix that, and then it turns out that that's only wrong because this other thing is happening, and then
you can add a parameter to lex expect that tells it not to fail. You can add a may fail to lex expect. That's an option.
That's one option. I like that. That is a solution. So when we advance the state, we are at the end now. So lex advance, if we had a done bool here.
You can also just have lex advance return whether it's done if it has access to that.
It should.
Does it know that somehow? Okay. Lex advance. So how do we check in lex advance whether we're done or not?
Well, it's a string, right? So we're lexing from state current end up to, or into state current, this token. So we use the end of the last token that was lexed as the beginning of the next current token. And then we update the end. I don't think we need this. This is just like a helper, so we don't have to write current all the time when getting the end, by the way. So this is just extra to make this shorter. And then the length we calculate from here. So lex advance would know, okay, what does lex return? If it
doesn't return anything, it returns void.
Okay. Didn't lex at one point have a done bool as a parameter? Where did that go?
I don't think lex ever had one.
Okay, it was probably lex expect that I'm picturing.
Lex expect does still have a done bool, yeah.
So
lex doesn't.
So it doesn't error if we're at the end, so that's good then. So if token end equals nothing, return. So if we're at the end of the file, token end would equal this.
Okay, so this is what we know it. The question is, if we're at the end of the file, do we return true or false? Which one makes more sense?
An enum.
Oh my god.
Well,
with two states is a bool. You're just reinventing bools.
Yeah. It doesn't bother me. It's a specific named. It's a named bool.
I'm gonna do. I can also just write a doxygen comment. Return true if. True if select a token false if we're reached at the end of the source. That's Copilot's suggestion, at least. That makes sense, I suppose.
Okay.
That way.
So if state end, right, is equal to a /0, if we're just returning a bool, what would we do? We just return. What did you just say?
Return
False.
again, same thing. If we reach the end of file, return false.
Okay. End of file. Return false. Cool. I think we're cool. Otherwise, return true, because everything's fine. It's a little confusing. I'm just
We're
doing
only
it.
checking the return value whatever we need it. So,
Okay.
so that's why it's not no discard then.
Yep.
So bool here, and if
And then let's advance.
state end is null, or 0 rather,
Yes.
then we just return false. So actually the easy way to write this is return state end is not equal to null, or 0. So, and in here, that's, where the hell is that? 1180.
Yep.
And do this.
Bool
and do a
done.
bool done is that. And then all the way down there, where the error was.
1330. Somewhere.
Yeah, that was here. We can do if done, just what, return or something?
So here's the thing. I think we need to break, but let me know. Let me check.
Break also works.
Yes. See, okay. Here's another case where we're checking for done manually. That's why it didn't break here. So on line 1401, we're checking token length as 0.
We could have just done this instead of adding a parameter, a return value to Lex advanced then, right?
What is token length? Where is this set? See, I don't think this is right.
You wrote this.
This is literally on the docket. This parser cleanup code. You can't at me for this. I wrote this months ago, and then it's worked so far. So I haven't changed it. It'll get better, I promise. It's gonna get a lot better.
I'm just gonna add if done break here, and that's that.
Yeah, we can even just do if Lex advance break. Like that. If not, right? No, so it returns false if it's at the end.
True, yeah, if not Lex advance, then we break, yeah.
So we need to set done to equal not done. Oh, is there already a bool done?
What?
Why is there a bool? Why? Did I write this? I wrote this. Okay, never mind. I'm dumb. I was like, well, what did I do?
Oh, that's that.
So bool done equals not Lex advance state.
See? Okay, now we're getting closer, but we're getting an unknown symbol error now.
Okay. I guess I still have to add that to here. If done break. So where are we breaking into is probably what's going wrong. Where am I going?
Oh, I forgot the not. My bad. That's...
Did you mean to dereference the pointer?
I know. I thought. Okay, but still, hold on. I hate this.
What have I done?
Turns. Okay. Let's not do that. Let's do this. If that.
I'm confused.
False, return true. If we are at end of file, this returns false. So at end of file is that, and then we can go down to
It's a char
here.
pointer.
If at end of file we break. Okay, let's see if that works.
Okay, I should just...
Still getting unexpected end of file. Maybe it's somewhere else now.
True.
No, it's still in the same place because at end of file is somehow false. Oh, it is. Wait. Yeah, it didn't. Hold on. Oh my god.
So Lex Advance didn't return the right thing.
It didn't work. Is what we're saying basically. Yeah.
Yeah. So, did you do pointer state end or pointer state end? How many dereferences?
Oh my god.
It's a char pointer.
None actually. Okay.
Yeah, that would be that would be an issue. I'm still getting
with 2 pointers. I'm still getting it. Let's try 1. Jesus Christ.
It's a char pointer, so it should be 2.
Okay, with 2 that doesn't help.
No.
Getting the error.
Conversion to D word. Cast between incompatible function types. Not going to worry about that.
Ignore, but that's...
Yep, that's stack trace stuff. It's Windows. Cannot color graph with zero colors. So that's just a warning.
We're getting the same error. That didn't help. Maybe it's somewhere else now.
Okay, yeah, that could
No, it's
be.
still in the same place. It's
So
still in the same place. So somehow that doesn't work.
what does that mean? It's in the same place. So when we expect here is where it's crashing.
Yeah, it's still failing where it was failing earlier. So our
So
check does nothing because somehow it doesn't detect that it's at end of file.
okay, so let's do a new thing then. How did token length work? Suspicion. So it looks like the parsing state has a pointer to a size t, which refers to this token length on the stack. Is that correct? If I'm reading this.
Yeah.
So let's look at the state. Yeah, it has a pointer to size t length. So when we update the state, I'm sure we are also updating this token length right here, which is why we do checks like this. So if token length equals 0, that would mean that we tried to lex and like the cursor was already at the end of the file. There's nothing to lex left, or there's just comments.
So at this point, we don't know that we're at end of file yet, it seems.
Right, so this not lex advance didn't do anything, huh? Which
Didn't
means,
do anything.
so can we print out, man, it's been a while since I like debugged the lexer. Can we just print out whatever this token is? Do I have print token? I'm pretty sure I print token. Okay. And then we can just print state. Oh god, current. So, yeah. I guess that's not going to tell us. How do we tell if there's a, and then we'll
Yeah, I
print
can
f
make a conditional breakpoint, maybe that'll help.
0 null terminated, null terminated.
So we can do this.
Well,
And
that's
here, let's check
genius.
for what's the
Dual debugging. Oh yeah, that's understandable.
state length. Okay, no, end current. Okay, we can try and do
Oh
maybe
my.
state current and then minus context source data. Okay, we can't. What? This is
Invalid
under this
token
is a
pointers.
token. Oh, of course, there's a token. Beginning, we can do this. We get 437. We can then check in here if this is 437.
I have no idea what you're saying.
I'm trying to add a conditional breakpoint right before the Lex advance.
Red Candy Eater says, have you had an anxiety attack before? Felt like you were gonna die and vision darkening dizziness. What a message. Yeah, I have had anxiety attack. Panic attack is what it was called, but yeah, that. We never get null. So we do get null terminated only at the very end. So we are returning false only once. And all the other times returning true from Lex Advance, based on this debug
I see
output.
why it doesn't work, because Lex Advance gives us the number token, so token length is 6. It Lex is the last token. After the call to Lex Advance, it's at end of file, so we'd have to call Lex Advance again or something to figure out that would end of file. That's what's happening. So the call to Lex Advance, Lex is the last token. After that, we are at end of file, but we don't know that yet, because we have just Lex the last token. Then expect tries to keep going and it fails. So we have no way of telling if we're end of file just from that specific Lex advance there.
Interesting. So it doesn't actually give us a null terminated string for number, is what you're saying?
Okay, what I'm saying is we have number is the last token in the file. We
Yes.
call Lex advance, Lex's number, and it doesn't realize that after that it's the end of the file.
Which you think if state end equals null terminator, it would
extra
happen.
white space at the end, and that's not going to work. Or stuff like that.
So if we have a new line at the end, it won't work, for example.
Which I think we do.
So what we have to do is advance.
Skip white space after that, for instance.
So we should say if there's nothing at the end. Oh man. That's fine. So from Lex, what is it? What happens when there's nothing at the end? This is Gigabrain moments. Where are we? There's so much code. We gotta split this up into 2 files. What have I done?
It's not that much code. The R parser is like also like 1,000 lines of code. It's not that much. 1,600 is not a lot.
It is a lot. For what's happening here. It seems like it could be a lot simpler, is what I'm saying. But I built it, so it's bound to be extra complicated. Okay, so token end will not equal /0. We can't rely on that. Which means we'll skip all of this stuff. Yeah, so basically we have beginning and end are equal. And then we skip beginning and end past all comments. And then we check for new line the empty again.
Skip white space after end. That's the problem, I think.
But we do that at the beginning when we Lex.
White space after end. Then this would work the way it is right now. Then you could just check for whether it's at the end.
Okay. I'm on it. I know what to do. End. So this has to equal state end. That's a pointer. End plus equals sure spin of end white space. That'll skip all white space. And then if that equals the empty line character. Honestly, that's not that bad. One libc call.
Discord being stupid again.
Uh-oh.
I'm back. Okay. Where we at?
Simon the Sweet says, hi, still not done with the compiler yet. Can you finish a compiler? Does that happen?
Can you hear me, by the way?
Oh, I can hear you now. How's it going?
Okay. Yeah, Discord crashed, that's why.
RIP. I'm so sorry. I didn't even notice. That's how attentive I am.
So what are we? Have we fixed it now? Or
so I'm pretty sure. So in Lex Advance, we just skip past the white space after the end and then check if that's the end.
That works.
So this, okay, I'm going to add a to-do though, which is this doesn't handle comments at the end.
Oh God. If you have a comment at the end of the file, you've brought that upon yourself, candidly. It doesn't compile then.
It also is just infinite looping. So the break probably isn't correct.
Okay, we need. I told you we need to return.
We can't though.
Something like that.
We might
something.
So look, here's why we break. So you're right. We can't break. We have to get out of this control flow. This is why there's so many nested ifs, by the way.
Just have a go-to then. If you need where do we need to break out to?
We can use a go-to, but we're going to try to avoid it now.
Where do we need to break out to?
There's literally a note. We often need to continue from here. So you can find it.
We often need to continue from here. Okay.
So
go to file.
Did I do this in the wrong spot? I feel like I did this in the wrong spot. That may be the issue.
Okay, let's try this. Actually, I need to add the string thing to Lex Advance.
Okay.
What did you do here? How did you fix that in Lex Advance?
Here, I'll move my screen up there. Where is it? One of these. There we go. Here. I used Sturspin and white space.
Okay, so
Simon the Swede says, I don't even know what a compiler thingy is. I'm just here for the vibes. That's awesome. There are many a
Then
vibe.
press will end. Okay, I see. Interesting. Let's try that. Yeah. Okay, let's try that. Okay, now I am getting an infinite loop. Let's see where it is.
I'm pretty sure it was the break in the wrong spot. At least that's what
Okay,
fixed
we
it for
are
me.
looping in inline comparisons. Interesting. In the optimizer.
Uh-oh.
Interesting.
If not Lex advanced state.
Why
So
are we
instead of
looping in here?
so when we break, I think that's incorrect.
Oh, I think. Okay,
Should be a
hold on.
go-to here.
So if in
So-
instruction point the mid, we continue. We are doing that, so this change is true. So that is right. So why is that a problem?
Parse continue. This is terrible.
You need-
I hate writing this.
After that pass, continue, you need a semicolon because that's a declaration. Next statement is a declaration, so you need a semicolon after the label because see.
What?
Why
Parse
the
continue.
label is, you need a semicolon after the label.
Oh yeah, of course. Type not found colon. Okay. That's beautiful.
We're now getting different errors. That's brilliant.
Yes, we've implemented different solutions.
Okay.
Somehow.
I'm trying to find out why this is looping. That's
So
not...
I'm maybe out of this wrong spot. Where are we? I was trying to. I did add that in the total wrong spot, didn't I?
looping in here. Something is being marked
Yeah, it
as
should be
changed
here.
when in
I'm
fact nothing
insane.
changed. So can we do like this? Okay, go to here.
It's still the same thing.
It's
Type not
not
found.
you. Is it you? Let's see if it's maybe it
So
is
if we
you.
just return,
Not inline comparisons, okay.
what do we do?
Maybe it's...
Yep, that's what happens when you hit
Okay,
that in the browser.
Okay, let's see. Is it you?
So Lex Advance is now freaking out.
Okay, it's not you.
Okay. Why is it freaking out? So type not found colon, that could only be because
Going to redirect this. Okay, it's
here. So when we, yeah, see, here's the problem.
Be this.
So
No, it's not.
it's not that one, it's this one. Okay.
Okay.
So else we look ahead for an index operator, or
so it's you then maybe. Is it you? Might be you.
so we need to look for all this stuff, but we can only call expect if there is another one possible. So that should maybe go there or here.
Ah, interesting.
What'd you find?
Inline global vars somehow thinks that it's inlining a variable. When so change is true even though it should be false because at this point everything has been inlined, I think.
Oh no.
Very interesting. Interesting. Let's go here then. Okay, vars is what? How big are you? There's two things in here for some ungodly reason. Why are they in here? Okay, hold on. There's something wrong with this code then. God. So for each instruction, if it's a store, we do this. Yeah. If it's unoptimizable, blah, blah, blah. We delete the loads, continue.
And if these two things, and then if we fall through from this, oh man.
Oh, change. We need to not just check if we have elements in the vector, but if we have any unoptimizable elements in the vector. So actually, we need to do this in here. Okay. We need to do this in here. Alt.
Okay, and then
Get
this.
here.
I see what I'm doing wrong now. Whoops. Yep, classic.
Might work. Let's try this. It works. Okay.
You fixed it?
Brilliant. Yep, works.
Do you think you can... Okay, when you did the go-to, can you do me a favor and change it just a little bit?
Okay, what do you want?
I want to test... Look, if you look at the screen, can you do something like this? Where instead of expecting this, we put that in the else if, right? So we literally just add this beforehand. Because then that should fall through exactly to where the go-to ends up.
At end of file, we do nothing else if. So instead of that, because that seems kind of weird.
We could do not done.
Do if not done.
And
Expect.
yeah, that should be fine. Something like that.
That is. Let's see if this works.
Okay. Mine still won't work.
That doesn't work.
That doesn't work. What's the error?
That doesn't work. Unexpected end of file is the error.
Okay.
That doesn't work.
Well, there you go. Use the go-to then if it works. I'll work on removing it as best I can. Until then.
I called it at end of file, by the way, because
that's cool.
Is a bit. It doesn't really say much.
Atiof. I mean, it does and it doesn't. It says so little that it doesn't. That it says a lot.
This works now. Do you want me to? I'm gonna.
Yeah, just push it
into the PR.
Yeah.
So we're gonna call this optimizer. There's two bugs in the optimizer and in the parser. Fix bugs. I'm just gonna say fix bugs, and do you want me to commit this properly? I'm gonna commit this properly.
Yeah.
Okay.
It doesn't matter. It's fine.
We're
just gonna merge it right away, as long as it works.
I still need to commit this. So wait a second.
I'm just gonna press merge before you commit. Ultimate self-sabotage.
Tell you when I'm done. Okay.
Yeah.
Wait, what was it? Okay. No. Okay, get lost. Not you. Okay, no. Here. What's it called? It's called.
So this was a function. Okay, here's a cursed idea. If this was a macro.
Progress has been made. A typo.
That could just be a macro. That'd be cursed, but it could.
What could just be a macro?
So remember, we often need to continue from here?
Yep.
That whole section after we often need to continue from here could just be a macro with continue at the end because it's in a loop at the very end. But it doesn't need to continue because it's an ice. So we could just have this entire found block thing be a macro, and then whenever we want to go to here, we could just insert the macro. And then that would let us get rid of all of these nested if-elses.
Jesus Christ.
It would just mean that the resulting code size is gigantic.
It would be easy, yeah. Just add a label and a go-to.
I mean, yeah, we can also do that. But then, okay, we still need some structure if we do that, because we have to check for example, a lambda before we check for a function or a variable declaration.
Oh, this fix in parser. Handle end of file problem, I'm going to call it that.
That's perfect. And then I guess we should try like everything at the end of a file.
There you go. Well,
okay.
With comments, we know that those don't work right now, so let's not try that for now. If you have a comment at the end of the file, then there's something wrong with you, honestly. I mean, sometimes you comment something out, so I suppose you can have that sometimes, but still, at the very end of the file, that's unlikely.
And it's only at the end of a file after a variable access.
Yeah, that's even more unlikely. So, here you go. I've pushed it.
Okay, I've pulled it. What do? I build it again.
But that is probably good. So now try pointers.
So pointer's now compiled, optimized, and I need to go up to code.s. Beautiful. And then run GCC. Hey, hey, hey. That's what we like to see.
So remember how I said it would take us 2 hours to merge this? We are now 2 hours in.
That's true. Way more than 10 minutes of work though. So we're on good schedule.
So I think we're done now. I think we can merge this now.
I agree. I almost don't want to try more things, but I'm gonna try more things.
Same. What is it this time?
Oh, it's the same thing.
What example are you trying to compile?
Oh, arrays. Arrays, my bad.
Okay, probably the same problem.
So what's at the end of arrays?
Okay, I can actually compile arrays and check where it fails. That's easy because like I have an actual, IDE with a debugger that just tells me why it fails.
Int array 2. So it's a dereference.
Yeah, in line 1380. Okay.
Oh god. What have I done?
Interesting.
Yeah. It's the same thing.
Where do we put the thing here? Because there's two calls to expect. Where do we put it? Oh.
So here's the thing. When we look ahead for the function call, if we're at the end of the file, we have to deal with that. This is a very specific case. But then when once again, we found an array. The thing is, you can have an array subscript operator basically, then be reassigned. So this expect is then expecting again. So we have to do the check here.
Yeah, okay, good. Before the colon, before we check for that. Break if we have an
Okay, that didn't
subscript file.
It didn't fix it.
Didn't fix it, really?
Yeah. I thought I knew what was going on. We're at the so dereference. Where's dereference?
So what does arrays even do?
Dereference continue.
We have the 2. So this is after this, I think, array index, right?
Yeah.
And we're after this, and interesting. Somehow failing here. In which expect are we failing though? That's the question.
Put it on a new line.
See where we're failing exactly. If it's the second expect, then I can understand what's going on.
Yes.
It is the first expect that's failing.
Oh, crap. So it thinks it's... Oh, okay. So the at end of file bool didn't get updated. But we called Lex Advance. So we need to... Oh, man.
Call Lex Advance?
So we're already calling it.
That makes sense. Yeah,
Yeah.
Sure. That makes sense.
Okay, well...
See? No, okay. We're not getting this error. Interesting.
And it's saying this thing right here. And it's saying that we have a symbol.
I'm just trying to print out something. I don't actually know if I'm printing a symbol correctly. In like the...
Okay.
So
That may not be correct.
Print something.
So, error unknown symbol. Where even... So that's here?
I'm calling node text. I have no idea if that's right.
That should be right. That should definitely be right. It should give you like symbol, colon, colon, and then the value. So that's a space. How is symbol a space? What did we break? So this is symbol is not a valid variable name. Check for function call or new variable declaration. What line did it say this was on?
17.
It says 17. So that's the first reassignment of int array, which is just the subscript. Did we screw up? Oh, we have to do not Lex Advance, don't we? Did we both do the same thing? So
Right.
I feel like
True.
we should change the return value because we changed this name now.
Yeah, because we only need this here, so that makes sense.
Yeah, so I'm
So
going to remove the other
returns
not.
true, false, returns whether we're at end of file. Huh?
Sure.
That makes sense.
Yep.
This. Still getting unexpected end of file.
Yeah, that didn't work. It's a different error, though.
Is it?
Yeah, remember
Yeah,
we had the
well,
symbol error. So
yeah.
we did change something. At end of file.
Oh, that's not gonna work because we have pass integer, and that internally calls lex advance, and that does something. So this
Okay.
is not the last call to lex advance.
That would definitely be an issue then.
I feel like we could just. Does lex advance have the? If lex advance had access to some sort of global state, it could set whether we have reached end of file every time it's called.
I mean, we could just put like static bool
For
at
now,
end of
sure.
file, which equals false. Oh man, this is horrible.
It's incredibly cursed, but for now that will do. And now it doesn't need to return anything anymore. Would you look at that? This is usually solved the way I usually solve this problem is I have an end of file token.
Yeah. That's not gonna work here.
Really? Think.
At end of file.
Okay,
Please
that
don't
seems
reassign.
that works. There we go. Okay, now it works. Yep. That works.
Oh.
And pointers also still works. Yeah, okay.
Hey.
Good. How are we gonna
Oh, did it?
handle end of file properly?
I didn't
Reload it.
do this.
There we go. That's the commit. I've committed and pushed it.
Awesome.
Ugh.
Awesome. Awesome. Okay, I gotta. This is such a weird way to work. We're like dual debugging. Why are you
Yes.
mad? So, I'm gonna end up with a lot of stashes after this.
Oh no.
Bug fix part 2.
More and more stashes.
I have 5 now. This is all only on your branch too.
Oh no.
This is in your directory.
Right.
I have a whole other directory with more stashes. Okay,
Oh, no.
pull from
Okay,
upstream.
make sure to poll because I've already committed it.
Yes. Okay, so
There we
poly.
go. Reload it.
Arrays. Oh, it worked. Okay, it works. We're good.
Pointer still works, by the way. I've tested it.
Okay.
Okay.
So
We're
now
gonna merge this now. We're gonna go through everything else.
I'm gonna try greatest common denominator again. I'm gonna make sure the simple ones work. Okay, they work. We're good. And these are all optimized, so we're good. Fact of 5 is still 120. That's a big deal.
That's good.
I like how it checks even when there's no CI. It's like, can we merge this? Let's ask CI. Oh, you don't have any. Let us ask anyway. Hey, now it's 15 files changed, 15 commits. It's just balancing things out.
Refresh, yeah, I don't think that's right anymore.
Oh,
my gosh.
okay.
Hold on.
Yeah, I know.
Okay, I
Wait.
need to add like 2 comments.
Yeah. Can you?
There's some work. I can add a comment before the end of file. I'm gonna just write. This is a bit
So cool.
but it's the simplest way of doing it. Simply because we don't have I don't know, a global parser state or something.
We need 2 lines added.
Okay. Add a comment explaining what at end of file is for. Oh, it doesn't explain what it's for. It just explains why it's a global.
That's what it's for.
Okay, now check the lines. Okay. This means we can't. So we need to merge it now. We can't add anything else.
You're correct. We've done it. That's going in the Discord.
Yep.
Eyes. It's beautiful. Okay, I'm just gonna click the button. Okay. Yep. Do it. Click button. Go crazy. We did it. Hooray. Okay, now I need.
did.
Oh.
Now I need to update my main branch.
Open new emails.
Good.
Don't do.
Fetch
I've done
that,
things. What have I done?
Merge that. Push. Okay, good.
On compiler. Merge. So I need to Control XG, Shift FU. That sounded aggressive. Pull a bunch of commits, please. Beautiful.
Here we go.
Okay, now the ultimate test. Hey, okay, we're good. We're good. It's good.
Nice.
It works. Oh my god.
Okay, there we go. Okay, so we're done. It's
The
about 2
suspense.
hours, just like I predicted.
You're right. You were exactly right, basically.
Oh my god. Okay. So, there's 2 things that we wanted to do.
Oh,
that we
no.
could do now. I'm gonna take another look at some of these that are unnecessary.
Yeah, it's fine. The backslashes get me.
Yeah.
Okay.
It's because usually I like them aligned too, but I just use Clang format. But I'm so used to not using Clang format in this project that I just never use Clang format. So that's why the backslash is underlined.
I see. I see.
What was I gonna say? Right, there's 2 things we could do. One would be a bit more painful, and we've done all the painful merging. What the other one might be a bit more fun. So the painful one is actually have references to function structs in direct calls. And the more fun one, at least in my opinion, would be to try and add a backend for the interpreter.
Are you bouncing a ball?
I'm just tapping my finger on the desk.
That's so loud. It's incredibly loud. That's incredible. Oh no.
The
Okay.
mic is too loud, I can turn it down, you know?
I mean, I can turn you down as well. It's just that you're not loud, but the tapping.
I see.
It's a big thud. It's kind of
But
fun
the-
though. It's like a song.
Loud.
That was quiet. That's quieter than your speech. Because how. Yeah, I can barely hear it because of how Discord works.
Interesting. Oh, maybe it's because that's the
Oh.
same desk that the mic is on. So maybe
That-
because of that.
That would definitely be it. My mic is on a fabric box to prevent that. So that when I tap,
see. I see.
it's still
Yeah,
loud.
if I tap over here,
Yeah, that's fine.
probably quieter.
Yeah,
I see what it is. That's probably why my keyboard is so loud too, because it's on the same desk.
definitely that.
My keyboard is loud in general, why it's so loud. The mic. Wait. So yeah.
Okay.
So what are we doing?
I don't know. I'm going to look at direct calls, right? Direct.
That's one option. Again, the other thing you could do is add a backend for the interpreter. That's also an option.
Yes. Yes. That. So we'd have to link with the interpreter because it's a library, right? So we just have some CMake option that includes it
You
or
add
not.
a module and that's it. Add subdirectory and link. That's it.
Yes, but we also want it optional so that the compiler still stands alone. It doesn't depend on the interpreter. It just can use the interpreter if...
I suppose you could do some conditional compilation, but that wouldn't be too complicated.
Yeah, it should just be all in CMake.
Yeah.
So if we get an external function, we make a direct call to the name. Why is this okay? This isn't okay.
No. For this, we need to allocate a function struct and add a bool to the function struct to mark it as external.
The IR function. Okay. Yeah.
IR function needs a name.
So
it doesn't need a name. It needs a bool that checks whether it's external or not.
Oh
I
no.
mean, you could slap it in there, maybe, but that's more for attributes for sure.
It's fine.
Attribute external.
This is
Okay,
gonna...
sure.
Yeah,
Decrement to 26.
thank you. Okay.
Otherwise, you can have an extra U in 32 at the end.
Decrement. There's no other way to do this? This is a mess.
I mean,
Like, if we don't have this, is it fine? What happens?
yeah, but I like having it because that way you need to count every time to figure out how much you have left. And that's kind of scuffed. So the reason why I have this way, you know, okay, I can add 25 more things.
I get it. Okay, I get it. I like it. It's fine. It's good.
That's why it's there.
So attribute external, sure.
Okay, sure. I suppose it's not too wrong. So, and for this, you might want to have a separate function for this that creates an external function in the IR.
That's what I was thinking about. So
Let's see what IR function does. It creates a block and everything, and an external function doesn't have a block. It doesn't contain code. It has nothing.
And this is just a call. But the problem is, okay, so the AST stores just the symbol.
Yeah.
So we're going to have to look up function by name then.
Yeah, what I think we need to do is when in the type. So basically, whenever we pass a call, if we encounter an unknown function, we just save the name like we do right now. But after we're done parsing, after we've done syntactic analysis, we need to do a semantic pass over the AST in the type checker probably, and make sure that a called function exists or is at least declared. We can do that, yeah. And then in the IR, we need to, and in the type checker, we can then just add like quote unquote allocate all the functions or something like that, maybe. And you could just create all the IR functions here or something like that.
Where do we currently call IR function from? We call it in codegen function, right?
Mm-hmm.
Okay, hear me out. What do we need? So this calls IR function. So what if in here, codegen function, we just make it so that if the function is external, like could we pass in a bool here to codegen function? We'd have to look where this is called. But if we can do that, then we could just set the attribute of the function, and or just based on that bool, call two different functions.
Function won't get called if it's external, I hope. Because an external function doesn't have a body. There's nothing to cogen.
Okay, what do we do here? So for a function, we definitely... So this is for node type function. This is like lambdas.
I see.
So where do...
This is another problem, that lambdas, like they don't have a name. We don't currently have named functions. We don't. We only have lambdas.
So in the AST, how would that be shown then? Because we need...
Not at all at the moment. We can't. We can't do this if we have a lambda and a variable. In that case, it would just it would have to be an indirect call every time. It couldn't be a direct call. It'd have to be, right now it is an indirect call because of that. So direct calls to named functions that aren't external, we need a separate syntax probably. Would be at least what I would suggest.
What if
that's just and give it a name that's immutable?
We just have an optional name in the function AST. Yeah?
How would you differentiate between declaring a variable of function pointer type or function type and that has an initializer and a function with a fixed name?
What are you saying? What?
Basically, currently what we have is we have, if we go to like something. So
Yep.
fact is a variable that has an initializer that is the function, right?
Yes. That's
If you just assign the name fact to the lambda, then what if you reassign fact the variable?
right. Yes, that's bad.
That is the problem. So we can only assign the name fact to the lambda if we somehow make sure that fact is never reassigned.
That's totally doable.
That's what I mean with a separate syntax, because I would recommend introducing a separate syntax for this rather than trying to check if fact is ever reassigned anywhere, because that's going to be painful.
I mean, it's not that insane.
Well, you have to know whether fact is.
We just basically during type checking, we just go
Yeah, but
whenever
it's still
there's
a bit weird that if you assign to a variable only once, it has different semantics, whereas if you assign to it multiple times, it's like it's a bit strange.
it is strange, but it would also allow us to optimize like functions that look like the other type. So you could like
Yeah.
forward declare fact integer, which returns an integer or whatever. Right?
Then we have forward declarations. That's also scuffed. Like, do we really want forward declarations in 2022?
No. But what you could do is like create a variable and then assign it, and if it's only assigned once, then we can know, oh, it's magically optimized.
The problem is, what if it's a global variable that has an initializer, so it's assigned a function, but it's a global variable, and then we want to reassign it from a different translation unit eventually?
Okay. So you're saying if we compile like two separate things that we want to link together, that's what translation units have to do.
That we should be able to both create a variable and assign a function to it, and create a function with a name, and those two we need to be able to do both of these things whenever we choose to.
Separately. Okay, I get you.
So that one thing always defaults to the other.
So
Because
sometimes you have a function which you want to give a name like this, right? We'll call this the basic case. Function with name that shouldn't be reassignable.
Mm-hmm.
But we also have the case of like bar, where we have a function with no initializer syntax. Right?
No initializer, or perhaps an initializer, and we want to reassign it later.
Right. So it could say this equals the integer and integer thing.
Yeah, that's actually the syntax I would suggest. Use the old style. If it's the old style function syntax, the one that we have with bar right now, then it's a variable. If it's the new abbreviated syntax, it's a function and not reassignable. That's what I would suggest, actually.
Let's do that. That sounds totally reasonable. Because if you define a function like this, all you'd have to do to make it assignable is copy this. And then
copy this, and eventually, if we have type inference, you won't even have to copy it. You just need like an equal sign or something, maybe, or an abbreviated syntax or whatever.
Let's try it. Yeah.
Yeah, actually, you could, if you want a variable, you could just write maybe like foo : equals, and then put the type on the right-hand side of the equal sign.
Like this.
And have type inference. Yeah, that's probably how we do it in the end if we wanted a variable or function type.
Yes. Okay. But for now, it's going to look like this.
Now you'd have to duplicate the type, but that we can fix that later. But this way we have a semantic difference between two different syntaxes, and then there's actually a reason for both of them to exist.
So, I just love watching Tree Sitter. So what we have to do is when this syntax occurs, if we have this name symbol in the AST added, and then whenever we're code genning, if this name symbol is here, we go, okay, this is like or we could just have like a flat list of these that can't be reassigned.
Well, we need to do one more thing. If we have this syntax, then foo is not a variable. It's a function. So we have to somehow not declare foo as a variable.
Why?
Only declare a function.
It's fine if it's a variable. You still should access it.
You can reassign to variables. You can't reassign to foo. I mean, you can also introduce the concept
That's
of
type checking.
That would also work. But you somehow need to know that an assignment to foo is invalid now.
Yeah. So in the type checker, what we can do, we're looping over the AST, right? So when we type check a function, then we can just, this is going to be it's going to be kind of complicated. But when we type check a function, if it has an optional name symbol, we can either add it to a flat list or just add the name symbol to a flat list that's like in the parsing state or whatever. Just somehow have a list of these names, right? And then we have to make sure that whenever those are, like, they can't be reassigned. Those are variables that are immutable.
So either we need immutable variables or not treat them as variables. Either way works.
Yes. And if we don't treat them as variables, it's going to make, like, calling them really hard.
I mean, you can call extern functions just fine.
I mean, they're variables.
Variables.
Are they not?
I hope not.
I'm pretty sure they're variables. They're just, yeah, they're treated exactly the same as variables, IRC.
Okay, fine. Then make them immutable variables. I suppose that works.
External function. Let's find it. So
Are
when
you
we
checking any word that you can't assign to an external function?
Probably not, unless it's in the type checker. External
Okay.
function. So when we have function call, we check for it, but that's it. So no, we're not.
Right. Brilliant.
Again, we should probably do that. We should probably handle that. So in a reassignment, we just ensure that the left-hand side and the right-hand side are equal values.
Oh god, okay.
Which makes
checking
sense.
if the left-hand side is an L value, because otherwise you can assign to 4.
Well, no.
Right, so we can assign to 4.
No, because a variable reassignment only gets generated for variables.
Okay, so
And the
you know
parser
it's an L
spits
value.
that out.
So you know the left-hand side is an L value because you get here.
Yeah.
Right.
Otherwise, the
Oh,
parser would spit it out.
Okay, good. That's good. So at least we can't reassign integer literals. That's a start. That's a start. Good. So yeah, if external functions are variables, then yeah, sure, functions should be variables too. I suppose that makes some measure of sense in some way.
Mokuteki, thank you so much for the follow. I totally missed it earlier, my bad. Hopefully you're still sticking around, having fun. Okay, yeah, so... Yeah, we'll just make it all insane. Everything's a variable, why not?
Oh god, this is Unix, but instead of files, it's variables.
Yes. So when...
Variable. An external symbol is a variable. A function is a variable. A variable is a variable. Okay, that would make sense, but...
We're going to add like a to-do, ensure type,
Yes.
I guess this has to be down here. Ensure type of left-hand side is actually assignable, like not an external function, lol. Okay, add a little bit of a to-do to variable reassignment. That's probably a good idea. Other than that, so when we are code-genning a function, we're back here. We just call, this is type checking. Okay, well, let's check this out. So when type checking a function, we would say, like, if it has a name, we have to then... Okay, I know what to do. I don't know if you're going to like it.
Oh god. What?
Every time there's a reassignment, we should check a list that the type checker itself builds of immutable or unassignable, unreassignable variables.
Right. How about you add a flag to a variable that marks it as unassignable, or as const? You could check is this thing const or not.
So but yes. But then so that would happen in CodeGen then, not in the type checker. So in CodeGen,
You can, in the parser, when you pass a function, you make it a variable node, and you mark that variable node as immutable. You add a bool to the node type, the variable node, that says const or not const or whatever. And then you can use that in the type check. You can just say, is this variable node const? Because I'm assuming we're using the node.
we have expression children as the AST node, yes. So we have an AST node which refers to a variable access, or a dereference of a variable access.
Can we get the actual variable from that?
So there's some complicated code for that up here. Where is that? Did we get rid of that? We may have gotten rid of that somehow. So there's in dereference, right? We have to, that might be in cogen dereference.
Oh my god, okay.
Yeah, definitely not. Okay, so there was some crazy stuff where we had to get yeah, here it is. Look at that.
Jeez.
So we say,
Wow.
just iterate into the left-hand side. Just keep going left-hand side, left-hand side, left-hand side until we get to variable access. And if it's not there, we say, hey, this doesn't work.
Oh.
You can't do this. So this should probably be the type checker doing this.
Probably.
Which is probably the whole issue. So when this happens, we get the variable access in iterator, and then we use it for things like, I don't even know.
Do we even use it?
That's funny. We may not use it anymore. It may just be for this assert.
Hey, then put it in the type
Oh, no.
checker if I'm using it here. Or we're
Here.
using it there.
Symbol
Because we
to
need,
address. That makes sense, actually.
that does. So we need the symbol. So we need this here. But if we also did this, so
In here.
but then a
Yeah.
variable access doesn't. All it has is a name.
Why does it have a name? Okay, that's one more thing we need to change. Right. I also mentioned that a while back.
Then that's a DAG, right?
The way that, for instance, a local variable should work is a local variable is just a reference to the stack allocation. And when you have a store, you can store to either a stack allocation or a global variable or whatever. So there was some way about how it's handled that's weird. Like if you assign to a variable, it shouldn't store the name. It should store the actual node that's being assigned to. So basically, you shouldn't really use names. Names.
But then
should
that's a
only be used
DAG.
to figure
So
out
you're describing
what
not an
node-
AST.
Sorry, come again.
So I totally agree with you, but you're describing a directed acyclic graph then. It's no longer a tree, an abstract syntax tree.
It's never a tree. It's always I've never seen an AST that's just a tree and not a directed acyclic graph.
Well, welcome to your first AST.
A tree, but it's a graph. It's always a directed acyclic graph.
Only in your experience, apparently. But you have not yet to see one because you're seeing one now. This AST is just AST. There's nothing else in it. It's not
Typically,
weird.
yeah,
It's normal. That's why it's called an AST and there's a whole name for it, bud. I promise. It's not insane.
Typically, if you look at like ASTs for C and C++ compilers, you have cross references all over the place.
You mean those 40 to 50-year-old languages are optimized? That's crazy. They like use data structures that are more complex and harder to
Pretty
use.
much whenever I write a parser, I also do that. Like if I have a call, the call has a reference to the node that's the function.
Which is insanity. To me, that's insane. It's like, that's not a tree.
Call by name is very... Yeah, it isn't. That's the point. It's not a tree. It's called a tree, but no one cares about names. It's
You
just-
like graph
you
theory
can
too
call
much.
it EST, but it's not a tree. It really is not a tree.
I think it's just you like graph theory too much. You're engrossed.
I don't even like graph theory.
Well, you're telling me to use a graph.
Yeah,
I'm
because
just
it's
saying.
natural. Like I've never written an AST that was not what I don't use the term directed acyclic graph because it's just
Because you like
it's
being
just
incorrect.
extra terminology. It's just an AST. An AST is just that.
It's not. Those are two different things. We use an AST. We don't use a DAG.
Everyone calls it an AST.
They don't. They call it a DAG when it's a DAG.
Clang calls it an AST.
Well, Clang
It's a DAG.
sucks. They make up names for everything. They name something value. That's how you know they. What a value. Yeah, it's a value.
An AST. Like it's just they're called an AST.
But it's not just an AST. This is just an AST. That's my point. I understand, even if the naming is wrong or different or commonly used to mean both things. It's not commonly used to mean both things here. This is an AST.
Well, so when you say AST, you mean
AST.
just a tree.
Yeah, just the actual.
Most people say AST, they mean a graph.
Well, they're wrong. So if they're okay with being wrong all the time, that's on them. It's like, oh, I
No
want to
one
say
will-
banana, but I
nothing
mean
is
orange.
anymore. No one writes ASTs like that are pure.
Well,
Because they suck. You can tell
sure.
why they suck because now we have to rework them because things don't work too well.
Only because,
That's why
okay, if I wrote
I mean.
this, if I continued to write the compiler with no PRs, then your style of programming that has been imbued into it, which I'm okay with, I love it. It's just different. I wouldn't have written this and having only an AST would be fine. But your brain, you're assuming that there's a DAG. So when there's no DAG, because I don't write that code style, I write a different way, then the code that you write then requires us to go back and change my code, which had a different original intention. So it's not like, oh, ASTs never work. Now we have to get rid of it because they suck, because, oh, we need a DAG. No, you expected a DAG when writing the code. We merged the code, and now we need to move forward from here, which means we actually need to write a little bit of a DAG to handle your code that expects a DAG. But if your code expected an AST, or if I wrote it and it expected the AST, everything would be fine.
Forward reference as well with just using a tree that has no backward references, no cross references.
Listen,
I have no idea how to do that.
If you want to go back 4 months and change what I wrote, you can. It's not worth it.
If you want to, I can rewrite the entire parser, sure, and the AST, because if you rewrite the parser, chances are you're going to have to rewrite the AST because those two are kind of linked, you know?
Then I can't maintain it. And you're right, yes. Because I already have a hard enough time maintaining it. Like, I barely get my digs in. But I do still understand it. That's my requirement. I have to know what's going on.
Just see, my point of view in these things is just that I've written a lot of parsers, and writing parsers used to be very hard for me, and I now write parsers a certain way. All of my parsers look the same, and they work well. I never really have problems with parsing or AST building anymore. And if I just do it the way I know it to do, then it works.
Yeah,
Maybe
that's
your way of doing it works too, but I have no experience with it. I don't know the good ways of making it work, and if there are
exactly.
ways of making it work.
Yeah, that's the fun part. You've discovered what I like. I like discovering the new things. Going, hey, I'm going to try doing this. Let's see if this works. And if it doesn't, well, I'm going to fail for 3 months in a row trying to get it to work. That's my motivation. I just like doing that. Otherwise, I would have just used like, oh, I'll make a parser using a parser generator. And then I'll make just what's a type checking algorithm. I'll use that. But I didn't. I just came up with this. I was like, I'm not going to look at anything. I'm just going to write code and get it to work.
This is pretty much what I did when I started writing parsers. I tried something, it didn't work. I tried something again until I arrived at something that works. And I'm now doing this because it works, and I have no reason to try anything else. I have found a way to write parsers properly.
Yes, you say properly. It is like proper in the sense that it will work and it's guaranteed. But it's not proper in that this is the proper way to do things and every other way is improper. It's just a proper way to do things. So it is properly. Right? Can we agree there?
Something like that, yeah.
It's not the way to do things. And the only way to discover any other way to do things is to do them differently and fail a whole bunch, which is what I'd like to do. Muck around in the mud is what I like to say. I really dig it, like just full steam into the puddle, make a big splash, figure out what happens after, who got wet. Snarlfurb with the happy face. Thanks, Snarlfurb. Just a happy face. But I agree with you that if it was a DAG, then we could make different assumptions in different parts of the code and do it differently. Because it's an AST, we have to work around that and figure out a different solution than things that you have used before. 100% agree. That's all correct. I just don't see that as a bad thing inherently. I think that's good to spend more time on a problem you've already solved, which is not common. That's only my viewpoint, right? Most people go, but you've already done it. You found a way to do it. Just use that way.
Yeah, in this case, it just seems to me like this is just a more complicated way of doing the same thing.
Right. and I would agree with you that that is 100% an understandable viewpoint. Because from your perspective, you're like, it's simpler when I write the parser in this way, then you can write the next portion simpler. Like the type checker can access different things in a different way, for example, or code gen. For example, it doesn't have to do name lookup.
Yeah, exactly. I only do name lookup locally when I'm for variables. I do name lookup locally when I'm passing. Like whenever I encounter a variable access, I check, okay, is this thing in the scope, and if not, that's a pass error. But if I encounter a call to an unknown function, I just record it as a call to that, and then later in the semantic analysis pass, I check whether the functions actually exist. That way, you can do all the independent function calls.
Well, there goes Emacs. That is a reasonable way to do things. It's like a job. I hate to say it. It's the JavaScript method. You lazily parse. You don't really do any checking until the actual type checking stage.
Yeah, you split syntactic and semantic analysis.
Yeah.
You do syntactic passing and then semantic passing, or semantic analysis.
Whereas the parser and fun compiler, at least currently, Emacs is just frozen. It won't even close. I'm going to use Task Manager. Oh. Uh-oh.
Let me, if I check my history.
Okay. Emacs, goodbye.
I have at least 3 occurrences of kill all Emacs in my command history.
It freezes from time to time.
Yeah, it just does that.
Okay. It'll give us a good clean slate when we write goodbye. Streama 2022 uncompiler. Okay, we're here. We're in the source, and we're talking about the problem of we want to create a named function.
Yes.
Which
I think the whole point of all of this is so that direct calls can have references to functions, which would make it, as you call it, a directed acyclic graph and no longer an AST, as you call it.
Yes. So what? But can't we just do that in the IR only? Because IR is already an a DAG.
Do it well. If it works, then yeah.
Okay, so when we're generating the IR, what actually needs changed in the IR for it to be handled properly? Does that make sense?
IR, yes, a direct call. So if you look at IR
Function
call
call
value, I think it is at the struct.
Okay.
Go to the struct
Intermediate.
definition of,
Yeah.
I think it's IR call value or something. That const char pointer needs to be an IR function pointer. That's it.
Okay.
That's it.
So this should be a. We're just going to leave name for now.
Const? Should it be const? That's a good question. I would make it const just in case you need to do something with it.
So we'll store the function in the call value. And this is the function being called, right?
Yes, that's the callee. Just like with the instruction. The instruction is for an indirect call, the function for a direct call.
Okay.
Every direct call is a reference to the function. Every indirect call just has a reference to an instruction, which is the value that is then being called.
So this is like a function address.
This is like a function reference. This is the instruction that evaluates to a function point or whatever.
Oh, I did that wrong.
Maybe call it direct callee or indirect callee or whatever.
So would IR function reference IR instruction callee kind of make sense? I mean, reference...
Reference is weird because reference, we normally use that for an instruction, right? Because we have value reference that usually refers to an instruction.
That's right. So value.call. We're just going to call it function. Fuck it.
Function, sure. You can call the instruction reference and the function or whatever.
So
call it. But I would remove the name completely. There's no reason for it to be there.
Well, there's no reason for it not to be there. We can keep the function name around. I guess the function should store the function's name.
It's in a union.
Yeah.
Union.
I see.
One or the other. You can't have both in.
You're right. So we should just have the function. And hopefully this will have the pointer to the name.
You can
rewrite it to where this works, to where the IR has access to that without doing anything in the parser, then sure.
I'm pretty sure. I mean, we're gonna have to do very little in the parser, is what I think. So when we create a direct call, we need to call a function now.
know this parser better than me. I have no idea how to do that with this parser. I only know how to do that when I write a recursive descent parser.
That's right. So now an IR indirect call or direct call. So every direct call needs to have a function created. Yeah.
Yes.
Which means that so this external function normally just used a name, and we would call that as a like external symbol.
Yes.
So that's no longer. How's it going to work now? So an
You need an
external
IR function for the external function. A function struct that has like the name and everything.
Yes. So that
You
has
add
to
that
happen.
the list of functions.
And then, okay, I need to go change the header. Oh, I can't type. So we have a direct call, which gets generated and it sets a function, which means that how we currently do it is we say, just use the variable. What is this? Not the variable. What is expression? Expression is a function call. So its first child should be the function it's calling, and that's the name of the function it's calling. Okay.
You can try looking up the name here and then trying to get a function for that, but you need to somehow declare a function. Create a function struct for this external function somewhere.
Yes. So that's still a to-do, and then we'll add to-do lookup function struct. Here, we'll just call it IR function by name. Okay, yes. Okay. So when we have an external function, we then need to have what? So is this only handling for an external function that we're adding?
Only for a function, but no, also where we have a direct call in general.
So when
The else branch, I mean, the problem is we don't do direct calls if it's not an external function. So this now needs to check. Yeah, so the problem is how. Okay, yeah. So right now the only direct calls we have are external functions because we don't currently have a way of defining functions with like that are immutable.
right.
Does that make sense? Yeah.
So instead of creating a variable access, which is what happens here. So you're saying for an internal call, so maybe this doesn't have to change at all.
No, external functions still will have to change, I think, because it makes sense to also just have a function struct for them.
Okay. So in that case, doesn't that mean the backend's gonna have to like skip external functions and not define them?
It just has to check if it's external,
And also
if not,
the register
anything.
allocator and also.
Yeah.
Okay.
And the register allocator should be per function anyway, so that's that. We still we still need to change that as well. So, but yeah, the backend then everything has to check, is this external, and if so, then don't try to emit the body because there is none.
So when we emit a variable access, then we're getting the result of that here. So the function call, are we assuming this is in codegen expression? So we get the type, whatever. If it's external, calls direct. If it's internal, calls indirect, which almost seems backwards. For iterator expression, children expression, iterator next child. If not codegen expression.
The arguments, that's going to be the same anyway, so that doesn't really matter.
Iterator expression child, next child, children. So how does expression children result? Where is that from?
That's basically the value that is being that evaluates to something is an address and designates a function.
So that's like the IR instruction related to.
Yes, that's the II instruction whose value is the address of the function we want to call.
Yes. But how does that ever... Oh, because that happens right here. I'm blind. Oh my god. Okay, so we call codegen expression children.
Mm-hmm.
That's not what we want to do.
Yeah. But the thing is, currently every internal call is just... So we need to differentiate between calls to variables of function type and calls to actual names that designate functions. Like with the two syntaxes that we want to differentiate. One declares a variable of function type, the other one declares a function that's not mutable, right?
I mean, yeah.
And we need to differentiate between the two because one needs to be an indirect call, one should be a direct call.
So if the child is a variable access and we look up that variable and it's a function that has that whatever that differentiation that says, hey, this function should not be reassigned. Or
yeah, then we need to emit a direct call to the function struct corresponding to that thing.
Couldn't we also... So that requires the IR function struct. So how do we get the IR function struct normally? From do we never do, right?
We don't.
So how would this even be feasibly possible? What are we talking about? So we're trying to, when we're cogenning a function call, we're trying to alter it so that when we are calling a function which is guaranteed to have one definition, it can be a direct call.
Mm-hmm.
Okay, so then we have IR function. Where would IR function be stored? So what data do we have?
Context. All the functions are just a vector in the context. There's vector functions in there.
So expression children refers to the variable access node, which we are actually attempting to call.
Mm-hmm.
Do direct calls have to codegen anything other than the call?
No, you don't have to cogen the argument. That is correct. You don't need to cogen the argument because the argument is a compile time constant.
Which means that we basically just create a direct call.
Yes.
So to look up a variable in the environment.
Something like that, yeah.
How are we doing that?
You need to look up a name in the... Actually, what you can do is...
Like that. Yeah.
Actually, yeah, you need to somehow know that a variable is you need to somehow be able to convert from a variable to the IR function struct that variable represents.
Because currently we have a parsing context, and the parsing context stores variable symbols to their types.
Mm-hmm.
And the type of a has nothing to do with the actual IR function. So whenever we define a function and create an IR function, it sets the name, right?
When you create an IR function, it does set the name, yes.
Which means if we were able to just loop over all of the IR functions and check the name, then we have the IR function.
Yeah, congratulations, okay. You found out what IR get function does. There's a function for that.
Legendary. So
but
use...
The problem is that you somehow need to store the name of the function in the function because it currently doesn't know the name.
So, yes, I'm seeing the issue now, the true issue. So when we...
Because IR get function only works with the main right now because that's the only really named function we have.
hence here. So when we
That one has a
call
name. This is just
here, has the
something. It's a name. Where's this name even coming from?
this this is in the cogen function. So the name is coming from here, and then the name is result up here, if I remember properly. So result. Okay. Why is this all fucky? Okay. So if we get a function in the parsing context, which is equal to expression, oh boy, and we get that into temp node, then we say, okay, temp node must store the name of the given function within functions.
Something like that, yeah.
So why?
The thing we're missing right now is the parser has to store the name of the function somewhere where it can be accessed from here.
Interesting. So it should just be in the functions environment. We look up by value and then we get a name. But this is failing where result is still equal to null from up above. And we're generating some random label.
Random label, yeah.
That's not ideal. So why
Sorry.
doesn't the functions environment in the parsing context contain the name of the function that we're trying to look up?
Because currently we don't have named functions in the language. Everything is an unnamed lambda.
Thank you so much for being this patient with me. I understand I keep asking circular questions. Like, but yes, I've explained that. I really appreciate you being patient. I understand it's not easy. So, okay. We get this value, which means that, in the parser, if all we have to do is when we create one of those special thingamajigs, isn't it right here? Where is it? Yeah, lambda type equals node type function down here, right?
Don't ask me, maybe.
Yeah, so if we get the type of a function, and this is a variable declaration, and we expect an open body, then we create the whole, okay, we already created the declaration, so now we create a reassignment of that variable. This is a mess, I see what you're getting at. And then we parse into a lambda, which is the child of the reassign on the right-hand side. Where are we at? Okay, so functions, what does it actually have in it? Do we ever touch it? I don't think we ever touch it. I was like, wait, if this is the way to define functions, and normally it's just a reassignment, huh. That would never...
We don't have functions in the language, that's the problem. We only have lambdas.
It's true.
Opposite of free. He only has functions and no lambdas. We only have lambdas and no functions.
It's perfect.
Like a list without defun.
The funny part is the Lisp I write. Defun is just a macro.
Yeah,
written in the Lisp itself. There's no actual idea of functions either.
Very built in from like defconst or defvar or something. Then let's use that.
So when we create a lambda here, if this lambda had the name of the function, yeah,
yeah,
then that means whenever there's, oh man. Okay, so we're just going to assume that after this point there's no reassignments for now.
Okay.
We'll ensure that. We'll ensure that eventually.
Yeah, because reassigning to it would break it quite horribly. Because then it would still be calling the old value. So reassigning to it would do nothing.
Oh god, yeah, that's kind of horrifying. We definitely have to work on the type checker there.
Actually, it's worse. A call to it would still call the old value, but if you assign, if you had some foo and marked it as a constant function where you don't check it, then if you reassign foo and call it, it would call the old value. But if we then copy the value from foo into another variable and call that, it would call the new value.
Oh, that would be
Isn't
killer.
that fun?
That would be impossible.
That's what would happen right now if we don't check for whether it can be reassigned.
Oh no. Oh no.
Because it would still store to it, I think. It would still try and treat it as a variable. It's just that any call would not use the variable, it would just use the value.
So we have body here, which is here, number 3. So if we just create another child of function.
Optional name symbol you put there.
Yes. If we just create this optional name symbol, then if that name symbol is there in the code gen, see, that still doesn't matter. Isn't that killer? That's killer.
Right. I'm
So-
gonna be right back because I'm getting hungry. I'm gonna turn on the oven now. So
Great
right back.
idea. Alrighty. We will see you when we see you. I'll continue on this nonsense journey. Get by value expression. So we're trying to look up an entire function definition within functions. Why are we doing this? This is horrid. Okay, so if we didn't do this randomness, how would we get the name of a function if it has a name? Node type function. So node type function is exactly what this lambda had, right? I know I am insane today. So lambda type node function. So this lambda, wherever it is, lambda, its last node add child refers to body. So then we could just say if it has a 4th child, result equals that. If expression, here's the 4th child check. I know this is horrible. So we have an expression function with a child, which has a next child and a next child. So this is child 1, 2, 3, 4. Result should be equal to the symbol what is next child? Next child should be a pointer. Why are you mad? Oh, it's not enabled. What do we need here? So result would be if we code genned it. That's not what we need. We need the name. So that's probably in value symbol char pointer. Okay. Do we ever need this? So if it has a name, set the name. Otherwise, don't. I think that's reasonable. And then all we have to do here... Uh-oh. What did I do? Say name. Node allocate. Is there node copy? Hopefully this works. What's the name? It's got to be somewhere here. What's the name? So yeah, here's this exact same thing that we are doing. It's called symbol. Copy symbol into function name. Then add function name as a child. You ready to see everything break? How about that, chat? You want to see everything break? Write a little compile command here. It's much quieter with just my headphones on. Normally I don't have them on. CMake build, clean first, build, func. Examples. I don't know. Greatest common denominator. Ah, yes. Oh yeah, I changed that other thing. Let's not change that other thing yet. So that was in intermediate representation H. What if I changed you and didn't do anything about it yet? How mad will you be? A little bit mad. Conflicting types for IR direct call. So now we can just redefine this as well. Nearly. Function undeclared first use in this function. Did you mean IR function? So then I didn't. Yeah, okay. We'll get there. I'm not too smart, but I'll get there. Undoing that little change we did earlier. Completion finished. Chat. Remember when this said global L0? Or L1, whatever it was. It was probably a L1. I'm pretty sure I just fixed it. I mean, it's not like there's still some semantics that aren't correct, like the dual assignment being a problem. Because what would happen if we reassigned GCD Euclid? Is this see, now we have some problems. So it can't be Sir Aid, I need your help again. I almost fixed it. So here's the thing. When we're generating a call, we're still doing the same thing, which is really the only issue. And then this is the other issue. So issue 1 is generating a call. Let's figure out that, because that's kind of important. And it'll be good if we've handled that already when Sir Aid comes back, because he doesn't have to complain about our terrible bad coding, which we are doing. We're doing it on purpose, though, so there's something in that. Use IR get function if we want to do all that. Okay. So when expression children now refers to...
All right.
Okay, I think you'll be somewhat... Okay. It's not bad. Huh? It's not correct. The calls aren't correct. Don't worry about that. Don't worry about this.
Getting there.
Hey. Okay.
I mean, the optimizer's going to eat the rest of that, so that's probably going to work already to some extent. I mean,
So
the call isn't actually handling that properly yet, but the name is right. I'll give you that. That's good.
Okay, so we did that.
I mean, the optimizer will already find it.
That's good. Here's the thing. We now have a variable and a label.
Oh no, the assembler won't like that.
No. So what do we do about these variables? Because we never have to reassign them, we never actually even need this variable, right?
We never need to emit it.
Okay, so that's complicated. Am I wrong?
No.
Go ahead.
Okay. Basically, there's two ways of doing it. You could just check for it in the back end if it... I mean, you need to find a way to mark it as this thing doesn't need to be used. Like, the easiest way is if you can somehow add a boolean to it and set it somewhere that marks it as this thing doesn't need to be used.
Okay. So
what we do in the back end, we iterate over all variables and emit them. So that means we have a list of all variables. If in that list of all variables you could modify the entry for this variable to mark it as this thing doesn't need to be emitted, then that's that.
So when we loop over all variables, I'm pretty sure that's the code gen context.
We loop over something. It's all the way in the
x86
backend. It's pretty close to the very bottom of the file.
Okay.
Towards the start of the last function.
Here it is.
Yeah, here somewhere.
The parsing context. There we go. Yeah, for all global... Yeah.
There's some complicated checking to see if it's unused. So we can just add another check that just says, hey, is this thing marked as don't emit or something like that? And then don't emit it.
So in here, right? Is this the proper place?
No, this is inside. If it's not an external function, actually, yeah, if it's not an external function, then you're in here, I suppose, yeah.
And that's kind of what we want, right? Because external functions we don't want to emit, no matter what. And we don't need to check if we don't want to emit something we're not going to emit.
Never want to emit those.
So if this, what do we have? We have variable to type binding. Yes. So there's not really a way to add to this list, to be 100% honest with you.
Is that
Because it's built by the parser by the type. You know what I mean? Like it's the type. It's the type information that the type checker uses. So this is like, go ahead.
type of a variable and the variable in different locations, basically. And how does it work?
Yeah, that's exactly correct. Because a variable is just, it's not like a thing, it's just a name. So the name is just bound to a type.
Right.
So
Because you don't, it's just called by name. Everything just uses names. Like, I'll go, okay.
which means if we had some other list,
Oh my god.
well, there's not really another way to do this unless you want to somehow.
I need to put the pizza in the oven.
Okay.
Sorry, be right back.
That is all good. Get that dough. Where are we at? So in here, we need to not emit a global variable if it has something. If backend failed to get type. Okay. So here we get the type info based on the type ID, which is like the actual integer string. Hence the string compare. So even if we're not optimizing, we still say if we don't have a data section, create the data section. Okay, what if we removed it from this? That's kind of scuffed, but that would work, wouldn't it? So if we removed a variable's type information during code gen, when we detect that, hey, we actually already have all this stuff. Oh no. Cache this somewhere. Still don't know what that means. Cache what somewhere? We get the type, and then we use the type info to figure out how large should this be. Okay. Okay. Hear me out. So if we get the type into type info from parse context, then we get the size. So there's a lot of data here that we're accessing that we don't need. We barely need the type information for the variable. We need the variable name of the global. We need the type only to get the size. So So if we had the size, that should be allocated. The variable, that's all we would really need. But we also need a way to tell should this be emitted or not, because some things are being optimized not into variables, like functions. This is why this is so complicated, because all functions are variables, but certain ones should be treated in a certain way. So what we're going to do is have var id type info. So all we are looping over is this. So if we had another list, I know Sorry, I wasn't happy about that one, but if we had another list, if we looped over a list of variables here that don't need emitted or shouldn't be, then that would be ideal. Because we would skip any variables that don't need emitted. which looks like, oh man, that's probably for this for each. No? Go to break loop. Interesting. Interesting. So we don't want to get here. So we basically would just say if blah, blah, blah as well. Okay. So we have the name of a variable. We have its total type information in the AST.
Right.
Hola.
So, where we at?
I'm just going over kind of the state of things. So we have the variable name. We have the type information, complete type information. So we have, it's an integer, its size is 8, blah, blah, blah.
And so on, yeah.
Or if it's a function, etc. Okay. This is complicated because this is using stuff from the parser all the way in the CodeGen backend.
Yeah.
Which is not ideal, right?
No.
So the ideal thing would be to either have here's what I came up with. A list of variables, global variables, that should not be emitted. But it should really probably just be variables. Just right here, it only... And then we could just loop over a list, and then if it's in it, we don't emit it, right? That would work. It doesn't seem ideal. B, a list of variables that should be emitted. So we could generate the list of Nix Craig. Thank you so much for the follow. We generated, yeah. Basically, if go ahead.
This is something we need to do anyway. We need to represent variables in the IR.
Which sucks.
I mean, the thing is, I'm modeling this, of course, after LLVMIR, because that's what I'm used to. And in LLVMIR, the way you do it is local variables, there's no concept of that. You only have stack allocations. And a stack allocation instruction, the value of that is a pointer to the allocated memory on the stack. So if you then assign to it, it will do a local assignment, right? There's also a separate instruction for, you can also create global variables. Those are separate and there's separate entries for those. Global variables are handled differently. Local variables are just references to the stack. Global variables need to be stored in the IR. That's how LVMIR does it.
Okay. Question, if we had a nested function that only is assigned once, we still want to call it by its label, and we also don't want to emit it.
Exactly. That's not a global variable, though, so I suppose dead code elimination would just yeet that.
Hopefully. But we don't want to rely on that.
Yeah, the thing is also with nested functions,
you see it breaks...
Yeah. Not closures, then we can just hoist them to the global scope and everything is fine, right? If they're not closures. But if they are closures, then it's a bit more complicated somehow.
They're somewhat like closures. Because they have access to the parent state. So this option A looks like the one to, like, that would be easiest right now, right? First time chat from Nix Craig. Emacs user, let's go.
It might be the easiest to do right now.
Yes. I 100% agree.
Yeah, we end up with like 4 different lists of things that store a part of a variable. What I usually do is I just have a variable struct that stores everything. Then we end up with DAG, as you call it.
Yes. So, we just don't want to get here when what? So if the variable name, this is so complicated. So when do we, we're going to have to fix calls as well. I forgot. That's another thing.
Exactly.
That's fine. So when we generate a function, we now get the name. Is this cogen? This is cogen. Wasn't I just here? Why did I do that? What am I doing? Wasn't there, we needed the name somewhere when creating
Yeah.
the result? Is that not in
All
cogen?
IR function. And that's in when we emit a function node here. Yeah, I think it's
Here. Okay. Here's what I did. I removed all this while loop context crap,
Okay, that's good.
and I've just said if there is a fourth child to the function, it's the name. It's that simple.
Okay.
Okay? So that optional name symbol, if it's there,
Sure.
guess what? It's there. And it's boom. That's the
Okay,
name.
that makes sense, I suppose. And otherwise, it don't have a name, need to generate a label. That makes more sense. Yeah. Okay, good. That makes sense.
Then we cogen the function.
Okay, and we've seen that already in the output that they now have the proper name.
Yes.
GCD Euclid now is called GCD Euclid instead of L0.
Beautiful. That is correct.
That means I can also then, there's also a hack in the IR parser, because previously it would emit an IR function called .L0, but then
That's right.
in the backend we use .L0 for the label name, so that would cause a naming conflict. So right now in the IR parser, it discards any leading dots in function names.
Which is reasonable.
I mean, it should probably not do that in the long run. Just modify the name of what it's passing. That's I'd rather not do that. And with this fix, we will no longer have to do that.
Which is good.
Yep.
So here's what I'm proposing. There's a C that I just thought of. What if we just removed it from this list?
Oh yeah, that works.
Legendary. Okay.
That's what I meant with it shouldn't be a variable.
Okay. Legendary. Then that works. So when we create this function, if this happens, remove type info. That's where we're at, right? This is a variable that has the special syntax, right?
Mm-hmm.
So when we look at, oh man, it closed because it crashed.
Okay. Oh, because Emacs crashed. Brilliant. That's the worst thing. Or when Emacs crashes and suddenly you have like 45 buffers open.
It's true.
Horrible.
Okay. So this new syntax, I didn't do TypeScript mode. Tree sitter mode, TypeScript mode.
The braces in foo are yellow. Or maybe that's just me, but I think they are yellow.
Yeah, this is all yellow.
Uh-huh.
Oops.
Wrong mode, perhaps.
Yeah. I'm just in the dumber one. I loaded the, what did I do? There we go.
Mode, dumb mode.
Tree sitter mode. There we go. There's the smart one. Nick Craig says, if my Emacs crashes, currently I get a kernel panic. Oh no.
What?
What if, oh no. That's not good.
Dear. I mean, I know that some people say Emacs is your operating system, but you weren't supposed to take that literally. You shouldn't
That's so
actually
good.
be using Emacs as your kernel. I hope you're not.
I have Emacs running as PID1. What? No.
That's actually true. Then yeah, you would probably get a kernel panic if Emacs crashes. If init crashes, that is a kernel panic. Because what the hell is the kernel supposed to do if init crashes? Init never exits. Init never exits.
You're literally using, Nick Craig is using Emacs as an OS. 100%.
An init system at least, jeez. And that's, yeah, basically. God.
Okay, so foo would have its type information removed as soon as it's created.
Yeah. I suppose that would work, yeah.
And then, so when do we, this is after type checking, so we should never have to get the type again.
I hope so.
We can hope. Okay, so
We'll see.
Nick Craig
I hope
says,
we hit an ice somewhere if we try and find, because in the backend, if we try and find the type of something and we don't find the type, that's an ice, if I recall correctly. So
we'll know.
Scream at us if we get this wrong, I hope.
Okay, so we have result, which refers to the name of the function. Okay. And we need, oh god, to find binding, find and remove binding from variables context.
Look at the thing that someone linked in chat. Look at
Okay.
that link.
I was scared to click a link. Oh no.
In Emacs.
Emacs is an
Not
OS
pid one,
confirmed.
It's an S bin. Emacs is an S bin.
How did you do this?
Oh god.
What did you even...
can just set Emacs as PID 1. So you can pass a kernel parameter init equals sbin Emacs in this case.
Oh
And
my.
then we will. You can also use bash. You can do init equals bin bash, and then you have a root shell just like that without password or anything. That's what you do if you forget your root password.
That's incredible. This is crazy.
This part is it's an S bin, so S bin is typically for system boundaries, and I need to get my pizza out of the oven, so.
Nah, just let it burn.
Oh god, no.
Alright, I'll see you soon. Okay, so we remove type info, find and remove binding from variables, parse context. Woo! So we're going to need a context iterator, which equals our current context. Did I call it parsing context? Yeah. Context it. That's incredible, Nick's Craig. Statically compiled Emacs with a lot of features disabled in Getty, then init Linux with Getty and have it exec Emacs. Otherwise, Emacs will crash saying it can't allocate a TTY. Oh no. Oh, that makes sense though, because it needs, yeah. Statically compiled Emacs is just such a cursed idea. Oh no. So context has variables. And in context variables, so we have like parse get variable and parse get type. What is that? Let's see there. Get the value of a variable symbol ID in variable's environment. Return an error if variable is not. Return false, I would assume. If variable is not a valid symbol ID found in context. Does that search parent contexts? Yes. So for every context, if we environment get variables by ID into result, status return true. So we're going to need to interact with the environment. So if we passed, okay, this is cursed. If we pass null here, how does environment get work? It says if node compare ID, result equals finding iterative value. See, we dereference it here when getting result, which is a little, I mean, we kind of have to, otherwise this has to be a pointer. So we can't really have it be null, because we'll still get something from environment get. So to remove it entirely, we would basically have to say, what is it? It's a linked list. What do we have? What is an environment? Pretty sure it's a linked list of bindings. I don't think... Yeah, we don't need those to-dos anymore. We definitely have them. It's been a while since I looked at this. Okay.
God, that's environment.h. I forgot that file existed.
I did too. I was just looking at it. There's like to-dos that don't make any sense. Oh no.
I haven't looked at this in like ever, I think.
That's, yep. Which is good. That means I did a pretty good job. Remove. Node pointer ID.
Oh, we're adding environment remove. I see.
Don't do that. Do this. Environment remove. So it's going to be like environment set, but not, right? Yeah, just return not environment set. That's how you do things, right? That's how C works.
Sure.
Yeah, and then we can just pass
Sure.
null value. Done.
Oh no. So write it with null.
Oh god. So we have a list of
Maybe it's a
bindings.
linked list. It is a linked list, isn't it?
It's a linked list. If you want to write a hash table, go for it. You have to write a hash function for arbitrary node. So
I'd rather not. I'd rather make it a vector, you know? That's easier.
I mean, that's also a possibility. It's the same as a linked list in performance-wise. It's probably
because
worse.
caching. It's better because of caching. If you can iterate over it.
It's true.
That's why vectors are generally preferred. And lists are slow because of cache misses.
They're not slow. I will die on this hill. They're not inherently slow. In fact, they're faster and light. Did you know that?
Depends on what you're doing. I mean,
It's exactly there. That's the answer I want. Lists aren't slow, but they are slow in use cases where you should use a vector instead.
generally never a reason to use a list. But yeah.
Other than to actually get anything done.
C++, for instance, it's generally good advice to never use standard list.
Well, yeah. C++, you have better options.
Mm-hmm. We
Uh,
also have vectors. Wait, let's write this function. I feel like if you pass in a null to this, it should probably be an ice. Because
Yeah.
why are you trying to set something in a null environment? That's
You're
like
right. We probably don't
just-
even need... Yeah.
Same thing for the rest of these, I think.
You're correct. You're absolutely correct. Null environment or null node ID. We'd probably want to just have that be ice.
Mm-hmm.
I guess null value as well, if we're trying to set null. That probably should never happen.
I'd at least added another to-do for it. Don't want to do that now.
What do I call ice with? Just a format? And we're going to say, does it do a backtrace?
Yeah,
Environment?
it is a backtrace.
Okay, so we just need arguments must not be null, and it'll make sense. Okay.
It will print the backtrace starting at environment remove.
Beautiful.
You can try it. You can remove the condition and it will do the ice. If you want to test it.
That's a good point. Oh, we're never calling this, so that'll be a bit of an issue, but we could do it here. If one.
Yeah, we'll notice that.
Nice. What did I...
It didn't build.
Yeah. I guess I screwed up a lot of stuff without realizing. Oh yeah, this is... that may be incorrect. Oh my god, what have I done? What have I done? What have I done? So we need to compare with each thing in the environment. We're not there yet. Okay. Do a thing. Please give me an ice. Serade.
Windows moment.
There's a bit of an issue here.
What on the VM? Are you compiling in you're compiling in debug mode, I think, so
Yeah, for sure. Otherwise these would be null. Or not there.
interesting.
Well, thanks Windows. That's a great ice.
Windows. I'm using Windows symbol to name function even like it's supposed to translate something to a name and it's not doing that.
Yeah, it's fine. So we're just going to say we're going to include it. I know it's horrible. We'll fix it. Environment set. Environment remove.
Ice should probably just print the function just in case that the backtrace doesn't work.
That's true. We could have used pretty function, can't we? Is that the norm?
Yeah, I just use func because pretty function can get long, but yeah.
I see. Perfect then. As long as there's...
Actually, it doesn't matter.
I don't mind. As long as it shows up. So we need to do... have some binding. which equals environment.
The thing is, this is C, so we don't have overload. So if function is, we know what is if we just use function. In C, if we have 10 different in C++, if we have 10 different overloads, just the function name is not going to help you.
It's true.
That's why I typically use function, pre-function.
Last bind. Okay. Whoops, I am a genius. Okay.
Oh no, kill all Linux.
Oh, I missed that. Oh, it also feels pretty cursed to do kill all Linux when my shutdown elisp function doesn't work. Oh no. What have you done? So, that's Emacs crashes all the time for me. And to be fair, I'm on like the trunk. I'm on 30.050.
I see.
But it crashes all the time. How do you deal with that? Well, Nix Craig says skill issue. I'm just not good enough.
It's a certified Terry Davis moment.
Okay. We need to set last bind next to bind next. Insanity, right? Bind equals bind next. Does that work?
What if it's the start of the list and so on?
Okay, fair. So
I have like a delist remove macro, but that would require restructuring the environment, so let's not you do that.
So if we have no bindings, we can't remove anything. If we have a binding at the very beginning, bind will be set and last bind will be set to the same thing. We'll compare, this will be true. Last bind next will equal bind next, which will totally break. So if we make this null, and then do if last bind, and then do else, then we just...
main reason why I don't use linked list, they're too much of a headache.
See, I love this stuff. It's like I get to keep a little structure in my head, and when it works, it works. As soon as you get to like a hash table, I have trouble picturing, like, what does that look like? My brain doesn't get it. Like, I can sort, oh, there's a bunch of buckets, and you store things in them with linked lists. It's like, how's this faster?
A hash table is a vector of linked lists.
With a special indexing function. But yeah, that's it.
In the way you index is you take the hash modulo the size of the vector.
Unless it's
the bucket is just a linked list.
Unless the size is a power of 2. Then you can just and -1. If last bind next equals bind next, else end bind equals bind next. So now we've handled the beginning of the list and the end. That's it, right? Nix Craig says, works on my machine also from trunk. So it never crashes, not once. You said it's statically compiled with a bunch of features disabled, so it's kind of a different use case, I guess. But you're right, the base Emacs probably doesn't crash. It's probably like the complex interactions from all these crazy packages I have installed. And hooks. Hooks always ruin things. So if we've removed it, then we're done, right? So bool environment.h, and then we're just going to say remove binding with matching ID. Yep. So remove binding with matching ID, and then the ret val is going to be false, which is going to be... You need standard bool.
I was going to say it should be bool.
First time we've used it. Okay, so ret val false did not remove binding. True.
You could also say return whether the binding was removed.
We can actually do all of them.
Oh no.
Returns whether or not the binding is removed. Okay, there we go. I think that'll actually be pretty...
But all right.
Overly verbose is like my motto. All full words, no shortened. I mean, identifier. Everybody knows ID is identifier.
I concur. Just like everyone knows that II is intermediate representation.
Oh, shots fired. True and false. So if node compare, remove it, return true, we removed it. If we can't find it in all of the bindings, return false. Cool. Yeah? Okay, what was I doing now? I wanted to say while context it, remove type, and this is why I make these little comments. I would be lost right now. So result refers to the name of the function. Find and remove binding from variables, parse context. So while context it, I could probably do this, couldn't I? This is going to be confusing.
This is why I write the call first and then implement the function.
It also works. Parent? There it is. Oh. Don't know what I just did. So, while context iterator and environment remove on context iterator variables.
Is it really going to be in more than one context?
What?
Is it really going to be in more than one context?
Parsing context? Yes.
Interesting.
Each one is a scope.
Wait, don't tell me, like, each nested scope copies the variables in the parent?
No. So we're searching through all parents until we find...
Okay, then you need to do not environment remove.
Yeah, equals 0. I forgot that.
I forgot that.
I guess that's a Boolean.
I would do not, because with Booleans that's like, makes sense. Was not removed.
I would agree. So if not environment removed, while not environment removed, go to the parent. As long as the parent still exists, do the thing. And then we just assume this works.
Yep.
Because if there somehow is a function with a name... So if we get to the end of this and this hasn't happened, then... Okay.
Context it is null, then you can just assert... I just assert context it, maybe.
Oh, that's probably the way to go.
Because, honestly, there's no point in even thinking about writing an error message for this, because this is just horrible. Like, if this happens, then what the hell went wrong? Shouldn't ever happen.
Parser... Yeah, parser generated malformed function lambda AST. Sure. If we ever see that, I feel so bad. Other than in the next 20 minutes.
The only error that's worse than that is, let's say, the one with this should never happen somewhere.
That's right. Could not get variable...
That's the error in the backend that I was talking about. Tries to get the type, but he can't find it. That's what I was talking about earlier. Remember why I said it will scream at us?
Yep.
Oh, man. That's in the backend, in x86-64. Search for that string, actually. Could not get variable within context for whatever.
It's not in the backend.
Really?
It's really not. Could not get. I don't even know where it is.
Grep for it then, maybe?
Yep. Grep. Dash R lep dot type checker. Well, that doesn't make sense. Wait, what? So in CodeGen, yeah, we remove, where did I just go? In CodeGen, when there's a variable access, we don't use the type checker. So what?
I think it is the backend. I recall the backend calling out the type checker or something else.
Ah, that's what it is then. That's what it is. So x86, so type check. It includes typechecker.h, but there's no actual type check call. Type underscore check? No, it's just type check, right?
Let me see.
So what if I remove that and compile? It's still fine. So we don't use the type checker in the backend. We used to, is what that means. Or it's included from somewhere else, I guess. So, because I guess it could be called get type or something.
Calls pass get type. There we go, you found it. Maybe it's this. Who knows?
Fucking.
Doesn't point to the type checker, does it? So
This is no longer a failure. Yeah?
what in this? This is in in here in the global variables, yeah.
This is no longer a failure.
I think that's what we need to check for now and then not emit it or something like that. Or
Yeah, you're exactly right. So you're gonna say if parse get type printf. I'm just gonna add them for funsies. Okay. We still get an internal compiler error, could not get variable within context for variable access return type GCD Euclid. So parse get type, why are you... parse get type. Isn't it right up
if you make a
above?
work in progress commit, I can get the stack trace in C line, if that helps.
That's not a bad idea. Oh
Or
no.
you can try using Visual Studio. Having a debugger usually helps with this, just saying.
So it's not parse get type that's failing. Confusingly. It's something else. I'm gonna try and give you your work in progress commit, because the stack trace would help greatly.
Visual Studio, that also works.
I could also just use Visual Studio. Oh man, I changed a lot of stuff.
Always put in a separate branch if you worried.
I'm not worried about it. It'll be fine. We'll just go. We're gonna start with Visual Studio. We're gonna try it out. I won't just lump it on you.
Visual Studio should be able to extract a stack trace.
First time.
What I usually do for things like this is I go to IceImpl and put a breakpoint in there and then just run it.
That's not a bad idea.
That's usually what I do, because then it will tell you how I got there.
Why are there breakpoints? What is happening?
ICE is a separate function though, so not in EC diagnostic. It's further down.
I didn't add those. They were just here.
Yeah, but still, just so you know.
Okay, IceImpl.
Just put a breakpoint somewhere in there.
Probably after it prints
Maybe not
shit
on the
out.
comment, maybe on an actual statement.
It'll fall through. It's fine. What do we got?
Make sure that it's like compiling the right thing.
It's probably not. Well, whatever it's compiling works. So what are we compiling that doesn't work? Greatest common denominator.
We're compiling GCD.
We're compiling Andor. Okay.
It doesn't have functions, so we're good there.
That's right. Greatest common denominator. We don't need... Do we have -o at the beginning? We don't. We have -fir, which we don't want. We have v debug_ir file, and that's it. Okay. Run. Wonderful. Well, that's a little better. type check expression called from CodeGen expression.
I mean, if you have Visual Studio, you can just look in there to see if you can.
That's a good point with the call stack.
Like, that's a bit better than my scuffed dumb where it doesn't even realize that what a color code is. So.
So when we access a variable, get type symbol from variable's environment using variable symbol.
I know why, because we still have stores and loads. Because we're still emitting, still treating it as variable, because we still have a variable assignment to the thing, right?
Yes.
And we need to not assign that. We need to not do that.
Interesting.
So I think, if possible, ideally in the parser, you wouldn't even emit a variable assignment.
That's what I was just thinking about. So if there's not one emitted, so when we code gen that special type of lambda, oh god.
In the parser, when we pass that type of lambda, we're setting the node type to reassignment or assignment or something. Oh, don't do that. Just declare that. Just treat it like a variable declaration without an initializer.
Yeah. Okay. Instead of the other, yeah. That's very reasonable and probably fairly easy. Because all we have to do is create the... Well, then where is this accessed in the AST? Because normally the lambda is on the right side, right? Of a reassignment.
Interesting.
So we would never actually get to this function AST because it's not anything.
Right. We'd have to kind of code that differently.
There would just be like a function node sitting around.
Yeah, something like that.
Okay, or if we don't remove it, right? If we didn't remove it here, if we added it to a list, that would then remove it after CodeGen.
That's an option. Yeah, sure. That, I suppose, works.
It's really not good, but I don't know what else to do. Because ideally, we want to keep the type information. But we just want to say, hey, this variable is like not a variable anymore, which is what's being very difficult, right? So we want to keep the type information, but remove it from the type information list. Oh no, I'm sorry.
As I was saying, what was I saying? Hold on, I need to think now. We were talking about variable, adding it to a list or something, and
yes,
and yeah. So the problem is that doesn't work because we'd still try to emit a store to a variable that doesn't exist, and that doesn't work.
Because of the reassignment, right?
Yeah, because of the reassignment, we'd still try. We cannot emit that reassignment. So either we remove the reassignment from the AST, or we mark it so that it doesn't get emitted.
So if the variable reassignment, do we ever call like parse get type? Where does this happen? Do we ever do anything like that? We don't, do we? Okay, so let's say a reassignment. We have a variable access, which has the name of a variable. Yeah? And when this... We may want to go here. So when this is a variable access that we are trying to assign to, if the variable has no information in the types thing, we could just not do this, right?
I suppose that works.
With a giant fix me up top, right?
Yeah, it would be indistinguishable from an actual error in the AST where we somehow try to emit to store to something that actually doesn't exist.
Yes. So hopefully that's not important.
Yeah, let's hope that the parser never does that.
If variable has no type information. Don't do anything. Just skip it. This sounds so bad. We may need to do like a no-op. Because expression result might be dependent upon existing. Or not being null. And we need some sort of instruction. Even if it's not inserted into the IR. You know what I mean? Okay.
Or just throw in an immediate 0 or something like that.
Context, ID. So, oh man. What if we just used the variable access, which is going to be iterator? Parse get variable into result may fail true. So we need to do like this. Into do I have like temp node? Temp node. Why did that not? So then temp node. What does parse get variable return? Return an error if variable is not a valid symbol ID found in context. What is an error? Is that false or true?
Returns false.
If well,
Generally, failure is generally indicated by returning false if it returns a boolean. Generally.
yes,
Unless it says otherwise.
not that. This break will go to this case, right?
Mm-hmm.
Because all we want to do is then free temp node return true, which means we've handled this expression. And we may even right now skipping code gen of variable bleh. We'll just say a bleh variable. Just so we don't go too insane.
Mm-hmm.
Okay. Okay. That didn't fix a thing.
Okay, back to the debugger.
Yep. Thanks for complaining. Type check expression being called from codegen expression function call.
Yeah, we need to fix calls now. The call
Yes.
is now trying to reference a variable that doesn't exist. Well, that makes sense.
That's at least understandable.
Yeah. We're getting this, like, it's failing in the same place, but it's being called from a different place. That's progress.
That's right. That's right. So, a function call has the name of a variable. Yeah?
Mm-hmm.
Why do we need this? The variable type. Because if it's an external function, we have to do certain things. Right?
Mm-hmm.
So we can say, this is so bad. This is so horrible.
Oh dear.
So,
I know that something interesting is about to happen whenever you say that.
so if we parse get variable, oh god, in context, expression children, this thing, into result may fail. Okay, so if this is false, then that means a variable with no type info is attempting to be called. This is so bad. This means that it is a named function. Clearly. Clearly.
Really. Very semantic, very expressive.
So, parse get variable. If we don't get it, what do we want to do? What kind of call? Didn't we do this whole thing just so we can do this?
Basically. Not for internal calls, but yeah.
So, we need to do this. And then, okay, we just have to move this up.
Yeah.
And then we can do this here and else here on all of this else. And then we still need to, no matter what, do arguments and then insert the call.
Mm-hmm.
Oh,
Well,
oh,
compile.
well, hey, that's much
Yeah.
better.
It's still doing the Liam. And the move.
What are these from?
That's getting the global address of a variable, I believe. Oh, I know why. You're loading them. You're still loading them. You need to not emit. Are we emitting the thing that we're calling if it's a direct call?
So when
we
it's
need to sort of not do that.
yeah, so we don't do it because here's the thing. We only cogen expression here for an indirect call. And that's only in the else of if we don't get it. So let's look at the IR.
The IR, yeah.
Oh,
What are we getting here? In what is this? This is main. See, it still does the store.
so do we not see? I guess we didn't see any skipping messages, but I added those, huh? Doing special function name call thing.
That part is fine, I think.
Yeah, that part
So
is
if you look
fine.
at call instructions, those are working because those are direct calls.
So it's the
Problem
reassignment
is that
check.
we're still emitting the store
This thing.
for some reason.
The reassignment, right?
I think it is reassigned, yeah.
Because this creates an IR store local global, etc. How are we getting here?
I mean, is it printing skipping cogen of the variable?
I don't see it. We can look.
Then the way it's getting there, that's somehow this isn't catching it seems.
So if I remove the IR debug, you can see that basically nothing's printed out.
Yeah,
Which-
so that's the problem. So that condition, that check somehow doesn't work.
Okay.
Great.
We're gonna look at parse get variable then.
Oh yeah.
What else I mean, how else would it be failing? So we're looking in every context, and then we're saying status equals environment get. And if status return true, an environment get returns Boolean-like value 1 for success, 0 for failure. Beautiful. So basically, if this, return this. So if we, oh man. So if we get a variable, we should return true from parse get variable. Which, okay, so we're going to say else cogening variable reassignment. Value symbol. Okay. Just tell me, I want to print something out.
There we go.
The one thing that it shouldn't print out is what it prints out. God damn it.
So somehow that check doesn't work.
So, Go
is
ahead.
this getting called before we emit the function? Because we remove it
mean?
when we emit the function, right?
So
Is the function a child of the reassignment?
it is. Remember, the lambda is the right-hand side. It's right here.
Mhm.
So do we literally have to do...
Yeah.
Hold on.
Yeah.
We can hope. Hey!
Hey!
Okay, wait. Dun dun. Ah, fuck.
Still not right, but closer.
Okay.
This is, if we look at the IR, that's still an address instruction for some reason. Oh, because we're still cogenning the RHS somehow.
It's right here. I found it, right? Yeah.
Okay, yeah, we need to not do that. Just put a break somewhere, maybe. After the assert, does that make sense?
But then we have to cogen the function itself.
We need to code the function. Right.
Ugh.
So we need to somehow store whether this should be... God damn it. So,
Okay, well,
like, make a variable. Yeah, that somewhere.
is special function name handling stupid variable thing?
Almost as long as a name as you'll find in some Java programs.
And when we're here, this is true. If not thing, generate.
Right, let's see. And maybe I usually look at the IR for this because it's easier to see what's going on than in assembly.
Okay, that looks
But
very
yeah,
good.
that looks not bad.
So I need to be here so I can generate debug IR -v. We'll just give it all of it.
Okay, thanks.
Okay, that scared me. I was like, oh, it's gone.
To go up to main. Let's see if it's gone. It's gone. Brilliant. There we go. I think that's it. And you see defun GCD Euclid.
Oh, yes.
So
Uh-oh.
the name is correct. Would you look at that?
Is that's not right.
Is that right? It may be. Because we're not emitting the thing. Oh no, it should never have a store then.
Oh no. Don't, it works. You know, it works.
Wait. Okay, go back to the IR. Go back to the IR.
Okay.
Go back to the IR.
I got it.
It's right, actually. I think it's right because if you see 3 is register R2, 5 is register R3. Those are the parameters.
Okay.
It's just not using 1 and 2 for some reason because the param instructions are still in there, maybe. Oh, right, it never uses 1 or 2 because of the param instructions, I think. That's why.
Yes.
So this is just, yeah. I
That's
think
cool.
this is right, actually.
Okay.
It's just scuffed.
I was like, 3.
The numbering is scuffed, but the II is right.
That's correct. So we have, I'm not going to check all the fives, but when we call Euclid 23,
It's right.
yeah. And we can prove that with GCC.
You can run it. Let's see, is it 8?
Oh, I can't type. There we go. What? Oh,
Hey.
yes.
Nice.
Oh, that was so rough.
That took a while, but we got there in the end.
That's right. It took us another 2 hours. I'm so sorry. And I'll admit, an hour of that is because I'm stubborn and I'm like, nah, it's going to be an AST. For no reason either is what I feel bad about. There's no reason that it has to be not a DAG and just an AST.
Yeah.
But I decided when I made it, I'm like, nah, it's going to be simple, to the point. Everything's a variable. It's an AST.
See, that's the thing. There's a difference between simple and easy.
Yes.
Something is simple and doesn't have a lot of features doesn't mean it's easy to use. Like I like to say C is simple and complicated, and G++ is C++ is what? No, I usually have two adjectives, but right now I can't think of what they are. Like easy and difficult, and simple and complicated. So C is simple and difficult, and G++, not G, C++ is complicated and difficult. That's what I usually say. So simple is
You're
complicated.
you're 100%. Yeah. It's unintuitive. It took me a second to get there, but you're correct.
I haven't said that in a while, so I have to think of it, but that's usually how I explain this. The same thing here, and AST is simpler, but it's harder to use, perhaps. At least I usually don't have these sort of problems with what I call an AST and what a lot of people call an AST, and what mathematically is a directed acyclic graph, but people are just used to calling it AST, even if it's not technically a tree.
So a DAG is a directed acyclic graph, if you're asking Nix Craig, and basically for most things it's very similar. Like for a binary operation, nothing changes. But it can change when all of a sudden this isn't a simple binary operation, but foo. So foo plus 4 in an AST would be like a func call of foo, and then it has another child which has the no arguments, right? None. No params. That's kind of, it's scuffed. It's not perfect. This is how an AST could work with this little thing here. And this func call just stores the string foo, because that's the string that's here in the source code. That's it. Whereas a DAG is a little bit smarter, and of course we have like defun foo as a separate thing in functions, right? Assuming you have like some state. So foo gets saved as a function because it's been created up above, which is important when it comes to the DAG, because that foo, right, has a foo definition or whatever.
Yep.
And in the plus, the binary operation, instead of saying func call to a named function foo, you say it's actually just a pointer to foo definition. And then you may have arguments done in any amount of ways because it's a DAG, but really most of the time it's just the same, where you have a child with none.
Mm-hmm.
Yeah? So here's an example of an AST versus a DAG for the person asking in chat. An AST would parse this as its own entirely, it's just a tree that has no references, no pointers to anything. Each node is self-containing. Whereas the DAG has a pointer to another thing within it, and that actually stores what is being called like foo, because this is the foo definition that it points to. Does that kind of make sense? It's a little bit, it's not backwards, it's just backwards to how I think about it, because foo is a symbol, you need to save the symbol in order to do symbol lookup. Mm-hmm. But you can also argue that the parser already knows there's a function called foo, so if we can resolve that, then we should resolve it into the pointer to foo definition. That way we don't have to get this data later.
The thing is, the main difference between what you're describing as an AST and what I'm describing what is a DAG here and how you get to that is you're missing a pass. The AST, so if I were to write a parser that passes this thing, it would, after the syntactic analysis pass, it would look like your AST there with a literal call to something named foo. However, after that, there's a semantic analysis pass which resolves that call to the actual definition of foo and then inserts a pointer to that in the AST node that is the func call. So after the semantic analysis pass, it would look like the DAG. So I have both. It's just there's a pass in between that does that. And that way you can have order independent functions, but you can directly access the functions in the tree.
So we'd have foo definition here as well. And so what you're saying is you begin by creating this style of tree where you have a foo definition from foo, and then you make an AST with it, right? Mm-hmm. And then you do a pass after this that says a func call to foo actually points to this definition. So just instead of making this its whole own node thing, just make it a pointer to this.
Yeah, what I often do is I'll just put in the name there and have a point that's just empty, like an unresolved. I'll just mark this as unresolved and then resolve it later. Something like that. And you need to do that if you want order independent functions. Like you want to, if you have the definition after the call. A C parser or a C++ parser can directly create the directed acyclic graph simply because it doesn't have order independence. Everything has to be declared before it can be used.
Exactly.
Which, so, with some exceptions, like in structs, you do have order independence in structs, like in member functions of structs.
Yep. Which is confusing.
You can define a function that's defined later on. You can do that. So it's probably a hybrid more or less. But if you're just passing C, you can directly do a semantic. You can do a semantic analysis. You can directly do a semantic analysis, but you don't have to separate the syntactic and semantic analysis.
So this would be syntactic, semantic.
Yeah.
Beautiful. Yeah, I hope that answers the question, Nix Craig. We did our best. Because that's something we've been talking about a lot today. What is a DAG?
Yeah.
Because it's directly related to what we're trying to do, which is, special function name handling, stupid variable thing. I'm going to leave this. This is going in. I thought about renaming it. Nah. Also, I should check more than just GCD. Let's make sure pointers. Well, let's optimized.
Actually, if you want an example of that, you could look at the IR parser.
The IR parser?
Basically, it does that to some extent. Because if you scroll down a bit, you'll find there you passed it already.
This thing?
No. It's a search for like symbol table, and it'll come up. Oh yeah, it's like that. So basically, no, there's some struct somewhere for that. I think they're further up, all the way to the. Yeah, there. Basically, we have these things. So we have a symbol table for temporaries, functions, and blocks. And when it, for instance, has a jump to a block, but it's a forward jump, right? So it doesn't know whether the block exists yet or where it is. So what it does is it just marks it as a jump to. It adds a new entry to this thing and then adds the block that needs to be resolved to the vector. And then when we encounter the block, we can resolve it.
Oh, okay.
It's something like that.
So you create...
It doesn't store the name, it instead creates an empty record. Yeah. So it basically creates a forward declaration. It's just like in C, where you can forward declare a struct by saying struct foo, but you can also say struct foo pointer A, and you can forward declare a struct inside of a variable declaration. In case you didn't know that, it can do struct foo pointer A, and struct foo doesn't need to exist.
That's right.
Need to have been declared before that.
I've done that in casts.
How this works, more or less. It creates an empty record for the thing, and then if we ever encounter it, we resolve it. And at the end, if you scroll further down, there's more macros for that. I think it's resolve all. I think it's called the macro.
This is terrifying. Okay.
Resolve all. Okay. Resolve all. So this iterates over one. Okay,
what has happened?
Your Emacs didn't really.
It's further.
Fucking Christ. Okay, Emacs doesn't know how to handle this thing, but
because the slash after the paren.
Oh yeah, because I put it on a new line. That's why.
Oh, I'll get there. Okay, now if I do this. Okay, it didn't work at all. What I thought would fix it. So, there.
Now you're missing a backslash.
Yeah. So, if I do that, there we go. I did it.
That more or less works, yeah. So basically what this does, it iterates over so this is like a macro because it's the same process for functions and blocks and temporaries. That's why this is like this. It's the same process for all three. But what this basically does, it iterates over everything, and if it finds anything that's unresolved, that's a parse error. And if it otherwise, that's the else branch, it what is it doing? In the else branch, it iterates over all things that use this and set the value.
Ah. That,
This would be so.
yeah.
If we were doing something like this with the calls and functions, the way this would work is when you encounter a call instruction, you try to look up the function. If the function doesn't exist, you create an empty record of a function with that name and add the current call instruction to a list of instructions that need to be resolved. And then at the end you iterate over all the functions and you resolve the calls, because by then you will have passed the function. If not, then that's a pass error if you have an empty record that's unresolved at the end.
That makes a lot of sense.
So this is an example of how you do order independence or slash without forward declarations, because we need this here because we have jumps that go forward.
And it points out how I was just going to be a total mean person. I won't. It points out how the DAG is basically just an AST, but with different semantics when you encounter undefined things.
Something like that, yeah. You transform an AST into a DAG.
Yes. Once you know you're able to, after you've parsed everything. So, all in all, it may be a good idea to like have a section between the parser, a section between the type checker and the code gen that becomes a DAG.
Yeah.
Or we could just do it in the type checker as well and use a DAG, but I feel like that we want to
Sort of. Actually, the process of doing this is
sort of type checking.
Semantic analysis, and type checking is a form of semantic analysis. So yes, checking, for instance, resolving function calls is a part of type checking because it's a type error if you call a function that doesn't exist. So it's basically type checking and semantic analysis are basically not exactly one and the same, but they're very closely linked concepts, and sometimes you can really do them at the same time. Sometimes you can't. You have to do something. There's something you need to resolve first. That happens sometimes. Happened to me before, where I've had to do a separate pass before type checking to just resolve some things. But ideally, you could just do them at the same time.
Oh, I mean,
What is this?
yeah, it's fine. I have these in here. It's fine. I was confused. I was like, I broke something. But factorial, it works. Everything's fine. Even optimized.
So, if you really want to rewrite the parser, I mean, I'll say it how it is. I would suggest going for a recursive descent parser. If you don't want to do that, then that's your decision. It's your project.
It's not recommended.
And after that, I would recommend going to a directed acyclic graph as part of or before type checking. And then we wouldn't need 27 different lists each storing a single thing about every variable.
That's true.
Because that information would just be available, and we wouldn't have to do environment lookups all the time. We could just do the lookup. That's the whole point of it. You do the lookup once for everything in the type checking, and then you store it in the node. You cache it, basically.
Yeah, that's
what it is.
That sounds like a reasonable thing to do, where the type checker, because the type checker is kind of the finishing of the semantic analysis entirely. So if you make it there, you have an AST. It's guaranteed to be like a functional AST. It represents a program that isn't insane. So then at the end of type checking or during it, you can kind of go, hey, now that we know this, all we have to do is make this a pointer to this resolved cached value.
Yeah.
Okay. That's probably worth it. And the type checking, I always knew. I literally have no idea. There's no information on type checking. Mm-hmm. When you look it up, there's like, it's like register allocation.
Yeah, I suppose a lot of that just comes from experience with C and C++ in general. Like, if you think hard enough about how pointer arithmetic works, you know how to type check it. Like, I've never looked up how pointer arithmetic works and how it's type checked because I know how it works. I know you just need to go through all the cases. What happens if you subtract a pointer from a pointer? Does that make sense? Yes. What should the result type be? And so on. Does it make sense to add 2 pointers? No, it does not. So that's a type error.
You have it
So
exactly
add pointers,
correct.
add pointers and so on. You just need to go through all the cases, and that's what I did. And I suppose that if you know the language well enough, and if you know how pointers work in general, you can figure out what the if you know the semantics of something, you can type check it basically.
Yeah.
And
Even
the
though
thing is also, if there's some like thing that you miss in type checking, you'll notice that eventually when the type checker screams at you if you and says that a valid program is incorrect. For instance, even if you have no idea how no return works, you'll sort of get an idea of what you need to do in the type checker as soon as it fails to handle no return correctly. For
exactly,
instance,
exactly.
no return should be is implicitly convertible to any type. You
Which
can
is
do for plus a call that doesn't return because it doesn't matter. The thing doesn't return.
that's confusing.
Yeah, it sounds a bit weird.
But it does
first,
make
but
sense because you
It does
go
make sense.
Yeah.
That's also why if you have built-in unreachable is also convertible to anything because it's unreachable. Like you can never get that.
That's so cool. See, that's some type semantics that I would not expect. That's like
There's languages. There's I forgot which language it was. It's like I think it's like Zig or whatever. There's a language that has no return when no return is a type, and it as a type is implicitly convertible to anything else.
oh my. Store function name in lambda if possible. We didn't do the IR stuff.
I suppose the next two topics that we should address is maybe for optimizations and all of that in the back end. So there's stuff to do in the front end and in the back end. In the back end, that's probably would be sensible to connect to add the interpreter so we can have constant evaluation.
Yes.
Ideally, we would reduce this entire thing to if this factorial is to move 120 into REX and return.
Which is just beautiful.
That's the end goal of this, because all of this is constant. So we should be able to evaluate that at compile time.
We're gonna
That's
write
one thing we do. And the other thing is sort of rewrite the parser and do all of that.
Yeah. Yeah. So, okay, let me look at my list. You basically just outlined everything I have on my list, by the way. So the only things that you didn't outline were I have add byte type. I want to actually make sure the byte type works.
Mm-hmm.
And then part of that is I want to make a string literal equal a byte array.
Nice.
And I feel like that would get us a lot of functionality with like strings and interop with C.
But there's a lot of things we need to do if we want to add a separate type. For instance, every IR instruction needs to be typed then, and also store a type.
Which should be doable.
Mm-hmm.
Well, not every IR instruction, right?
Not every, obviously. Most of them that an add instruction needs to store a type. Well, not even an add, but our operands need to store a type. So a lot of instructions will need to have a type.
So, and the type of the instruction actually refers to, well, if we never stored a byte, like if semantically, so that's the problem. Okay, I see what you're saying.
Mm-hmm.
I see what you're saying now. So when we move into memory, we have to know the type, which means in the back end.
Stack allocate, we need to know the size of the thing. For overflow, we need to know when we add them, we need to use 1 byte registers. So on. When we copy, when we load from an array, we can only need one. We need to load 1 byte and not like however many.
So each instruction has to store its result type. Is that correct?
Yeah. Each instruction that returns a value has a result type.
Okay, that doesn't seem too bad. It's going to be a mess, but it doesn't seem too bad.
Yeah, it is going to be a mess.
What is all this? So
once we have a byte type, we can actually implement casts, because right now casts don't really make sense.
Yeah, not at all.
We could cast any point to an integer, but that's boring.
Very.
What was I going to say? Right, and in the parser, what are your plans for the parser like? Do you want the recursive descent parser? Do you want to sort of refactor this?
So the plan is fully like work backwards from design requirements, right? What do we need? Let's make a parser that can do that. And then however that happens, that's cool. And the least we have to change what we have now is ideal.
Okay, well.
But again, yeah, it's not going to go well. That's why it's long term. So I don't want to like replace the parser, but I do want to make it more readable, not as insane of a control flow, right? With the crazy
Yep.
8 nested if else's, right?
The way I see it, there's two main problems with the parser and the AST. One is the control flow. The other one is expressiveness. Children, next child, next child, next child is not very expressive.
So what if I just created like a function that said nth child?
That's not the problem. The problem is it shouldn't be, oh, this thing is a thing and it has two things in it. It should be this thing is an if has a then branch, and if has an else branch.
Well, that's how it works.
Else and branch, just like IR instructions. So basically, I'd suggest doing the same
What do you
thing that we
mean?
did for IR instructions, but with AST nodes.
Well,
There's a
that's what
node
we
type.
have. What are you talking about? There's a node type, and then a tagged union in the actual node itself with a type and a value. That's the exact same thing as the IR instruction.
It's not the same thing, because, for instance, the operands of a binary operator aren't called left-hand side and right-hand side. They're just a linked list of instructions. That's the problem. It's always just a linked list of children. It's not. They don't have names. And
So-
you sort of need to remember, always look up. You can't just look at code and know what the hell this child is. You always need to go, okay, what is the type of this instruction? Okay,
You have to
in
go
this
up here,
instruction,
yeah,
What is the fourth child? You always need to go back
which
to
is here.
Yeah.
Uh,
That's not very expressive. If you just look at the code, you can't tell what it does.
You're
Because,
correct.
okay,
How would we
this
fix
sets
that?
third child to give them names. Do the same thing that we did in the IR, like have an if node, and the if node actually has a value with
what?
one instruction pointer. That's the condition one that it's then whatever. Like everything that's a comment up there, make it a struct and give it a name.
But then those are all nodes, so you can't have a node within a node as a value. These are nodes. So how do we have a node as within a node? What's your proposal there? We just put a bunch of pointers in here?
Yeah, just pointers.
So
For instance, a binary operator node would have two struct members, one called left-hand side, one called right-hand side, and they'd be node pointers. Something like that. It's just like the value of an R instruction. So for every possible type, we have a value union that contains pointers to other instructions that have proper names. Something like that.
I'd say that's reasonable. Because
It will
currently,
make all of this a whole lot more readable, because right now, if I just look
so
at
that's step one.
code in the parser or in Cogent or in the type checker, all I see is children, next child everywhere, and I have no idea what the next child in this case actually is.
That's fair.
I
It'll
just
probably
I
help.
need to think hard about what it is.
It'll probably help the parser be simplified a lot as well. So, question then, how do we loop over the AST? We'd have to have like some crazy control flow following thing.
You need a function. You need some sort of AST visitor. So you could have a function that, depending on the node, has to do different things then. So you need to switch on the node and have to do different things depending on what node it is.
Which is going to be complicated, and every time we add a new node, we're going to have to add it to that function and add it to, so then we're everywhere that we loop over the nodes, we're going to just have to change every time there's a new instruction.
Correct. It's exactly the same thing that we're doing with the IR right now. Exactly the same thing. Every time we need to do something with an IR instruction, we need to make a switch on the type and do everything.
And there weren't any bugs in the follow control flow code. It was perfect and easy to write.
It's at least more readable than this. If you look at something like in intermediate
worth it?
representation, if you look at like what's a good in where's the thing? What's it called? IRF emit instruction, something like
Okay.
that. If you look, you can either see, okay, this is
Yeah.
a call, we're emitting the name, the callee. If this thing is an ad, we're emitting the left-hand side and right-hand side. If this thing
Where's
is
IRF emit?
a global store, we're emitting the new value and the name, and so on. So you have a switch on the type, and then for each type you have a different action.
Yes.
Something like that.
I mean, I
Whatever.
guess it's fine. It just seems like such an inconvenience to have to literally handle every time.
The thing is, the only difference between there is no difference. You still have to do that. If you look at what we do in CodeGen, we need
Okay.
to switch on a node, and for each
CodeGen.c.
node type, we need to do something different. We already have to do that.
It's true, but so for example, where is it? Let me just look. I could be wrong. I'm gonna fully accept that because you sound very correct and you're making a lot of sense. So I'm doubting myself greatly. But so okay, you're right. It doesn't work that way anymore. Does the type checker work that way? Okay, it doesn't. Look. So this is what I was picturing. We can't go over all the children like this, but we don't do that anymore.
There is no notion of just a child. It doesn't mean anything for a node to just have a child. And nodes of specific types have specific children, but a node doesn't just have a child.
You're correct. Okay, I think you're correct then. I think it's a fully reasonable refactor to work on next, where the parser doesn't just use like a generic doubly linked list type of thing. It uses basically strict structures and unions in the value.
Yeah, because the problem is if you don't, you saw how I noticed when you were writing this entire thing for functions that you'd have to pause and think, what is this now? Because it doesn't have proper names and anything. I think this refactor that would just now would have been much easier if everything was named properly. I have
agree with you.
parts of ASTs before where I just had a vector of child nodes, and the result is always that I would look at code and I had no idea what it was doing because it was just accessing the third child of something.
Which is reasonable from an implementation standpoint. Like when I was beginning this compiler, I didn't even know. So I knew about a tagged union, and I've used it a lot, and I've used it in parsers for Lisp, for an atom. But I've never actually created a compiled language. And I think the parser of a compiled language is like a different beast than the parser of an interpreted one. Or it can be, at least. Because an interpreted parser most likely just generates an AST that's supposed to be immediately evaluated. So everything has to be correct in the AST. And out of the parser, everything's good to go, ready to be evaluated.
Yeah.
And that's what's in my head. So, or at least it was when I was starting this project. But that's not the requirements for this project, which I didn't know in advance. Now that I've done it, I can see that it would have been more beneficial to have, instead of a generic tree structure where I can store children and next child and blah, 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 hard coding everything, while it's harder at the beginning, because you have to code like 30, you know what I mean? 30 different structures. Like the IR at the beginning, we had like, okay, now we have to define IR integer, IR type, and IR call type.
Find it anywhere, and if this is my parser generator, I can take a screenshot of that. It's exactly that. Where the hell is it? Yeah, it's this. You have to do this. I mean, this is in C++, obviously.
Yeah.
But, I mean, I suppose I can post it in the Discord.
We now call functions directly instead of doing indirect calls, if possible.
I've put in code review what I mean.
Legendary. Okay. Why is that weird? Oh, it's wrapping. Okay, I was like, what is happening?
Line wrapping.
So now I can just push all these changes, and hopefully they work everywhere. Code review.
Too many windows.
It is. Okay, I can close Visual Studio. We're done there.
That's good.
Yep,
Always
still
good.
need these open. What is Twitch telling me about? Okay, we're fine. Twitch recap is here. See and share everything we did together in 2022. Fucking Twitch. AST moment.
Yeah, this is basically what you mean, and this is
That's
what
so
I need to do
small.
every time.
It's so small. Okay, that's
Shall I zoom in? And
no, I
make,
did
okay,
it.
then.
I did it. I was figuring it out. Tree node, unique putter. Okay, an AST node containing child nodes. Tree node container.
That's just like a helper. This
Ah.
is what I mean. All of these node types.
Yes, I've done this. I've done this. You just, oh my god, you gave me flashbacks and I hate you. I have PTSD with this structure. This, oh my god.
This is the most memory efficient way to build an AST in C++, unfortunately. Unfortunately, it is the most memory efficient way.
I agree. This is, okay. I'm gonna do it. I don't know where this is, so this may go badly. See, so where, archive. I don't remember where things are. Okay.
GitHub, maybe?
Nope. This was before that. So, oh yeah. Okay. This is years old. I don't even know when I touched this last. This is EV2, a compiled language that I tried to design. And it's horrible. It doesn't work. And I couldn't get it to work. I was very mad.
Mm-hmm.
And I tried to do things efficiently. Like, I'm going to use an unordered map to store human readable token types of token type to everything seems reasonable. And it was fine. Everything was fine. Until I tried to actually compile this, because do you know what I tried to do?
Write the entire thing without compiling once.
Oh no, so the program itself runs. Everything's fine.
Oh, okay.
It parses just fine. Oh my god, I hate this. And it's a recursive descent parser, as you can see. Like here's parse expression, and here it calls parse expression on the right side.
Operator, yeah. Mm-hmm.
It's very simple. This was years ago.
Mm-hmm.
And I was just proud when I finally was able to parse a function call. That's where I was at when I was making this, right? Mm-hmm. And if we're going to get down there eventually, here's parse program.
Mm-hmm.
I tried to make a class, which was a code generator for a specific thing. This is just stupid. I can see now. This should just be a CodeGen class. And if it is a CodeGen class, it should inherit from a CodeGen class which has virtual or abstract. I wouldn't do it like this now. Either way, this is how I did it. And generate expression node code. Are you ready? I would, if the left-hand side is an operator, I would move it. Look at this. Do you see this?
It's moving into R13.
From R14, which is past here.
Interesting. So you're hard coding the registers.
Yeah.
For well.
And then it worked. Here's the thing. This works. I wrote it down on paper and I came up with a thing that works. Mm-hmm. And it's horrible. And it's stupid. because all the registers are hard-coded. I didn't even know register allocation was a thing. I literally came up with this from scratch. I was like, how do I generate code? I'm an idiot. I know assembly. How do I generate it? And it resulted in things like this, where if something is on the right-hand side, if children at 1 versus if children at 0, then you handle them completely differently in different registers.
Yes.
And the reason I did this is because, 1, I came up with the thing on paper. Yes, it supports string literals. Don't worry about it. It all worked. And in doing so, I realized this is horrible. And I can't remember what I did next. Is it called P? I think it was called P, which is just funny. And this one, P is my implementation of a programming language. I'm trying to implement any. I'm like, just a programming language is what I want. It is nowhere near complete and likely never will be. Exactly. This whole project will be canned and restarted multiple times.
That's how it goes.
Oh, I do like that sentence. But that just may yield a clarified carbon in the denticulate. Oh, that hits hard. I bow to you. That's all I got. Ugh. I don't even know why I wrote that. Anyway, this one.
Generator, jeez.
This one is never even got past parsing.
Okay.
And in doing so, I eventually brought myself. I don't even know what I called it. Is it Mirai? I made too many of these, man.
Really isn't that many, trust me.
These aren't the only ones. This is the like I'm working on it for months folder. So then there was Mirai, where I tried to have an assembly factory, which took in a different template architecture, and would generate different programs based on the architecture. Never got past 1, but in this one, I believe the parser. So where's parser.h? Did I put it like in include? I don't know.
That would make sense.
Yeah. There's just no H. Oh, it's
There we go.
It's within the source folder. That's why it got me.
Oh, it's the include folder is in the source folder. Of course it is.
Yes. Okay, in this, I tried to have a syntax tree node. And you can see this one, I have a vector of children, which is exactly what you talked about. And this was horrible as well. Because in the parser, printing a tree node, you have no idea what it is or what its children are. So you just print it. You go, yeah, here's the value. So in this, this is where I came up with a much better error handling, though. I had like a custom error status enum and then returned it. And that's where I came up with the whole error struct. But here's the thing. It's horrible because, yes, we parsed it. It's not too bad. It's like 200 lines. It's an easy parser. We can't do anything with it. That's where this project ended. I was like, okay, we parsed it. We can try and make an assembly factory. And here, let's look at what it output. There you go. Mirai function definition from probably main.mirai. Yeah, there you go. So here's Mirai. So we have fn add, which is a uarch. By the way, do you notice the syntax?
Hell yeah.
Little familiar with no semicolon.
Oh, I see now.
I know. This is an old one. This is like a year old. Maybe a year and a half now. Anyway, you can see I have uarch, which is like the architecture size integer, like pointer size.
U size, basically, yeah.
This went, I got all the way to an assembly factory. There's no intermediate representation. It's just direct AST to code. And guess what? I just used racks. I used the same exact. I used the same thing. I did not do better about it at all.
Uh-huh.
As you can see.
Mm-hmm.
You know how when you call a function, it returns its value in racks? That's what I did for constants.
Ah.
And for everything, including expressions, assignments, variable declarations, etc.
Okay, so everything just dumps its result in racks. Okay.
Yep. And if it needs to save it, it saves it explicitly.
I see.
This is horrible. Ugh. This didn't get very far. But all of these were to avoid. I don't think
Well, you
I.
have the template specialization there. For assembly factory.
Yeah, it's for the only one architecture. This is how we could have one assembly factory for all architectures. It didn't work, but I did try. I don't remember where I put this one, so it's probably not here. Yeah. I may have deleted it because I was so angry. Do you know the LLVM programming tutorial?
Ah, yes. Yeah.
That made me hate LLVM and that whatever you posted oh my god, I hate it. And now you know why. All of that, I literally went through it for months because this stupid, oh my god, where is it? It starts with a K. That's all I know.
Kaleidoscope is what it's called.
Kaleidoscope. Oh my god, I want to die.
It's really bad.
It's so
Tutorials.
oh my god.
I'm writing tutorials. Or,
This-
as I usually put it,
LLVM tutorials are great if you already know what you're doing.
If you work at LLVM. And if you look at this horrible
You make virtual, yeah.
so they
Make it
want
virtual.
they wanted this structure I could not figure out for the life of me. And then on top of that, I finally got this structure working. We're like, oh my god, it's so complicated. There's virtuals and implementations and Jesus. Finally got it working. It was great. Guess what? I couldn't link with LLVM. I wanted to die. I was like, this is ridiculous.
Did you try and follow the CMake tutorial? Did it not work, I wonder? Did you...
The way you link against LLVM is you do target linked libraries LLVM in all caps dash version. So LLVM dash 13. That's all you need to do. They'll tell you, okay, you need these 20 lines of CMake that compute the LLVM. But no, you don't need LLVM dash 13. That's how you link against LLVM.
See, I wasn't even using CMake. I was using Visual Studio.
Oh, that's even worse. Okay.
Yeah. And there's all the instructions are outdated and they're not right and nothing works. And I try to get people to help me and they go, oh, did you try this? Oh, what about this? What about this thing? Oh, well then I don't know. And it's like, fuck. So then all this work into this giant programming language I just threw away. I was like, okay, I can't link against it. Screw it. And that's probably when I deleted it because this crap, include LLVM, would not work. I could not get it to work. I tried to use pre-compiled versions of LLVM. I tried to compile LLVM myself. I tried everything. I could not get it to link. And I'm sure I could do it now in 10 seconds. I just didn't know how C++ worked. And
Linking against LLVM is a hard thing to do, though, and also libclan. I'm currently looking through if I can find the thing.
And that's exactly what I was trying to do. And that made me I hated it. I was like, I'm not going to use Visual Studio. I'm not going to use LLVM. And I'm not going to use whatever this syntax is or this structure because I hate it. But you're correct in that it's probably the right way to do things. It's at least the most efficient.
So this is how I link against libtooling.
Oh my.
Yeah.
This is why. I'm not
just LLVM is just like that. But libtooling, just LLVM is just LLVM 13. But lib tooling is all the stuff above, otherwise it wouldn't work for me.
Lol. Nisgreg says, CMake Pepe laugh. What, do you not like CMake or do you like CMake? I don't know how to interpret that. Is it like CMake? Oh my god, in 2022? Or is it like, ooh, CMake? I don't like CMake.
Interesting project. It's also part of a programming language, but it uses LLVM to parse C and generate types from C headers and function signatures.
Oh no.
You can just include a C header and it works.
Nix Craig, that's totally fair. He says, well, to be honest, I don't like any of the build systems for C or C++.
Yeah, because there's nothing to like about any of them.
Honestly. Yep, you're correct. It's not like I like them. I just use them.
Not that we don't use CMake because CMake is good. We use it because it's the least bad.
That's right. That's right. That's the exact thing. I love watching all my naming conventions change over time.
Yeah, I usually have two. I use either Pascal case or Snake case, and I sometimes switch between the two depending on what project I'm in.
God.
And sometimes you'll see sometimes I just change my mind, and then you'll see a commit that just changes everything from Pascal case to Snake case, or vice versa.
See, I need to do that in the OS. Right now it's just a mess.
Like I recently did a commit for a web server that we have, and .org, and it's just 7,000 lines of changes, all white space, replacing tabs with spaces.
Make file go burr. Mm-hmm. Well, Emacs crashed again.
What a surprise.
Nix Craig says, I've been spoiled by cargo. Okay, I hate package managers. I'm just going to get out there. All of them. I don't like any of them. It's not like I dislike cargo, like cargo sucks. I just dislike how cargo is used as a package manager in general. And if I had to use another one, I would hate it too. It's okay. It reminds me of Node.js, and that's why I don't like it. It's the exact same thing, and people don't want to admit it. They're like, "Oh no, it's fine. It's great. Everything's perfect. Cargo's awesome." It's like, yes, but also it's way too easy to include 18 million dependencies and then just end up with bloat.jpg.
It's also that I find with not just I'm gonna look up this thing. Maybe you are better at reading documentation than me, but I have a challenge for you, more or less. Can I find this really quick?
What is it?
There you go.
It's hard to center.
Where the hell is that? I need to find the LLVM tutorial. Is it this? Is it really this? I don't think it is this. Is it this?
Okay.
It is not this. Okay, I can't even seem to find the LLVM tutorial right now. Yeah, there we go. This is the I'm just gonna put this in here as well. The docs for lib tooling. And if you want to write a simple tool using Clang that like passes a C file and emits some stuff about it,
Treester.
I want you to take a look at that and see if you can figure out what you need to do.
Okay, so we're looking at this. Linking against libtooling be like, yes.
Yeah, we'll just do that.
What is this?
This is the link. If you can figure out what to do here.
For the information on how to set up Clang tooling for LLVM. What? So tools built with libtooling like Clang plugins run front-end actions over code. In this tutorial, demonstrate the different ways of running Clang's syntax-only action, which runs a quick syntax check over a bunch. I love a bunch. How much code? A bunch.
A bunch.
Ton. It is a ton of code. A bunch. Not a file. Not a snippet. Not a page. It's just a bunch. However much. Nix Craig is describing exactly how everyone working with LLVM tools feels. Oh yeah, I tried using libtooling, gave up after about 2 weeks of no progress. That's exactly correct. See, here's a code snippet. Where's the code bunch? How do we parse a code bunch? That's what I'm curious about. So if we parse a code snippet, what? What? Okay, why is there a test here? Why are we writing a unit test? Hold on. What is happening? This does okay. Immediately, I'm 2 paragraphs in.
It iterates over code and executes some stuff on it. That's all it does.
Here's a test. Fuck.
Yeah. This is the tutorial for lib tooling.
Run tool, not tool. Run 2L on code returns whether the action was correctly run over the given code. So not the tool. So run 2L on code actually means run action on code.
Something like that.
That totally, okay, makes sense. Test, run tool on code can syntax check code. What is that? What is test? So if it's not a unit test, are you testing like that you can syntax check code? What does this even mean?
Oh, this is brilliant.
Okay, we write a standalone tool. Oh yeah, that'll be good. Now that we can't even use it, let's write a standalone tool ourselves that uses it. Okay. I hate this. The fact that there's like a common options parser, that should to me it seems so backwards. For an OS to implement this would make sense. Because then every main function could handle options in the same exact way, and every program on the platform, on the OS, would have the same interface. But why would you make it where just LLVM provides, oh yeah, here's a common options parser? What is that part of? How is that a compiler? What does LLVM even make? I'm so confused. They're like, yeah, here's an options parser. There's nothing else here. This is the example. Like, here's how to parse options. What? What is it telling us? It can be read from a build directory or the command line. Using common options parser allows for explicit specification of a specification of build path and automatic location of the compilation database using source files paths. And then they give you an example of how to use common options parser. So that's how to use libtooling, is you just use the common options parser and you're done.
Basically, the mistake, the obvious glaring one that you've made, is that you've read past the first paragraph. The only thing you need is the first code block. Run tool on code is the only function in this tutorial that you need.
That's not even it's a portion of the first code block.
The rest need to sort of glue together, but basically everything after this paragraph is irrelevant. The entire writing a standalone tool thing, more or less ignore most of that. Most of that is irrelevant.
Introduction. This is why I hate LLVM.
Actually,
they talk down to you.
Like, if you want to actually figure out to do something, you need to go somewhere else. So, because basically what you need to do, I can post some snippets from this project.
God.
Yeah, don't look at the CMake files. It's pointless. So basically,
God.
The main thing you need is something like this.
Oh, I just opened Guild Wars 2. Oh, don't leak me! Don't leak my email, please. Okay, thank God it had an update to download. Okay, I'm. Oh my God, everything's breaking. Don't open Guild Wars 2. I just pressed the X and it reopened. God. Okay.
Now you can task kill it.
I'm just gonna start playing Guild Wars 2.
There's a task manager to kill the program if need be. Anyway. First one is basically you need an AST. I called it AST walk context for some reason. You need an AST matcher that defines a list of callbacks. So basically it will run this thing on the AST. You can define some callbacks to be called on certain parts of the AST. That's all you need.
Okay, close. Please close. Okay, it closed finally. I can show this. I'm sorry.
This is like the top of this class, basically. Ignore most of this. you see a virtual void run that takes a match result, and then you can get the node at something and blah blah. And there's an AST matcher defined somewhere. Where the hell is it? Where is the matcher actually? That's a good question. Where did I put that? It's somewhere.
Oh
Basically
my
match
god.
of an AST. Yeah. That is what you need to do basically. Yeah, this runs a tool, and the new front-end action factory. Yeah, you need to add a match finder, and then you need to add a matcher to that. The matcher that's the actual thing you want to match. So here we're matching a translation unit decal, and that we're giving that translation unit decal the name D. So we're basically matching the entire file, right?
Yes.
And then using that matcher, we can use the thing in the previous image. If you look at that again, where it says get node as translation decal D. We gave it the name D. Now we're getting the thing that we're matching, and now we can iterate over the AST and do stuff with it in here. And you can also change the matcher to be match all for loops or whatever, and then you can get them like that.
I don't like this
is
anymore.
how you use lib tooling.
I'm not
Actually.
I'm not having fun anymore.
Yeah.
What is this?
And then run tool on call with args is basically just that. It just runs this thing. Then
It just calls run.
runs the matcher. It matches the AST, and then it calls this thing with the result of the matcher.
Why did they do this?
Much simpler than the tutorial.
It
You
is.
don't need any of that other nonsense, no command line options, but you don't need any of that.
Well,
You just need run tool on code and an AST matcher.
what?
Rest of it is irrelevant. That doesn't matter. No one cares about that.
You can run clang check on a file in the LLVM repository by specifying all the needed parameters after a dash dash separator. What does this have to do with anything? What is clang check?
This is what I meant when I said if you scroll all the way up,
It makes
The only
sense.
it's run tool on code. In this case, run tool on code with args. Let's just specify like include paths or whatever. And you can. The way I found out about that function is by just looking at the declaration in
Oh my.
the header. That's typically how you figure out how LLVM works. You look at the source code because the documentation sucks. The only part of the documentation which is good is the LLVM IR documentation. That's good. But other than that, it's like, even like the compiler flags documentation sucks. Like if you look at Clang compiler flags, it's just horrible.
It's terrifying, yeah.
Horrible. I mean, I'm gonna put. Suppose I can post that like in chat even here. You just
Nice.
scroll down a bit and look at the descriptions of flags.
Compilation
Scroll
flags.
down in the middle of the page. Yeah.
There you go. So, PTXS path to PTXS. There you go. That's
Even if you like search for any warning, do like W. Well, what do we have? What kind of warnings do we have?
W no.
We have W for instance. What kind of warnings do we have?
Volatile.
Whatever, yeah, something.
It doesn't exist.
I'm not in here, so maybe there's somewhere else.
There's Clang CL options. Oh no. This is just the compiler.
Is this just the compiler, not the driver? Okay. Clang.
Oh my god.
Clang command line options.
What? Try configuring Clang format. Ha! I'll continue to use Emacs. I like how some of them don't even have descriptions. Like, what's
Okay,
private
what
underscore bundle?
W no on use
go.
whatever, something like that.
Private bundle.
Of course, it's not compiler options. I was looking at diagnostic flags, so the diagnostic reference. That's what I meant. This one here. And yeah, configuring Clang format is also quite something. So look
Oh
at
no.
just click on any of them. Click on any of them and read the description. What does it do? Who knows?
It's enabled.
Stable.
What is ignored? What?
That's all you get. It gives you the warnings that you give. That's all you get. You don't get a description. It just gives you the text.
There's not
That's-
even.
That's the documentation of clang diagnostics.
Who wrote this? Who wrote this? Somebody spent too much time
You
displaying.
don't know what a warning means. You look it
Oh
up here, and
my
the only thing
God.
you get is the text of the warning. Like if you scroll down a bit, you'll see what I mean. Yeah. What does ignored availability without SDK settings mean? As the warning, figure it out.
Okay, if I ever write documentation like this, can you kill me? Like, can you fly to where I live and kill me?
I promise.
Because that's literally, you're not supposed to do this. Okay, if you've ever localized anything, like translated into multiple languages, you're not supposed to do this stuff. You're not supposed to use language that has like, oh, you can use has or have depending on what it should be.
Really?
And then the S.
It's not like different languages have different word orders and different ways of conjugating verbs, and it's not like not every language has a concept of a different form for just the third person plural, right?
What is this?
Or plural in this case.
There's just space. What?
Brilliant,
Yeah.
isn't it?
Qualifier space or S. Yeah. I love qualifier space. All my homies love qualifier space. Fuck qualifiers. This just doesn't make any sense. Oh, good.
Yeah.
Good. Implicit int. I'm glad it describes the simplest thing, warning. I'm good it describes what it does. The hell? This is ridiculous.
Yeah, this is the clang diagnostic reference. Good luck trying to figure out what some of the warnings that might be a bit more exotic mean.
Who made this? Who's Sphinx? We gotta find him.
Who made this?
I know.
The clang team, apparently.
Okay, new plan. Assassinate the Clang team. No, we're just gonna volunteer to write explanations for all this shit. It can't be that hard.
It can't be that hard. Look at the GCC documentation for diagnostics. Do you want to see the difference?
Okay.
GCC diagnostics.
One of them is usable.
Hold on, where are they? Diagnostics.
Isn't there just a bunch of lists?
GCC warning. I closed the tab on accident.
Control Q?
Damn it. Control W, yeah. There we go. Night and day.
Are you ready?
It's incredible.
Are you ready? Oh. Let's
It
just
tells you what the thing does. Would you look at that?
Boink.
Scroll down any obscure W3 non-heap object. What does this do? There's a paragraph explaining it.
And an example.
And the code snippet even.
Oh. And it where is it included? In wall.
Yep.
No frame larger than. Disable frame larger than warnings. This option is
Oh, wow.
equivalent. They give equivalence.
And that's just W and no. I mean, there's not much explanation then. For the actual explanation, what this flag is, look the one above it. It's directly above it.
Oh, look at that. They even put them next to each other. Oh. Oh. This is amazing. It's literally, what is this? I feel like I'm at Chuck E. Cheese's right now. Eating, like, I'm just eating cardboard pizza. And I'm like, this is sort of like pizza. This is sort of like warnings. You know, docs. I see pepperoni. You know, a little bit of bread or dough. I don't know what it is, honestly. It smells bad.
It's like the serving a pizza in like one of these cardboard boxes, but instead of giving you, they do the opposite thing. Like instead of throwing away the box and giving you a pizza, they throw away the pizza, give you the box to eat.
Yes. Yes.
It's like,
It's not a pizza in a box. It's a box in a pizza.
yeah, the box around the pizza.
I just love that idea. Like this, you go, oh, look, you got some pepperoni. You got, you know, cheese, actual cheese. You have like, what is this? Maybe some chicken, maybe some peppers. What do you like on pizza? Pineapple? Go crazy with it, you know? And then it's like, oh, they have more. It's not only that, they have more. There's like garlic powder in the sauce. It's amazing.
LLVM is comically bad, and Clang, by extension, are comically bad at writing tutorials. The only reference that is okay, there's two. The Clang format docs are a bit huge, but they make sense. Like there's a lot of options for Clang format. And the LLVMIR reference. Those are good. Other than that,
Look at how they are so detailed in what each one does. But no. Clang's like, it's enabled by default, you know? And what is it? It's enabled by default. That's what it is. Yeah, it's enabled. Oh, good. Good. Glad I could figure that one out. What is they're even thinking? Are they thinking that they're self-explanatory?
yeah, but that's not an argument because some of these very much aren't. Let's see if I can find a Go one.
Okay, this is definitely a confusing one. Visibility?
Yeah. Do you know what visibility is in this case?
No. It's not visible.
Symbols in a shared library. A visible symbol is basically global, and non-visible is internal and hidden. You can't
So
access
static
them.
versus not in C.
Sorta. That's linkage. That's a bit different. But yeah, basically, yeah, sorta.
And they couldn't have just written that. It's too hard. You know what I mean? They're like, what you expect the people who make LLVM, the Clang team, you expect them to like write meaningful English sentences? No.
Something like W final macro.
W final macro?
Yep. W final dash macro.
Macro A has been marked as final and should not be.
What does that mean? What is a final macro? I have no idea. Glad that they explain it so well.
I don't know. I'm trying to think about it. A macro has been marked as final. That doesn't make any sense. A macro, can you... Okay, that's horrible. Macros are supposed to be redefined.
Well,
Sort of. Undefined and redefined. So what is are they all final?
I don't know.
There's
What
no
do
way
you
to
mean,
know. That's the horrible part. There's literally no way to know other than to try it.
W encode type. I don't know what that one does either.
Encode?
Encode type.
Encoding of a type is incomplete because B component has unknown encoding.
Wow.
Okay, that might be the most confusing one. What is this? What?
Brilliant.
Synonym for Wextra tokens.
Yeah, do you know why?
Why?
What this refers to?
No.
This is if you have extra stuff in an endif directive, and it doesn't do anything, so that's a warning.
So, okay.
If you
Yeah,
have endif,
luckily they clearly explain that. They don't at all. Also, isn't it... This is in alphabetical order, isn't it?
I think so.
A, B, C, D, E, F, G, H,
I
I.
think so. I think it is. Why?
Yeah, yeah. W, GNU.
Wow. Brilliant.
They've implemented GNU warnings under their own names.
Two extensions. So
Okay, so it just warns you if it's a GNU extension.
yeah.
Use of ternary conditional expression extension, omitting
Yeah,
middle.
basically, you can omit the middle term in a ternary, and then it's the same as the left-hand side.
Oh, I didn't know that.
Instead of doing A question B colon C, you can just do A question colon C, and that's the same as A question A colon C. So it
I
repeats
actually-
the term on the left-hand side. And yes, it is called the Elvis operator because someone mentioned that.
This is, yes, you are correct. I knew about the ternary operator, the Elvis operator, ternary conditional operator, but I didn't know you could put them together and
Only
omit the
called
middle
Elvis
operand.
operator if it's put together like that. Otherwise, it's just the ternary operator.
Oh, I see. See, I didn't know that. That's good to know.
It's the Elvis operator.
I don't think I would learn anything if I read this entire thing.
Yeah.
It just says the names.
This is why I say LVM docs are great. If you know what you're looking for, you just forgot how it's spelled or something like that. Because then you can find the warning in here if you know what the warning is, but you just forgot what the spelling is. But otherwise, yeah. That one is funny.
Oh, because 2 to the power of 4 and it looks like XOR if you write it like
I've
a
actually had that happen
rich
before,
text.
with a student who tried using that in Java. And I had to explain to them that compiles, but it's not what you think it is.
Yes.
Because what's worse than in the assignment they wrote 2. In the assignment they wrote 2 to the power 4 with like the XOR operator, because it's like in text it makes sense, but not in code.
That's true.
So that's
yeah. I do just enjoy changing small things and watching Treesitter freak out and see what it changes.
Mm-hmm.
Like else is only a keyword following an if in a body.
Mm.
So if you have if a else, it's not highlighted. Or if you have...
Yeah.
Oh, it's beautiful.
Mm-hmm.
This makes no sense. Clang, you are the reason that I am eternally depressed and I hate you. And GCC, you're awesome. Thanks for doing everything you did. No, I'm just kidding. Clang has its use cases, but it's clearly not as usable as some of the other compilers.
Yeah. The thing really is with LVM, you have to know how to use it. If you do something wrong, then, well, sucks to be you. Yeah, that one, I see that all the time.
Oh no.
Yeah, that's if you have indentation that's kind of stupid.
It's not issued. So even if it's enabled, this won't break it.
Yeah, because this makes sense. This is not incorrect. Actually, well, this may be in... Yeah, I mean...
This is scary.
This is scary. This is a bit interesting, but...
I bet you we could come up with an exploit surrounding this.
Maybe, yep. Also, the thing about libtooling is, like, I'm using it to pass C headers and just generate function signatures for it. Like, it's pretty good at doing that. It also takes like 10 seconds to compile every time. Just this file.
No. Oh no.
And it's like code only, so that's that. But yeah. Yeah, if you ever want to like iterate over C code or pass C code, libtooling is pretty good if you know how to use it. So it is a very good library, but the tutorials suck.
AKA, if you helped write it, go ahead and use it. Otherwise, maybe think about something else.
Yeah.
Yeah, here's factorial. We've been doing this for like 5 hours, so it's probably time for me to go. Oh, it's very much time for me to go. Rip.
5.5 hours even, yeah.
Okay. Oh god. I just break something? Okay. It's fine. Don't worry about it. It's fine. I won't even look at it. I hate how easy it is to... I feel like Mr. Magoo when I go through life. Like, I can be sitting still and I hit my head or I stub my toe. And it's like, how... I feel like I just find ways to to screw my own life over. My body is like, hey, what if we fell over right now? And I'm like sitting down. It's like, well, how would that work? And then my body just falls over. And I'm like, oh, I hit my toe. It's like, why'd I fall over? I don't know. I just was up and then I wasn't. I really like... I know I keep saying this over and over. I really like Treesitter. It's gonna be such a big thing for Emacs. I should set up Treesitter with C mode. We'll get like in C++, we'll get member highlighting different from globals and enum highlighting.
Though you need a proper LSP for that. Do it properly in the long run, because C might work, but C++ is just very complicated, and so.
I think there's a C++ TS mode. I don't want to go crazy.
I mean, I don't think Treeseater can actually parse C++ properly, but it can try.
Yeah, it's just part of C TS mode.
Yeah.
It creates a tree sitter
Try
parser.
C++, but it won't get too far, I think, unless it's actually using a C. Because the thing is, parsing
okay.
C can be annoying, especially because of the declaration syntax. But at the end of the day, it's not that hard to do. Like, it's fairly straightforward, except for maybe declarations. Parsing C++ is something that only a C++ compiler can do, really.
I think it would work pretty well. Based on what I've seen in Tree Sitter, it has done nothing but impress me. I thought it was going to be dumb and like not really any different than non-Tree Sitter, but it is a big difference.
Seeing the C++ BNF.
I don't know if I want to.
Well, you don't get to choose that.
Oh no. So a bunch of keywords for C++. We have all the keywords. We have all the. We should have a lot of it. Yeah.
We have constival or something. Let's see.
Yeah, constival. I mean, this was made this year.
Return and co-yield. Okay, good.
What do we else? Oh, else auto.
I mean, there's a lot of compiler extensions that are not in there. Friend is in there twice for some reason.
Well, that's interesting. Time to submit a patch to the mailing list. I know what to do. Nick's Crage says
C++ BNF in chat.
Nice. Going to it. Can I see it? Can't see it.
Look at the scroll bar.
Oh no. Oh no. Why?
There you go. Past that.
I'm pretty sure the tree sitter C++ one should do that. Should it not? I don't know. Let me look. I have to look it up now. I'm Googling on stream. This is so dangerous.
You know what the problem is with parsing C++?
What's up?
Is that part of,
There you go.
like, in order to parse C++ properly to get a proper AST, you need const expr evaluation.
They linked back to the same spot.
So,
I mean,
they have a full constant evaluator built in. Then it can pass C++ sort of, but actually pass 100% of
Grammar.
C++ is very hard to do.
You are probably right. There's probably some things we're missing, like const expr and const eval stuff.
Because the thing is, it's not just const expr. The thing is, you can use a call to a const expr function as a template argument, and depending on that, instantiate a template that, depending on whether the function returns 1 or 0, it has a member called foo that is either a type or a variable, depending on whether the template is the const expr call returns 1 or 0 or whatever. So you can do complex stuff like that where you don't even know if something is a type or a variable unless you evaluate that const expr function.
Yeah, that definitely won't work. But I mean, unless you're doing that one very specific use case, it should handle it, right? Object aside.
Yeah, but what I'm saying is if you want like completion or so, then you need a proper language server for that. Syntax,
Yes, tree sitter. Well, tree sitter has nothing to do with completion.
Yeah.
Which is the good part. It's just syntax highlighting, which is why it's so fast. Whereas completion is now kind of where it already is, where we have company, right? Or at least I use company, which has, it's like backends. Yeah, and this is how you configure it. Where it uses these different eLisp functions to actually find what you mean. And capf, completion at point forward, right? That means that whatever is at your point, like if you're in li, well then it'll say, capf will say pass li to the completion backend, and it will give you st if it sees list somewhere else. And CapF is where language servers hook in. So company actually uses this, not company, but ClangD actually uses CapF so that when I'm in, for example, a C file, a C file, then I do actually get meaningful completions if I turn on comp mode, of course. Signed, unsigned, string. You can see it's not doing well right now.
Yeah.
Signal is not there.
My experience in C++ that I've yet to get proper syntax or actually completion
So,
for C++ in Emacs. I've never managed to do that.
so have you used alt slash, meta slash?
I don't think so. I'm not sure.
Meta slash is deabriv. Are you ready for that same sig? Okay, it did sig info, then signal. It was close. It did the closest one that matched sig. So deabriv literally just searches backwards in the current buffer for the same start, and then whatever it found, for example, sig info t, it'll just insert that. And if you press it again, boom, signal,
I suppose.
sigabert,
Yeah, but what if I
sigil.
want auto completion for string view, standard string view right now?
So, well, there's no string view in this context, but what would happen is that if you have a buffer open that said string view in it anywhere, it would find that completion. See, like, for example, max alto stir base 8 count is somewhere in the standard lib of Windows, right? And it's just picking that up because ClangD reports it. But deabriv wouldn't actually find that, but it would find, for example, string, because we have string.h right here.
Does what's it called, tree sitter handle? Can it highlight like global variables differently from regular variables and so on? Or
Only if there's a
enumerated?
way in the... Okay, yes and no. Tree sitter itself just creates the parser. So if the parser can output different things based on the syntax of this is global or this is not, then it can definitely just hook right into tree sitter and highlight those things.
I see.
But what often happens is you end up with, like in CTS mode, you end up with syntax highlighting coming from tree sitter, and then certain things are applied on top of it. But that's not done in these new tree sitter modes because they're brand new.
I see.
But for example, you would say you can do your own queries. And then, where is it? Query. Okay. They did it, they did it a bit odd. But you can basically query like parent is this. So if the parent is a certain thing or has no parent, right? Then you could check that. So if the parent of a init declarator or a like a variable declaration, if we don't go by this crazy list, if the parent of a variable declaration is null or nil, doesn't exist, then you could highlight it as its own thing or indent it differently. Or... So you can build on top of the tree sitter parser output and query it and basically do different things. Here's more queries. So like a preprocessor if def, then it finds the name identifier and then puts it a variable name. Whereas you can also do anything in here in the queries. Like you can run any Lisp. So you can run when equal mode CPP, then highlight this in the font lock constant face. So what you would have to do is like when equal mode CPP, highlight certain things based on the queries. What was your exact question? You said how to highlight...
global variables or enumerators.
Yes, so that's definitely doable. Because you could basically use the parent is query for that. Because you could say if parent is a certain thing. And then you would just say if parent is translation unit or like global scope, whatever you call it. Like in mine, I called it source file, I think.
Okay, so it knows what the variable is defined.
As much as the AST does. Yes. Because it just builds... Tree sitter just builds the AST directly. as far as I
It's
know.
not-
Can I do this? Tree sitter highlight parse. Yeah, I don't even need. Can I just give it pointers? There we go. So this is
I
for
see.
our fun compiler. This is what it
Uh-huh.
outputs. And you can
Uh-huh.
do queries on like the parent. So statement declaration, parent would be a lambda.
Yeah.
But the
Makes
statement
sense.
function parent would be source file. And then you could say, oh, if parent is source file of a function, highlight it this way. And that's basically what it does in its regular mode.
I see.
Ta-da-da-da.
So, be right back. Okay, in a few minutes.
Okay, I'm going to start winding down the stream. And then when you get back, we'll end it.
Okay, we'll see.
Okay.
Bye.
Well, that's it. We did it. Tsoding? What? The Tsoding? Are you kidding me? Are you here? I'm so sorry I missed your message, Mr. Tsoding. I really like your videos. Ooh. Autocompletion is an unsolved computer science problem. That is 100% true. Man, Mr. Tsoding. I feel so I am honored. Oh! He's here. Oh! Oh, he gave me the Tsoding weed. How's it going, Tsoding? Oh my god, it's so amazing. I've watched your videos for a year now. I really like them. You are a large part of why I even use Emacs. I love Emacs. And I have you to thank for that. So thank you, Tsoding. I'm so happy. Oh my god. I'm pretty sure Sir Aid, he just left. He's gonna die when when he realizes he just left. Oh my god. Nix Craig says tree sorter querying is really nice. It is. It is really nice. Because these are actually... It's basically... It's an amazing syntax to query things. It's really cool. Because you have this AST, and you can do anything with it. And that's so cool. Tree sorter realized that. Tsoding says, I'm glad you like my videos. I personally hate them. I watch them back and I sound like a grumpy old man. Oh, I feel so bad. You're correct. You don't sound like a grumpy old man, but I understand that feeling when you watch yourself back and you're like, why am I saying, like, I just went on a 10-minute rant for no reason. Just for this, nothing. But people love that, Tsoding. I will let you know. I love that. I love when you talk about, like, for 10 minutes, you go on a rant and like, this is ridiculous. How has this happened? Computer science is so much more advanced than this, and this is where we're at. This is dumb. But at the same time, it's like, have you seen what we just went through with the, oh man, where even were we? Here, I'm going to leak my history on stream just for Mr. Tsoding. We were looking at warnings. This is an example of one of those rants that we go on, right? And I totally understand where you're coming from. Where we were looking at, for example, GCC warning options. And if you go there's tons of warnings, but if you just pick one, array compare, warn about equality and relational comparisons between two operands of array type. This comparison is deprecated. Tsoding says, oh god, GCC. Yeah, it seems like GCC docs are like not ideal. But then you go to Clang. Where are the docs? It just says the warning text. What? Clang? What are you talking about? And it's like, oh, new returns null. So, Tsoding just with the lol. It's true though. They're like literally, oh, here's a move vbase, multiple move vbase. It's enabled by default, just so you know. That's what it does. It's enabled. What is it? Enabled. There you go. Move vbase. We were literally on a 10-minute rant about this, just complaining like, look at how careful GCC is in describing each and every one of their warnings and laying them out in a way that makes sense, where all of the discarded qualifiers are in one spot instead of in Clang where they're literally in alphabetical order. Literally I, K, L. Oh, wait, what's going to come next? Is it M? Oh, it's M. They're literally just in any order. They don't even care. And I know I sound like an old, grumpy old man right now, but I know at the same time that I'm right. There's no way that Clang wrote this and was like, yeah, this is good documentation. When all you do is copy and paste the compiler output and put, oh yeah, some of the diagnostics controlled by this flag are enabled by default. Which ones? What? There's no docs. There's effectively no documentation. What time is it for you, Tsoding? Over in Novosibirsk. It must be crazy late. Or early. Tsoding says, maybe they don't even know themselves. Lol. Honestly, I feel that. Because sometimes I look at parts of the program, like the compiler I'm writing, I look at parts of it, and it's like, if I look at, for example, environment.c, I haven't looked at this in months. It's been 3 to 4 months since I even wrote something in here. This is code I've written, and I don't even know what it does. I would have to reread it. And I did today. I had to add environment remove. Oh, it was horrible. Tsoding says, the LLVM codebase is a mess. I won't be surprised. Okay. I can't even compile LLVM. I've tried, I've tried so many times. I've literally gotten help from people who are like specifically team viewing effectively into my computer, and they're like controlling the mouse and typing things, and they can't get it to work either. I just can't compile LLVM on my machine. It's not possible. Which is like, it just goes to show, what are they doing in their convoluted system to make that not happen? Like, oh yeah, this one person on this one machine just can't compile it. Why? I don't know. I just can't. And I have problems linking against it even. LLVM is rough for me. And then we were also talking about this is not how you do localization. Like having optional sentence structure. Who wrote this? Like, who made this display in CSS and HTML? Hopefully there's no JavaScript. Who made this display to go, oh yeah, this makes sense, and this is what we should do? You give 2 options for an English sentence, and then, oh, parts of it are sometimes the same and parts of it are different. Let's just make the parts different. It's not like if you're trying to translate this into another language that this will go horribly wrong, right? Like, imagine trying to Google Translate this page. It says translate to English. This isn't English. But you get what I mean. It's like, this won't translate. These docs don't even work for anything except English, and they're not even good English. Types declared in an anonymous struct are a Microsoft extension. Could you not just say an anonymous record struct union? Could you not put struct union in parentheses? Like, why did they have to do this? And if they're gonna do this, what are their plans for localizing it? It's just clear that they have none, which is, it's bonkers. It's bonkers, man. But Tsoding, I'm happy you're listening to my old grumpy rant, because man, this stuff pisses me off a little bit. I'm not gonna lie. Microsoft. If I see the word Microsoft in a compiler, I'm gonna get upset. Okay? Oh. Okay. Well, Tsoding says, I understand you. Aw. I love you, Mr. Tsoding. Thank you so much. I honestly, I would never have thought I would have ever talked to you. You feel like you're unreachable, like this in the stratosphere, this magical, you're like Richard Stallman. Like if I talked to him, it'd blow my mind. Like, how do you guys actually exist out there? And now you're watching my stream. That just blows my mind. I can do nothing but thank you, Tsoding. That's all I can do, because if I didn't use Emacs, would people even watch this stream? I don't think so. I don't think so. It's what makes it a large part of being different, is using different tools. And you were inspired me to use this one. This is the language I made. Remember? Okay, Tsoding. Don't hate me. Remember when when I totally like memed your porth and I made it in C++? It was awful code. I feel so bad. I feel like I did a disservice to porth by writing it in C++. Honestly, I was just inspired by what you had done, and I was like, this looks so approachable and was explained in such an amazing manner that it looks like even I could do it. Right? And I was like, well, maybe I can do it. And I did do it. Only because of you. Only because you made this super educational series on like how compilers function and are made. Without you, there's no other series. I'm going to be honest. There are other series, but they're like school. You know what I mean? They're like, let's go over this textbook definition and then give an example, and then that's it. And then you're on your own. It's like there's no actual real world proof of like, this is how you do things. And I just love that. I love that you provided that. Tsoding says, here is an interesting thing. Oh, I'm listening. Tsoding says, I have no idea how actual compilers work. Lol. What? My man. Tsoding. You know. You're being humble. You're being humble. You've written one. Although I know what you mean, because I feel like I don't know how this stuff works at all. It's so complicated. If it was less complicated, it'd be much easier. But everything has to be so damn complicated. It was so complicated that I've literally wrote an entire PDF that doesn't work anymore. I need shell escape. I made an entire PDF. Oh. Just to describe how the compiler works to the developers themselves. Ooh, this syntax highlighting is taking time. Oh no, Tsoding says, it's actually pretty late in here. I gotta go. Thanks for the quality rant. Anytime, Tsoding. You are welcome here. If you want to join like Discord and you want to talk on stream, you are welcome anytime. Message me and I will go live. I'm not even screwing with you. I'm down. But yeah, I literally made a compiler reference. This isn't even a language reference. It's a compiler reference. Here's how lexing works. Here's how parsing works. Here's how type checking works. Ugh. Anyway, thank you so much, Tsoding. I can do nothing but thank you. I appreciate you and your time. Thank you for listening to my grumpy old man rant, and I hope that we can do this again sometime. You've been awesome. And I can't wait to catch your most recent video, the OpenGL rope in C. I didn't catch that yet. I still have to watch it. So if you're sitting here right now, I don't even care. Leave the stream, go watch Tsoding's new video. It's awesome. I haven't even seen it, and I know it's awesome, because Tsoding makes awesome content. I promise. Like coding a rope in C, I'm sure there's going to be sweet like physics, and he's going to describe it in a really simple way. And then he's going to write it for you in front of you. It's beautiful. It's beautiful. Oh my God. I'm shaking. I'm never going to wash this hand, if you know what I mean. Oh my God. Tsoding, if you're still here, thank you so much. Make sure to get some rest. Go to bed. It is actually pretty late in here, is what he said. So yeah, I was right about the time zone. It's way off in Novosibirsk, because you're closer to me west, aren't you? I'm on the west coast of the USA, so you're closer to me west than you are east, which is rare for a majority of viewers. Thank you so much, Tsoding. I'm honored. I'm honored. Sir Aid, when he gets back, is gonna freak out. He's gonna freak out that he missed this. Oh my God. Oh. I'm just laughing. I'm gonna have to describe this to him. I don't even know what just happened. I'm trying to put it into words and I'm laughing. That was so awesome. We have emotes. What? What? That's incredible. Thank you so much, Mr. Tsoding. Thank you for validating my stupid rant. Oh, I feel so good. I feel insane. Do you feel insane, chat? Is anybody still here? I don't even care. That was insane. We had Tsoding in stream today. The Tsoding. I am so honored. I feel like I've been graced by the gods. Okay, now the compiler has to work. Like, at this point, there's no way. I'm just gonna do it. I'm gonna @notifs again. Oh, you guys can't even see this. That's how distracted I am. I'm not even looking at my stream, going, what is there? Oh, we were just ending the stream anyway. We were winding down. Ooh, 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 ooh. We were winding down the stream. I'm pumped. I don't know if you can tell. My heart is racing. Oh, that was incredible. Okay. I feel like, you know, SpongeBob, you know Pearl, I'm never going to wash this hand after she meets Bubble Boy. That's just what my hand. It's so clean. I'm never going to wash it. Okay. This is the language that I made a compiler for, and I made up. It works well, and it's to the point where we're nearing actual usability. We're going to add string literals very soon here in the byte type, which will allow us to do things like putzi, right? So we could define putzi as an external function, which it doesn't really matter what it returns. It can just be an integer, but we could just say that takes in an integer and a file, right? Which we don't really have, but we could just say take in an integer, which is a file descriptor. And then we're going to be able to, hopefully, have putzi actually, well, it already works, but what I'm talking about is puts. That's right. So we're going to need like a byte array or a byte pointer. So we could have a byte pointer like that, which is a string. That's the plan next, so that something like ASDF will equal a byte array of 4, which can then be converted into a byte pointer with byte 0. That is actually how that'll work. And then that can be passed to interop with C, libc perfectly. And not perfectly, but like with null terminated strings. You know what I mean? So this maybe is probably going to be a 5, including the null terminator. And once this happens, then we're going to be able to do stuff like call puts on. We could probably like make standard out an external integer as well. It's not going to work well always, but it may work.
Dear my, this madman is really implementing strings now.
Oh my, Sir Aid. Sir Aid, you're not going to believe it. I have news. Are you ready?
Strings?
No. Look at the Twitch chat. Look at the
Oh!
look. Yeah.
Here am I. Ooh.
He's gone. He's gone. He had to go. It's late in Novosibirsk. I understand.
I see.
I tried to keep him around. I was like, Sir Aid is gonna freak out. I was like, I can't. You have to. He had to go. I don't mind. I don't blame him at all. It's probably like 4 a.m. where he is.
Well, yeah. 4 a.m. It's probably later. It is 3 a.m. where I am almost.
Yeah, it's probably like 8 a.m. and he's been up all night. That's the only thing that would make sense.
Jesus Christ, yeah. What is... Okay, hold on. I am now in Novosibirsk. 8... Almost 9 a.m.
That's a good time to go to bed. But yeah, we had the legend himself. I was speechless. I don't think I'm ever going to wash this hand again, if you know what I mean.
My timing is as impeccable as always.
You literally left and he left a first-time chat. It was the worst timing. I felt so bad. I was like, what do I, oh no. So I put it in the
Yeah.
Discord and I at notifs. I was like, hopefully, it didn't go well. But it went amazing. He, I can't believe that he knows the stream. I can't believe he's watching it. It just broke my brain. Like, I can't make sense of it. Like, he knows, he like went to Twitch and saw me. I go to Twitch and see him. It's
Yeah.
weird. It's breaking my brain.
Is weird. It is weird. It is.
So yeah, I'm a celebrity now. If you want an autograph, I can arrange one for a few bucks. You didn't see it, but I just put my feet up on my desk. It was pretty funny.
Oh, I see.
I
I don't.
I'm just excited. That just gets me excited. But yeah, I started panicking, so I just described what I'm gonna work on next in the compiler, and he left. I don't, even if I never see him again, and he doesn't even remember my name, I'm gonna remember this for a long time. You know what I mean?
Yeah, I trust it.
Tsoding is the reason I use Emacs. And that's like kind of the only reason people watch my stream, right? Why else would people watch me sit here for 8 hours? Like, it doesn't make sense to me. It's got to be like something's different, right? I mean, you could say that my personality is just so interesting that anybody on the earth would watch it for hours and hours, but I have great doubts that that is a fact. Oh,
I mean, comparisons are interesting.
I appreciate that.
Sort of thing.
They're interesting in that they somehow work, even though they're built how they are. Like, that worked for you? What?
I mean, I've said it before. I'll say it again. The internet works, so I'm not surprised that compilers do it. Like,
Did Discord just freak out? Blah. Are you still here? I can't hear anything if you're talking. I'm so sorry. Well, rip. Where'd he go? He's gone. I'm so sorry. Sir Aid, you're gone. Hey, you're back!
Yeah.
You made it!
Discord just keeps. I have to run Discord in the browser because right now I can't use the app because I'd have to update it and I can't be bothered. So it will auto update at some point. So until then, I just use Discord in the browser and it's just horribly unreliable. It just crashes all the time.
I forgot Discord's even usable from the browser.
It's a website. So yeah, it is.
That's a good point. I forget that this is literally just a website. Which breaks my brain a little. But yeah. So I was just planning like what to do next. And I was like, well, puts should be able to work.
Wow, if we had I saw the byte point earlier. Was that prototyping or have you implemented that already?
It's all prototyping.
I see.
It's just in the tree sitter highlighter. We already have the byte type.
Ah, I was like, wait, with strings now? That was fast.
But if we had a string, which is a byte pointer, then we could do like this, and then we could just use like an integer as a file descriptor for now.
For instance, yeah.
And then we could call puts with like...
Puts doesn't take a file descriptor, but yes.
It doesn't?
It's fputs. Puts to start it out.
Okay.
Fputs takes a file descriptor.
Put C, does it take? What about put C? This is why I get confused.
Putc does. Puts doesn't. Putc does take a file descriptor.
Well,
My bad, yeah.
and put
Actually,
char.
no, it takes a file stream, not a file descriptor, but yes.
Oh no.
But char doesn't take a stream.
So naturally, you have put C and a non-existent function, and then you have put char and puts. Naturally, these would be grouped together in this way.
it's also
It's fputc.
Yes.
with put C.
Yeah, that makes so much sense. That's actually, yeah. This, imagine if I came to you and said, this is what I want to structure my custom library like, where when you write a character, you need to provide a file, unless you write putchar, in which you don't need a file. But if you want to write a character to a file, you have to call putsi. But if you want to write a string to a file, wait, if you want to write a string to a file, you can't.
Well, there is fputs.
Oh, and then there's fputs. Yeah, of course.
There is.
Yeah, of course there is. So yeah, there we go. There's the full.
I think a byte or integer pointer would be a better representation because it's a file pointer, not a file descriptor. But still. Ish, yeah.
Good enough. It would work.
It doesn't really matter because it can't really type check libc functions unless we do the thing that I did with LV.
That's right. That's right.
We could do that. I can write
Oh no.
like conditionally compile in where we can do like includes or import some standard like C header. It just literally imports standard io.h and it will just pass standard io.h and give you like declarations, extra declarations for all functions and types in that. Or functions at least for now.
That's actually okay.
That's what I did in
That's-
part of my projects. That's what I used libtool for. That's the code snippets you saw earlier for that. But
We
you can
may
just,
want to
like,
have that be an ability. That sounds cool.
Otherwise, you'd have to like generate or write wrappers by hand, and that sucks.
Which we are going to. I'm basically just gonna.
It's not just import standard IO. You can also do like import. What's it called? Like STB image or something.
Oh man.
Just libc.
Yeah.
Or SDL. You can import SDL.
That'd be pretty pog. I'm not gonna lie.
When you do that, you will realize the true depths of the C type system because you will be confronted with libraries that use break fields. Unions, obviously, you need to implement unions somehow for that to work. You also need variable length arrays and flexible array members.
So maybe we don't do this.
Yeah, what I usually do is I say, okay, I'm not supporting that. So if a type or a signature has like use the type that has a flexible array member, yeah, that one you can't use or something like that is what I usually do. Or because yeah, it's annoying to have to implement the entire C type system.
I'm gonna make it. It really is. I want to make.
For you can just emit a char array with a specified alignment or something, I suppose. But we'd have to have alignment for that. Actually, alignment is also something we're gonna we need a notion of alignment. Types have a size and an alignment. That's gonna be
Oh
fun.
no.
Mm-hmm.
Okay, don't click that. That opens a thing. Twitch chat. This little thing.
Just click random links in chat. You know better.
It was this. I thought it looks like a nose. I was like, what is a nose? Well, that does look like a nose, right? What is it supposed to be?
It does look like. It doesn't show up here in actual Twitch chat. I don't know what it is.
Weird.
Interesting.
Can I make Tsoding a moderator? Hold on. This may be something I need to do.
Oh my god.
It'd be fine,
I
right?
don't think we need too many mods right now.
No, but I mean, it's like a respect thing, right?
Yeah.
Community roles manager. I don't even
You
have.
always make a good mod if you need moderators. Just saying.
I don't even have a moderator role. I'd have to make it just for Tsoding. Can I give? Okay, can I give Tsoding his own role? I gotta think about this. I gotta do this after the stream. That might be worth it. Because if next time he comes in here, he has like his own role and the ability to ban people, like.
Good.
I feel like I've been graced by the gods. Like the compiler has to work now. You know what I mean? there's no chance that it like just nothing becomes of this project. It's gonna be grow into something great. We've been like effectively Zeus himself has visited and said like, hey, here's this little lightning bolt. Guess it might be powerful or something. Good luck. Oh.
Though, for the like import headers thing,
Yes.
look in what's it called? What's the channel called?
Code review?
Code review. Look at that again. Remember the image with the 20,000 libraries that I'm linking? What do you think that's for?
Oh no.
Yes. Oh yes.
Okay, we're not doing that. We're not doing that. No.
Not that bad, really. I think you could even. I mean, a standalone program would be. You'd have to invoke it, and it's annoying. And
It's not that bad. Are you kidding? What? This.
all of that.
It's just okay. It's just a few things, you know. Clang tooling, Clang front end. I can't even speak. Clang tooling, Clang front end tool, Clang front end, Clang driver, Clang serialization, Clang codegen, Clang parse, Clang sema, Clang static analyzer front end. I can't speak. Clang static analyzer checkers, Clang static analyzer core, Clang analysis, Clang arcm arc migrate, Clang. I was like, wait, that doesn't make sense.
Arkham migrate.
That's like a Harry Potter spell. Arkham migrate. And then he like disintegrates into lightning. Clang rewrite front end, because of course the rewrite front end and rewrite are separate. What?
Clang edit, Clang AST matches. That one is actually important. Clang lex, Clang basic, and Clang finally. It took a while.
You know, not that bad. It only took us like 2 minutes to read it out loud quickly.
See if I can find where I handle function decals in this thing.
Okay. Now that we've been graced by the gods, by the way, I do still have to go because it's late. I still have some time, but I do have to go. I just feel like we had such a good exit. I'm so sorry you missed it. I feel so bad.
It's fine.
I literally, you left, and then I look over and it says first time chat, Tsoding. And I'm like, oh!
Yeah, timing much.
Like, if you watch the VOD, I'm pretty sure that's exactly it. And I'm pretty sure I left it for like 30 seconds. So I'm pretty sure if I was quick about reading chat, you may have met the man himself. And if it's my fault, if we watch the VOD back and it's just sitting there, I'm so sorry.
It's fine.
I'm just all I can hope is that like one, he thinks I'm like a complete idiot. That would make me really happy. I don't know why. It just would, where Tsoding comes in, he's like, this guy's dumb. Fucking what? Anyway, bye, weirdo. You know? Because that's how I feel people should react when they join the stream and I say like, and I just read their name and what they say. Like, oh, yeah. But with him, I did like a weird simp thing because I was speechless. I'm like, because I was like, at first I literally said, I'm like, oh, someone made an account named Tsoding. And then I clicked on it and it says account created December 22nd, 2015. And it has his image. Here, I literally did this. I looked at it and I was like, oh, and then I freaked out. I went insane, which I think anybody would if they met Tsoding.
It is the actual Tsoding. It is his account if you click on it.
Yeah. I didn't think it was. I really didn't think it was. I was ready to like fully just expect like, oh, some person made a fake account. It's not real. It's funny, you know, oh, it's Tsoding, he joined. And then it was like, wait. That's man.
It's familiar, doesn't it?
Yes. Oh, love you, Daddy Tsoding.
Brilliant.
live. Hello.
That's brilliant.
Oh, I couldn't believe it. I still have to watch his rope video.
Yeah, right, that showed up in my inbox. I remember that.
I literally, as soon as I realized it was actually him, I said, everybody right now, go watch Tsoding's new video. I just promoted him. I'm like, just go watch it. It's good, I promise. Because I remembered it was about the ropes. So I was like, this is good. I've got a memory item. The legend himself. Yes. I mean, I love that he came in and used the original emotes. Like, we stole his emotes. I did, at least. That was my choice. I was like, these emotes are great. I love Tsoding. We're stealing them. And then he's like, he comes in with the OG emotes. He started off with a Tsoding weeb. Like, how am I not supposed to freak out? He just said Tsoding weeb. Like, oh, it's him. Oh, I'm so happy. Anyway, I really recommend watching the pod. The last 10 minutes. It's going to be good.
I'll take a look at it when I get to it.
Oh, I also told him, anytime, if you message me, I will go live. And you are welcome in the stream, in the chat, anytime. And if you want to join Discord and like talk on the stream, totally allowed. I was like, you have full reign, okay, over the channel. If you want to change my emotes, if you want to make me a Twitch partner, I'll do it, okay? Tsoding knows what's up. If he mysteriously makes me send money, $100 a month to some Russian bank, you know what I mean? I'll do it. It's worth it for Tsoding himself. Come on. Oh, I really rolled out the red carpet, or at least I tried. It was more like I rolled out the, oh my god, weeb, I love you, and simp fanboy. Here you go. Hope you like it. Oh,
I usually try being a bit more reserved whenever something like that happens, but I can see why.
okay. I used to really care about looking like professional and like acting the proper way when something happens. Like, and then I started wanting to feel good. Right? And I realized that I don't feel good if I try and like regulate my reaction to everything. Which isn't good for other people. I've fully recognized this pattern. That it's a bit unhealthy for relationships around me. Where I'm not nice to the people around me if it's like a major inconvenience. Anymore. I used to just be nice no matter what. And be like, yeah, whatever you need, I'll do it. Like with Tsoding here, I revert into that like mindset I used to have where it's like, anything you want me to do, let's do it. Let's go. I'll send you $100. I'll change the channel emote. Or the logo. I don't care. You know what I mean? And that mindset used to be how I treated everybody. Where it was like, well, I don't deserve anything. I'm just a stupid person. They probably know what they're talking about. And I should be nice to them and do what they want. And then I started realizing that I was just horribly unhappy all the time. And to make that better, I had to start making decisions which didn't include other people's feelings. Which then resulted in a lot of people around me no longer liking me. Because I constantly hurt their feelings and didn't take them into consideration at all. A great example is my timing. Remember today when I was like, oh yeah, I'm starting in 30 minutes. And then in an hour, I was like, oh yeah, 30 minutes. And then in an hour, we started. That's not nice to you. You know what I mean? I recognize that. And
it's fine in this case.
Thank you.
I had things to do anyway. I was just writing unit tests in Java while I was waiting.
I appreciate it. I appreciate you being lenient and taking that blow.
I'm used to it is the thing. Like 2 hours is nothing.
Egma is like, and I got it to you tomorrow, and then it's 8 weeks later. Like, okay, I'm
Oh
almost
yeah,
done.
no, it's like okay, I'll message like maybe we could do stuff tonight. I'll message you later, and then it doesn't message me until like noon the next day. And it was like, I was too tired. Maybe like in like next week or something.
Oh my god, I'm so sorry. That hurts my soul.
It's horrible when it comes to planning stuff like that.
So I'm mean, and I'm like, if I'm gonna be late, I may not message the person that I'm meeting because it's like I'm late. I'm working on getting there. I don't have time to message them, which is a very selfish mindset, right? But he's like, he does. I don't feel like there's any shame in what he's doing. He's like, oh yeah, I didn't message you when I said I was gonna, and that's it. That's it in his head. That's like that's the fact. I said I was gonna, and I didn't.
Too much about that though. I'm not sure he does. Like the thing is also he's horribly slow when it comes to responding. Like he sometimes doesn't respond for a day or something like that, or for like a few hours.
See, I do that like once every 3 weeks when I go insane. Or I start working on something new, then it's like, yeah, I just worked 24 hours straight on something. Sorry. I was out. But if I'm like just sitting there, the first thing I do is make sure I have no notifications anywhere. And if I have, I've dealt with them.
I mean, yeah, I have 3 monitors and one of them is just Discord always.
Nice. I would definitely have that set up if I could.
Agma is the opposite. He's out there gardening something. Something like that. Typically, yeah. Or whatever, yeah. Or like editing a video for 12 hours.
Editing, I admire anybody who can get through that.
Yeah, I think the Conlang Iceberg, I think that's where he, like, was a 2-parter, like 1 hour each, and I think part 2 took him 12 hours to edit or something like that.
Oh no. See, I spent like 4 hours editing a video because I was going to make some videos for YouTube.
Uh-huh.
And then I can't open the project anymore in DaVinci Resolve. It just freezes. It freezes my computer and I have to restart it.
Oh dear.
So I have lost all motivation for editing or anything like it. I'm like, screw that. I'm just uploading full VODs. That's all you get. I'm sorry. I can't do anything else. I'm not proficient enough with my tools.
I mean, speaking of, have you ever tried subtitling something?
I don't know if I want to. No, I haven't.
It's the most horrible experience that you could ever possibly imagine. Because if there's like 4 people talking over each other and you want to time the subtitles nicely, you have to go back all the time. You have to time the subtitles so that they become visible when a person starts talking and like disappear when someone stops talking. If you want the subtitles to animate nicely, you'll have to like do 4 different transitions in a 5-second period. And if there's 3 people talking over each other, you have to first try and make out what they're saying. And to do that even for like a 20-minute video is absolute pain. I think I wrote some subtitles down once and I was like at 1,000 lines of subtitles for 5 minutes.
Oh god. That's horrifying. Yeah, I don't want to think about that at all. I'll just say the stuff that then gets subtitled.
My advice is don't ever subtitle something. You don't want to do this to yourself, trust me.
Yeah, I'll just pay somebody. You do it. I'd subtitle a music video.
You need to do it? No.
I would subtitle a music video.
Oof.
That's easy. Just lyrics. Ad-libs. Oh! What?
Ooh.
Yeah! You know what I mean?
I see.
Easy subtitles.
Oh yeah. Definitely. It's horrible, trust me. It's a lot worse than it seems.
It is. Okay, it is.
Bad, but it is so much worse.
Because even if you know the lyrics and have them written down from the artist, it's still going to be like they say half of a line and then the rest of it after a little pause. So you either just have subtitles on screen that aren't really relevant for each half, or you have to make each half separate, in which case now all of a sudden there's no lyrics to subtitles match up. So now you're just like, good luck. You know what I mean?
Yeah.
You could do it simply, but it wouldn't be good.
If you don't even have the lyrics, you also need to type everything out. You need to make sure you understood everything correctly. You need to find the start, like time it, find the start and end interval and everything. And you need to do that for every spoken line of text. And perhaps you don't realize that until you try to subtitle something. But even in like a short video, people talk a lot. There's a lot of, if you want to subtitle everything that someone's saying, that's a lot.
It's true.
Even
And
if
if they're
it's
like,
small.
if they're performing quickly and they're like saying a lot of words,
Yeah.
you're going to have like half the screen covered in subtitles because they're talking so fast.
And what's interesting though is that you realize like quirks in someone's speech because Agma repeats words a lot. He'd say like it's the thing or in us whatever. He like repeats the first word of a sentence all the time.
Yeah.
And it's something you don't like on stream, and it's something you don't realize unless you like listen carefully, which is what I did when I tried to subtitle a video once.
Yeah.
Tried, emphasis on tried.
Have you noticed anything in my speech?
I haven't been paying particular attention to it. I think nothing like that stands out too much. You don't have a particularly. Your accent is fairly normal, I'd say. It doesn't stand out too much, at least not to me, because I can't tell American accents apart. So that's that.
I feel like a true white guy. Yeah, you're normal. Everything's fine. Yeah, nothing's weird. Like, oh, I haven't heard that one. That's abnormal for me. Oh, me being a white male in America. Real abnormal to be called normal, you know?
What I pick up on very easily, and that's probably because of my like linguistics training, if you can call it that, is if someone pronounces something way differently from how I pronounce it, or uses an expression that I would never use, that I notice immediately. But if it's something I'm used to hearing, then I sometimes don't even really pay attention to it.
That's a good point. I almost never think about your accent. I haven't even, there's not been a time where I was like, oh, he said that funny, or I've got nothing. You honestly, I wouldn't think that you sound abnormal, which is weird to be honest, I thought you were going to sound abnormal. That was my expectations. Like, there's this guy from you're from another country.
Well, it's true.
The people that I've interacted with from other countries were like, I hate to say this, imported. So they were like people from the islands that we nuked, America nuked in the 40s, and like we ruined everybody's life over there. We relocated them into America. And this town was a subject of a lot of those relocations. So we have a lot of like native islanders, which is sweet. And they're really awesome people. But interacting with them, it was like this whole other thing. And I'm not trying to be like mean. It was like, as a kid, it's like you have all the people, but when you try to talk to them or play with them, it's like they have different tendencies and they're playing different games. Like you both say, let's play tag, but they start doing some other, like you go to chase them and then they're trying to chase you and you're like, no, I just tagged you. They're like, yeah. And then it's like, okay, there's like miscommunication somewhere. But, and many of them had strong accents because they were like, for example, they were still being relocated even as at high school age. So in high school, we would have new people come in all the time and they had really strong accents and are just learning English. And when talking to them, you definitely get into like a different mode of your hearing where it's like, oh, when they say this syllable, they actually mean this word, but they're not saying this sound. You make like a little accent translation in your head so you can start to understand them.
Yeah, I think it's much more noticeable if it's a non-native accent, simply.
Yes.
Like you notice if a pronunciation is just off.
That's probably what a lot of it is that because we both speak English, even with a different accent, we can understand each other. Whereas somebody who doesn't speak English would have like completely different ways to make sounds. So we make the same sounds, even though they're different, put together
Sorta,
differently. Mm-hmm.
Phonemes are more or less the same, to put it that way. They're the actual
That's a good, yeah.
phones. Our phones are different, but yeah.
Because we're still like making the R sound. Even though when I say R, it's not your ah.
Mm-hmm.
To be honest, the British R is just so much better. I hate the American R. I feel like my mouth like contorts on itself.
Yeah, I mean, there's some differences in like the actual R, like because the American R is a bit more retroflex, so it's more like right instead of
Yeah,
right.
that's really good.
Mm-hmm. It's like if I shove my tongue back into my throat, it sounds American. That's what it is. It's like much more retroflex.
It's like, yeah,
Uh,
it's like your tongue is rolled up.
yeah.
Why? Like, why did America think that's the way to do
No.
things? What have we
The
done?
thing is that in like most British accents, R isn't pronounced. Is only pronounced like between vowels and obviously at the beginning of a syllable, but not at the end of a syllable.
Yeah, you kind of
That's
just
all about
extend the
Because, like,
vowels.
Yeah, the vowel is lengthened. It's far.
Yeah,
The R is not pronounced.
that's exactly
But
right. It's like
Followed
FAA.
by another word that starts with a vowel is like far in or whatever. And to the point where the rule is not so much that there are words that end with an R that's pronounced in certain cases. No, it's just that when there are two vowels that collide at the word boundary or the syllable boundary, we insert an R, even if there was never an R there. Like, I mean, what's like the prototypical example, like law and order.
Oh, is
Law
that
and
what's
order.
happening?
Yeah, law and order, because it's we have two vowels colliding and we insert an R there. That's a
Ah.
phonological rule in a lot of British accents or in non-rhotic accents. That's called an intrusive R.
See, that makes a lot of sense. I always wondered why. Okay, so in America, we have portions of that left over. When people say saw, I saw that happen. They say saw, and they just do a light R,
Yeah.
and it becomes I saw that happen, and it's like my ears die internally.
For me, it's I saw that, but I saw it.
Right, and that
saw
sounds
it.
natural. That sounds normal where you tap the R because it sounds like a natural distinction. There's two words here. Here's the border.
I tap the R into vocalically. That's not something that a lot of people do. Like I'll say very. I think that one is fairly noticeable.
Oh, I see. You're not saying very. You're saying very.
Very, yeah.
Very. Okay. I definitely would never do that, but I've never noticed it in your speech. I've noticed that you sound like British. Every once in a while I go like, oh, that was fa instead of far.
Yeah.
But it's not like that's weird. It's like I've heard that all the time. Even from people in America where they say, oh, it's far, it's over there. It's
Yeah,
far.
there's some accents that are sort of non-rhotic or something like that. Or
Yes.
less rhotic, I suppose.
I feel like I've experienced it in like oh man, I don't know if these words are offensive. It's just words I've been taught, so I'm not going to say them. Like the place, like the rural areas. Yeah, say rural. That's a good test.
I see.
But the people in the rural areas, they tend to speak with like less R's, but they also insert R's on word boundaries like SAR. I saw it. And that now makes so much more sense based on what you're saying, is that's more of a British accent.
Yeah, but there's some really cursed things that can happen in my accent to where I drop my T's quite frequently, especially word finally. That's common, like I say that instead of that. Right?
Yeah, I'd say that's almost universal in America.
Yeah, that too, but like I glottalize it much more. Like again, prototypical if not stereotypical is like a bottle of water.
Oh God. Okay, I get what you mean now. Americans remove it whereas you insert a glottal stop pretty much.
Yeah, what Americans do, you use actually tap. You say something like a bottle of. Well, I can't do that, but it's a tap actually. So water. Sort of
Yeah.
water.
Yeah. Okay. Yeah.
It's a tap actually. Interestingly, the T gets tapped. It's called T flapping. That's a prototypical American thing. British accents don't really do that. We glottalize
Water.
the T's. But in my accent, I say that instead of that. But that means that the word that now ends in a vowel. So if I have another word that starts with a vowel after it, like happens, which I also drop my H's sometimes, so that might just be happens. So I say that happens. I insert an intrusive vowel between that and happens. So it almost sounds like I'm actually flapping the T. Yeah, that happens. I remember saying that once, and I
Wow.
was like, "That. Where did that come from? Where did the tap come from?" I was really confused. And I noticed myself that I was saying that happens. I was like, "Well, I had to like step back and analyze that carefully to figure out how I got there."
That's amazing. So it just sounds like if my ears were turned off, I wasn't paying attention, that would just be that happens. I wouldn't even think about it.
Yeah.
But there's so much going on there phonetically and phonologically where it's like there's so much. And all I hear is that happens,
Yeah.
which it shows how dumbed down everybody's version of each other's communication is. Because like when you hear someone speak, you don't hear what they're speaking. You hear what you heard, what your ears received, and then perceived as specific sets of sounds in a row. And then they try to send that to your language processing, and your language processing is like, definitely that happens. That matches that pattern.
Yeah.
But nothing, like, you never actually heard that happens. You heard that happens. Which is like,
happens, yeah. Yeah.
Clearly that means that happens. Okay.
Yeah, especially the thing is also though that, because you say you understand me fairly well, is that typically, especially when I talk to Americans, my accent isn't that strong. So it's like noticeably different, but it's not like that thick.
So I bet you if we had like one of your friends from over there, just like any British person, not necessarily one of your friends. But if we had one of them from over there, just any British person in here, their accent would like mob mentality probably both of us into speaking more like them.
Could be, yeah.
I'm American, so I may have a pretty stubborn accent. We bring America wherever we go, you know what I mean? Which is just a way of saying all of this is our land and you can't do anything about it. It's horrible. America is based on stealing.
I mean,
righteous stealing.
British Empire was a thing, you know? We did it first.
We did it first.
Like at some point, what was it like? I think 26% of the world. Was
yeah.
On the British reign. There used to be a saying that the sun never sets on the British Empire because somewhere in the British Empire was always day. Because it was just all over the place.
You tried to take India. That's like,
well, yeah.
That breaks my brain. Like America,
India, Australia, Canada, the United States, like all of that was basically just British colonies. Well, India not so much colony, but you know what I mean.
Yeah, that's a special case for sure. They did interesting things, made questionable decisions.
Mm-hmm.
But to be fair, if someone in 100 years looked back on my life with like a microscope, they'd probably go, look at this idiot making all these mistakes.
Well, yeah, that's how it be.
That is do how it be.
It do be like that.
Okay. One more thing, then I have to go.
Mm-hmm.
Okay. What is your experience with finna or fixing to?
I've never really heard anyone actually say that.
Okay.
I just haven't. I know that it's a thing, but I've never heard anyone say that like RL.
I'm so glad that you share this perspective. That was exactly my perspective until high school.
Hmm.
And then I showed up at school one day, and everybody's going, finna this, finna that, finna. And then I'm like, what is finna? What are you talking about? And they're like, oh, it means fixing to.
Yeah, but
And I was like,
Yeah.
what is that?
uh,
What is fixing? You're fixing to what? Fix to
yes.
what? And my brain broke, and I was made fun of greatly. They're like, you don't know about this? What? Which is hilarious. It's like, oh, I don't know words, so I must be a dummy. Yeah.
Yeah. Well,
No, you shouldn't just explain them to me. That'd be stupid. You should just make fun of me for not knowing them.
I mean, things words change all the time too. I mean, most
Exactly.
younger people don't use radical anymore, so
That's radical, bro.
that's radical.
Oh yeah. Surf's up, man. Radical.
I don't know what that character is, but I can drop into it at any time. It's like it's a surfer, but I've never been surfing. I've never met a surfer. I don't think I've ever
Actually.
seen a surfboard. Not even joking.
Can't remember seeing one either, honestly.
I've been to the coast like twice. I've seen the ocean once. I'm a pleb. And they expect me to know words from other places? What? Oh, anyway, finna means I want to do that.
Yeah, I know what it means, but the thing is, I've never really heard anyone use it. As in, like, at least not IRL. I mean, maybe I've heard it online before, but not really.
Yeah.
I
I'm
know the thing that some people say, but I don't know who those people are.
so I had some contact with family, is how I'll put it, from the South, where they're like very Southern.
I see.
And they would say it all the time. And they'd use it very weirdly. They'd say, you finna pass me that? And that's a question like, can you pass me that? You finna pass me that.
I see.
And it does make sense on some level, but every time I heard it, I was confused. I'm like, wait. So my idea of like the word want is very self-based, where I want something. And if you want something, then you want. So when you say, you fixing to do thing, that's you saying you want this thing, which isn't a demand. It's a question asking me to do it. And I just...
As I understand it, I could be wrong, but I understand it's basically like gonna. Something
yes,
like that.
it's exactly... just with a little differences. Because I would never say, you gonna pass me that? I guess I would, but I'd ask it as a question.
But it's not exactly a nice. It is not exactly a nice way of phrasing it. Let's put it
No,
that way.
that would be like, I've been asking you to pass me it for 8 years.
Yep.
Give it
Yep.
to me. You're gonna pass me that today?
Yeah.
But apparently finna is nice. Anyway, I was just curious what your experience with it from another country is. Because I feel like it's from another country. I learned it like it's another language. Like, oh, these weird people I meet use it in this. I can't understand them. I don't know why I thought about that. My brain is... Tsoding has affected my brain permanently. I am now offset by 5 minutes. However much time I've spent with him, I'm that much in the past.
Recuperating from the shock.
That's right. Honestly, I was in a bit of shock. Like, not even overstating it. I'm looking at it and I can see it.
I'd imagine.
And there's input in front of me and I'm going, okay, what? Uh-oh. I don't know what to do. Uh-oh. Panic. Say something. And then I'm like, oh, compilers, they're complex. This is one.
Yeah, it does feel strange if you're not, if like you meet someone who you only know like from online and you don't really know them, and now suddenly you're talking to them or something. That's like it does feel strange, especially if they're like semi-famous or something like that.
It is. To me, Tsoding is like Tom Cruise. He's like top level celebrity. And I realize that's probably not a realistic view of the world, but that is my view, right?
The
He's
mean,
like,
I'm
go ahead.
sort of more used to all of this because I'm on a server with all the conlanging YouTubers.
So you
I'm more
interact,
used to that kind of thing.
yeah. You're like collaboration isn't crazy, or seeing another YouTuber talking
Yeah.
to another one.
And also the thing is, I and Agma are usually the people organizing everything, so that's that.
So you definitely talk to everybody and deal with that. It's
Yeah.
like everybody goes through you.
Not necessarily, but something I talk to, like, whenever there's an event, I'm usually there. So,
Nice.
but
You're part of it.
I'm like the only person on the server who is not a YouTuber.
That makes, yeah, that's a good way to put
because
that.
I help Agma organize stuff mostly.
I mean, honestly, my channel would have half the videos if you weren't here. Because somebody else pushing you to be like, hey, are you going to do this anytime soon? is so powerful.
Oh yeah, tell me about it.
And it's good. I love it. I love having that motivation, the external motivation factors. Because I have so much internal motivation, it's just misplaced a lot of the time. I'm like, yeah, I want to do something. I'm gonna base jump off a bridge, and it's like maybe I shouldn't have put my energy into that. You know, it's just on any level, it's clearly dumb. It's like, okay, it's dangerous. It's not regulated by anything. The safety equipment, you're just trusting whoever used it last that they checked it and it still works.
Mm-hmm.
And then, you know, just go jump off a bridge. And it's like, wait, that's the steps? That's it? That doesn't seem right. But if you get internal motivation can just point you into like, I'm doing this. And your brain never stops. It's we were so caught up in whether or not we could, we never stopped to think.
Thinking to whether we should, yeah.
For me, it's usually a lack of motivation. Like, I'm too lazy to do stuff. I'm generally very lazy.
Oh, I'm jealous, man. I'm jealous.
It's nothing to be jealous of, trust me.
That's fair. Well, I'll let you know from the other side. It's nothing to be jealous of over here either. You should take your time and be lazy. It's nice. I can't remember the last day I literally did nothing. Like where I just watched TV or like didn't. I can't remember. Because I can't. I sit down for 2 hours and then I go, oh my God, I'm freaking out. I have to go do something. Or I get a crazy idea and I'm like, I'm going to go learn the D programming language and write a toy assembler because I can't relax. That may or may not be a real example.
Really, I may or may not be. For me, it's usually different because I typically struggle to keep just motivated for an extended period of time. Unless, like, the only hobby that I really have and the only thing that I can just sit down and do for 10 hours straight is programming. Anything else, I just get bored of. I do it maybe for an hour, maybe for a few days. But after that, I can't be bothered for some reason. I can't get the motivation to do anything unless it's like programming. But I mean, of course, if I'm working on the same project for like a week, after that, I'm probably going to be burned out as well. But I come back to it eventually, you know?
Yeah.
Whereas with other things, I just don't.
Okay, that's
I'm a linguist,
yeah.
but I suck at learning languages. I can't. I just don't have the motivation for it.
See, I'm great at learning languages, but I suck at using them. I can learn a new language, write a Rule 110, write like a Hello World, write for example, an x86 64 assembler in D, right? The day of learning it. It's like, it's not, my brain is great at that, of going, oh, this is how I solve this problem in a new way. And then it just caches that and goes, oh, in D, I do this to solve this problem.
I see. I mean, I was more talking about natural languages than programming languages, but...
Oh, that's funny. Okay, I can't, yeah.
Programming languages immediately when I said language. It's brilliant.
So when I learn a new like natural language, I would have to go there and speak it wherever it's spoken. Otherwise, I'm screwed.
I see.
Because English will just take over. I go, because I know the English words for things. It's like, that's a phone. I can't, all I got is phone. You know what I mean? Like, I got nothing.
whenever I have to talk in another language, I'll just mostly have to pause and like, okay, this is how you say it in English. How do you say day after day in this language? And then you try translating it literally, and it really doesn't work.
Okay, that's a great.
Every
Yeah.
once in a while was the worst. I tried translating every once in a while literally, and it's when you do that you realize how little sense every once in a while mean actually makes if you try and break it down.
Oh no.
Yeah, because wait a second.
Every
Every once in a while, what the hell is once even here? Is it like a noun? What does once mean as a noun? Is it a noun? Like, there's just the thing is just that with set phrases like these, it doesn't make sense to analyze them or break them down because they don't really make sense as a whole.
like what does once upon a time mean? You said once, and I was like, oh, it's like once upon a time, and then I went, wait, I don't know what it's being used as there either.
Once upon a time, like once all the way back then, that's kind of the sense.
So
Yeah.
upon a
That one
time,
makes sense, I think.
I guess it makes some sense because upon a time, you could say that's on a time. So once on a time, and on a time is kind of weird. So you'd say at. So you just say once at a time, which is
Something like
weird,
that, yeah.
but it still does make sense. Where it's like, okay, once, aka one time before now, but every once. There's only one once. That's what once means.
Yeah.
So every once is the one once, but a while. Okay, what? It's every once and a while.
Makes sense. Okay.
There's only one while. How does that make
Okay,
sense?
No etymology for it. I'd have to power on my Windows VM and check the OED. But I can't be bothered to do so right now.
That's fair.
Because you need a subscription for that, and I can get to it if I log in via my Uni's VPN, but for that only works on Windows. So I have to start my Windows VM for that. and
Oh,
it's just
no.
annoying.
Yeah, don't do that. Don't do that. Okay. I probably should have gone 40 minutes ago, but Tsoding put this whole thing off track.
Oh yeah, he derailed everything completely. I'm
It's
sure.
all his fault. Oh, if you're watching this, I'm so sorry. I still am speechless. And I want to, as much as I appreciate Tsoding being here, I do want to say I also appreciate you being here, because you put a lot more work in than Tsoding today. Like 7 hours of constant help with debugging and like just general entertainment during a stream. That's a literal job. You know what I mean?
I mean, sort of, yeah, you are. That's true to some extent. But the thing is also the way that I view it, even if it's sort of like a job and I don't get paid for it, I still get, like collect experience, and that helps. Like, even if it's. That's why I typically say that even if you don't get paid for something and if you want to work on a project, that's gonna help later because you're gonna learn how to do these things, and they are gonna come in handy at some point when you do get a job, or if you do get a job. So
It's true. I can't remember this quote, but it was like,
with programming, especially, I mean, it's probably true for a lot of skills, but with programming especially, I find that to just be very much the case because a lot of the things that I know how to do well and that I've had to use in certain situations, I only know because you had to use them in some of my projects. Like, I only know how modular arithmetic works because I've had to deal with that before somewhere. And
exactly,
like
yeah.
when I first formally learned about modular arithmetic, I didn't understand a thing of what it was about. Now it makes sense. Oh, of course, it's but
They didn't teach you modulo in school?
not modular arithmetic. No, I
Oh,
only have
no.
it at uni.
I'm so sorry. They literally, in America, they taught us that in elementary school. It was part of like division. They're like, yeah, sometimes they called it the remainder.
Yeah, well, remainder, but actually modular arithmetic, like 3 plus 4 modulo 6 is 1.
Yes. Yes. Because 7 modulo, yeah. Remainder, yeah. So, but yeah, they actually called it modulo when we were in elementary school. They're like, this is the mod. And then we actually wrote the word mod. I felt like a mathematician in 6th grade.
Yeah.
In grade 6.
Also, like, I feel like as someone who is doing computer science at uni right now, I feel like that people say a lot that academia is a bit out of touch, but I really get the feeling that that's true because they often don't really know how to teach things to us. It's very much mathematical and abstract, and that's not the best way of teaching programming. Like, if we just a simple topic like manual register allocation, I had a compiler class at uni, and they also had a simple toy compiler with manual register allocation. The way you did it is 10 times as sensible and much more intelligible than what a seasoned computer science professor could come up with.
Seriously?
He had very weird naming, and it was just very hard to understand what was going on in like register allocation. For you, just okay, allocate a register, deallocate a register. It can't get much harder than that. So
I'm proud. Thank you. That did make me feel good. Because a lot of the code I write, I just assume it's the stupidest way to do it. And that I haven't solved any problem. I've just made more. But learning that...
how it goes. I mean, I think I've sent you that one image like twice. Now the one that programming fun. I don't know. It's complicated. I
yeah.
love that one. It just fits so perfectly.
Is
like-
programming fun is the same question as, am I screaming right now at my monitor? If I'm not, it might be fun. If I am, I'm probably having fun, but I don't think it at the moment. Amazing. Well, thank you so much. This has been incredible.
It's fun, yeah.
Not only did we get stuff done on the compiler, we talked to a celebrity. And we I don't even know, what else did we do? I see
We
Tsoding just
that's about 2 hours.
and then yeah, that's right.
I was speaking semi-ironically when I said it would take 2 hours. You know, I wasn't actually expecting it to take 2 hours.
It's the same thing when I made the 10 minutes of work, 3 hours. You'll see. And then it turns out exactly correct, and you're like, I thought I was joking. Even I thought I was joking. I didn't know.
So it'd be sometimes.
That is how it do be like that. I wonder how many ways there is to say that. Because
I mean,
there was
lot.
like the meme before of like, it do be like that sometimes because of Jaden Smith and everything.
really, I don't even know what it is, honestly.
Oh
Like-
no.
Some kind of musician, I think.
That's a good way to describe Jaden Smith. Some kind of
Because the thing-
musician. You're
Thing
correct.
about me is with music, I only really listen to classical music, video game soundtracks, and anime music. Like anything that's like rap or rock, I haven't the faintest clue of what any of those people are. I don't know anyone or any I like. So I constantly hear people talking about, oh, this guy, I've heard this name like 10,000 times, still don't know who they are.
See, I'm the opposite, where it's like I am fully into rap, and rock is like I've grew up with it. The people around me listen to it, so it's like I know it. I listen to some of it, like from my childhood, like Shinedown. Their old albums, right? And I have a peculiarity in that I really care to know if I've listened to an artist before or not. So artists' names get like implanted in my head.
Yeah, I see.
Real people names, nothing. They don't stick in. But artist names, someone says like, "Have you heard this person?" And I'm like, I definitively know, yes or no. It's not like maybe what do they make? It's like no. And if I have, I could tell you, oh, that's that person. I listened to them at this time and this song, and these are some lyrics. I could probably sing it.
For me, like 99% of the time, it's like the answer is just no.
Is it Bach? I don't know who it is.
grew up listening to rock music. I grew up listening to classical music. Like,
So it's kind of the same thing.
yeah.
But yeah, and
Things
then
I was a kid, like all of the stuff I watched was like TV shows. Like the most modern stuff I watched is like the Smurfs, and that's from the 80s. Like that's the most modern show I watched as a kid. It's
that's
like all from
crazy.
the 80s or before that.
So what's really interesting, I had something similar in that I only watched shows from like the 60s.
Okay.
And
Question.
then go
You know
ahead.
who Laurel and Hardy are?
Laurel and Hardy.
Mhm.
Okay,
Stan Laurel and Oliver Hardy.
is that Faulty Towers? What is that?
Okay, now I don't know what that is.
Faulty Towers, FAW.
Ephraim, no, that's like 40 years off.
See, I know old stuff. That's my problem.
Okay, this is old. This old stuff is from the 30s.
That's very old. I definitely don't know that.
Somehow, no one knows who Laurel and Hardy are anymore. Like, it's shocking. Like, I've yet to meet someone else who is my parents who knows who they are.
What do
like-
they? What is it? Is it a TV show?
Like a comedian duo.
Like Abbott, Abbott and Costello type of thing?
I have no idea who that is.
Who's on first? Okay, hold on. Look up who's on first. You just need to watch this. It's
What's it called? What?
who
Who
is on first.
Who's on first? Okay. I'll have it open here.
Okay, it's worth it. We're gonna do this. We're gonna stick around.
Wait.
Remember the Three Stooges?
No, it's not. Okay, it's similar. Okay. I'll watch it later.
Yes. That's a good idea.
I'll have it open in one of my 2000 times. So, Laurel and where's the thing? Where's the one with me? This one, yeah. Okay,
Dun, dun.
I can link it here. That's one of the films.
We're gonna do it. I'm gonna talk over it so that I don't get like any problems with YouTube and putting the VOD up. And Metro Golden Mayer is probably really mean about this, so I'm gonna skip past it. Oh God, there's so much Metro Golden Mayer.
It's like
Okay, so we're just gonna do whoa.
public domain by now or something like that. I don't think anyone's gonna copyright something from 1932.
We can hope. I'm just gonna scroll up and down.
So these are Laurel and Hardy.
This looks a lot like Abbott and Costello. Let me guess. The one on the left is Laurel.
From what I saw.
Laurel.
That is Sam Laurel, yeah.
Hardy.
Oliver Hardy, yeah.
Beautiful. So this is like Charlie Chaplin times, 1932.
Yeah, something like that.
So I know
Everyone knows who Charlie Chaplin is, but no one knows Laurel and Hardy. It's like, how?
it's true. Okay. I'm scared to press this. If that says what I think it might say, I'm gonna freak out. I'm not gonna do it.
You know what you may be talking about?
You definitely do. It's the obvious one. Oh. How about that?
What was that? What was I?
Okay, we did it. That's Laurel and Hardy. Is that like a whole movie?
That's just like a short film, like 30 minutes.
I'm gonna watch that.
A bunch of those. I can link to some others. If you just search for Laurel and Hardy, the one with the Christmas tree
Just
is
gonna
also
keep it
very
open.
funny.
Oh, I already have it open. No.
One with the Christmas tree, if you can find that one, whatever
Okay.
it's called.
Legendary.
And okay, if you don't know Laurel and Hardy, you're probably also not gonna know Bud Spencer and Terrence Hill.
Definitely not.
It's okay.
But yeah,
yeah.
the Abbott and Costello thing is like a short bit. It's only 3 minutes, but
Take a look at it.
it's funny. They're a great comedy group, and that actual joke has been like told 8,000 times to everybody in America. We all know it. If you say it to anybody, those 3 words, "Who's on first," they'll laugh. I mean, that's a bit of an overstatement. I understand, but most people in America are gonna go, "Oh yeah." Do you at least know
Yeah.
Snoop Dogg?
The name rings a bell, but I have no idea who or what that is.
Oh my God, we have such different lives. That's incredible. I love
You don't
that.
know who Terrence Hill and Bud Spencer. I'm shocked.
I know, and you have the right to be. I'm not. You have the right to be shocked. It's just amazing that we both have so much knowledge of people and things we've seen, and they don't overlap at all.
See,
Just with
stuff
each
like
other.
that. TV shows that I grew up watching were the Smurfs from the 80s and Star Wars, the original, not Star Wars, Star Trek, the original series from the 60s.
Nice. Yeah.
Oh,
The racist
yeah.
one. I mean, that's not why we liked it, or anyone likes it, but that is a definite part of it.
Star Trek, not so much if I recall correctly, but it's also been a while since I last really watched the original series, so.
So you're correct in that in the 60s, Star Trek was like progressive. It's like, whoa, you can't talk about that stuff on TV. What are you doing? But if you look back on it now, it's like, oh, they're using those words. Uh-oh.
Oh, I see what you mean.
But Star Trek, like in its time, it was very progressive and helped so many people and that deserved voices get them. You know what I mean? But it was still a part of America in the 60s.
Oh, well.
And
So that's why I grew up watching. Interestingly, my favorite sci-fi franchise is actually not Star Trek; it's Stargate. So
ooh, SC1.
Stargate SG-1, yeah.
Is it SG1 or SC1? I always get it wrong.
One
See,
SG-1. I'm pretty sure SG stands for Stargate.
I'm pretty sure you're correct. I just always get it wrong because SC1, I'm pretty sure I played a game called Planet. This is ultimate, like, down a rabbit hole. I played a game called, like, Planet Fall 2 or Planet Base 2 or Planet Side 2. That's what it was, Planet Side 2. And there was these teams, and each of them had, like, vehicles you could get. And they had crazy names. And I just knew that, like, I was, like, 10 years old when I played this game. I was like, if I go in the game and I click SC1, the vehicle, then it gets me like a big tank and I get to go kill people. And that's all I knew.
I see.
Or it was SG1 and I just made up SC1 for fun.
Who knows? Yeah, it's Stargate SG-1, and there's like 10 seasons of it. So if you have time and you like sci-fi, I'd recommend it. It's
I should
probably
watch
my
it.
favorite sci-fi franchise. And I'm saying that I have watched all of Star Trek pretty much, so still I prefer Stargate.
That's impressive. My favorite sci-fi franchise is Leave It to Beaver.
I've never heard of that.
You've never okay, it's not a sci-fi franchise at all. It's like the SpongeBob of the 60s in America. It's not a cartoon, but it's like just this. It's just like, okay. It's just a kid called Beaver. There's a kid called Beaver, and he just does stuff. That's the whole TV show. He has a brother, he has a mom, he has a dad, and that's it. It's like, oh, he got into a bike accident this episode. Oh, he talked to his friends, and they're saying bad words. Oh, no. But yeah, I grew up on Leave It to Beaver. Like, that was a main staple of my childhood. And then, like, Disney movies, like Nemo, right?
Oh, yeah.
And then I watched cartoons all the time as well. So, like, Jimmy Neutron, SpongeBob. What was the one? Chaotica? Was that what it was? I don't even know. That show got me through elementary school.
I've seen like episodes. Obviously, I've seen episodes of SpongeBob or like Phineas and Ferb and whatnot, but I never really watched those shows. Again, the most modern thing I really watched regularly back then was the Smurfs from the 80s.
That's incredible. Honestly, I admire. I kind of am a little bit envious of that because I feel like the new media has a different vibe and it's like more advertising forward. Until you watch like a soap opera. Then you're like, oh, this is literally made to sell soap. I get it now. Hence soap opera. Wow.
It's also like, TV shows have changed a lot and they're a lot more serial today than they were because TV shows used to be mostly episodic.
It's mostly just long story arcs.
Yeah.
That's
I've
a
even
general fact, I think, and it has to do with the fact that, as far as I know, it mostly used to be the case that you'd watch these shows on TV, and that's also how when I was
ah
12, and a friend of mine, or like acquaintance, I should say, of mine, told me that you can watch films online whenever you want to, and you don't have to wait for them to air on TV. My mind was blown. Like, I was like, wow, you can do that? I don't have to like wait until it comes up on TV. Okay, wow.
that's amazing. See,
I
I was
was like,
spoiled.
ooh.
Growing up, we had something called on demand. I hate saying these words because Comcast is just a horrible company and they did horrible things. Do horrible things. But on demand was like you can pay extra per month and then you can just like all of the TV is just always available like Netflix.
Oh, yeah. I see.
So that's what we had. So I would just watch Leave It to Beaver like churn through it, you know what I mean?
Oh God, yeah, no. What I had to do is, if you wanted to watch a show, you had to buy the DVDs.
See, that's a healthy mindset
I
is
had
what that's called.
all of Stargate, all of Star Trek on DVD.
That's incredible.
Because of that.
See, I don't have anything other than terrible memories. That's all I got, man. I guess my computer, I also have that. I do own that. Until the debtors come. And be like, hey, you owe too much. We're taking your assets. It's like, all I have is a computer. I mean, I don't have a computer. They're like, no, it's ours. Thanks. I try not to think about financial situations in America. It's so dumb.
I mean, yeah. The thing that I was saying earlier with how shows used to be episodic is because you'd have to wait for them to come out on TV, and you'd maybe watch an episode a week, and then if you miss one, yeah, and also you'd have to remember what happened last week, and that's too much to ask for. So it's better for stories to just be self-contained. Like maybe every once in a while there was a two-parter.
Yeah.
So that's like, whoa, story arc. But nowadays you could just watch the entire thing on Netflix. So that obviously encourages much more serial storytelling because you're more invested in it. You're gonna watch the entire thing if it's like keep watching to see what happens next.
That's true,
Whereas
the
with
binge
Star Trek,
watch.
okay, self-contained stories.
So binge watching ruined television. That's what Surade's take.
Changed.
Changed is better. My take is it ruined television. Because I don't care about serial storylines. I've tried. I can't invest myself in people I don't give a shit about. And I can't give a shit about people I like, fake people. I can't I mentally know these are real people being fake people. There's no way I can imagine that these are like these are fully real people and care about each other or actually think this way, because nobody talks or thinks like they do in TV shows. It's like the closest you'll get to a real moment in a TV show is like when somebody screams or cries, because it's hard to fake those things even as a person. So even when you're acting, you still just scream as yourself.
You're more or less lacking that suspension of disbelief as like a literature student would say. I did English for a semester, so it was horrible, but I still remember a few things. But how is it when it comes to animated shows? Because it's not actual actors, it's animated characters. Is that any different? Like if you watch an anime or something?
So, yes,
You watch anime?
I don't watch anime. Good question. I've tried many times to watch anime because many people that I enjoy being around watch anime. And what I found is that it's pretty interesting. There's nothing wrong with it. I'll sit there, I can watch 3 hours of Naruto episodes in a row. But if you ask me what happened or who they are or like what powers they have and how it works, it's like, how do you understand any of that stuff? I'm dumb. I'm watching and I'm going, how did that just happen? And they're like, oh no, he just used this special move, so now he's going to be able to run faster. And it's like, how do I know that?
I suppose you get more used to that as you watch, because I've watched a lot of anime, and I like watching anime. Like I just got done watching Black Clover, which is like 170 episodes.
I have a really,
So
I've heard of Black Clover. People around me have
Black Clover is great.
suggested that. I have a really big problem with repetition in that I'll watch the same episode of the same TV show 8 times in a row, and I'll laugh the same every time,
I see.
which is worrying. Right? I physically, like, I mentally make note when it happens. I'm like, this can't be good. Mentally, something has to be going wrong where I'm like, let's do the same thing 8 times in a row for 30 minutes. Or, for example, songs. I'll just loop the same song for like 4 hours.
Oh, yeah. I sometimes just sit there programming, listening to Bad Apple on repeat for 6 hours. I
That's fair.
typically just take the song and just loop that. And it's typically an anime opening or ending song or something like that.
Yeah.
I just loop that for 6 hours or something like that.
See, I do that same thing with rap. Just replace Bad Apple with like Nothing But a G Thing, and right? They're the same thing. That's exactly what I do.
I see.
And the crazy part is that I sing along a lot of the time, or rap along, whatever you want to call it.
I see.
So it's like, at the end of the day, I feel like I just came out of It's a Small World.
I have no idea what it is, but
That's okay. So in America, there's Disney World. Disney World. You know Disney World. And in Disney World, there's this ride, quote unquote, where you get in like a boat on a stream of water and you go through a tunnel and they go, it's a small world. It's a small forever. It's like 10 minutes. And kids love it. The kids want to go on it over and over and over again.
oh dear.
So when you're like,
Bad for the parents.
exactly, the parents at the end of the day, they come out of that place and they're going, "It's a small world." And then they just start crying because it's like, it's all that they can think. They're ruined. And that is what happens to me. I just do it to myself. I'm like, It's a Small World myself. That is,
It's not like particularly like Chicken on a Raft is an interesting song. You can also listen to just that for like 2 hours.
Chicken on a Raft.
Unironically, yeah. Or something like, I don't know, what's the one with I don't know, the one with John
Two.
Paul Jones the pirate. That one.
I
Random things I stumble upon on YouTube sometimes and I'm like, yeah, actually, I'm just gonna listen for that now for a while.
Oh man, that reminds me when I encountered Bo Burnham.
I have no idea what it is.
Okay, okay. Do you have Netflix?
I do have Netflix, yes.
Okay, if you have time and you like, watch Inside. It's just called Inside. It's by Bo Burnham.
Inside.
So Bo Burnham he's a comedian.
what?
Right.
Let's see.
He's a comedian and he's a really different comedian. He's not like a stand-up comedian.
Uh-huh.
He originally became popular through musical comedy
I see.
as a teenager. And then as he's gotten older, he's been able to make comedy specials,
Uh-huh.
which are not stand-up. They're just him on stage performing music he's made that is funny.
I see.
And like, if there's there's What? It's just What period. WHAT period. By Bo Burnham on YouTube. It's a completely free special that he did himself. But it showcases who he is greatly. And the first 10 minutes are a completely custom mimed intro song. And if I tried to describe that to you and how it's funny, I would like fail in 10 years. I wouldn't be able to do it. It's like, no, he mimes it. Like, why is that? He just does what he's saying? Like, no. So what? There's like a fairy and a unicorn, and then he has a gun, right? And then and it's like, I'll never be able to describe it.
Well, right, that isn't making any sense.
I know. But if you watch that special, you'll be like, oh, I really get this. I promise, Bo Burnham is a person.
I guess it's like trying to explain Mr. Bean to someone. It's like,
Yeah.
not really.
It's like, he just goes around and like does stuff, but he doesn't talk. That's what's funny.
No.
Yeah, that's so like.
It just makes funny noises sometimes.
Mm.
Yeah. I can't do it like Mr. Bean sounds.
See, I can't do sounds, but I make them anyway. I'm like, I can't do an accent, I can't make a sound, but I sure will try.
I can do one accent. It's the one that I have. Like,
I think I can do many accents, but none of them are of real people.
okay, I see, yeah. I mean, I suppose, yeah.
Cause I have like my surfer dude, man. Isn't how I talk.
That's not how I talk.
The thing that I find interesting is that people constantly tell me that I have a Scottish accent, and I don't. I really don't have a Scottish. If you know what a Scottish accent sounds like, I don't have a Scottish accent, and it's like I can't do a Scottish accent.
You're
what do
doing.
You mean I have a Scottish accent?
You're doing the Scottish don't, which I love. You're going don't. I don't have a Scottish accent, right? You're like I don't.
Just annoying. I don't have diphthongs in my accent. Like I say, what's an example like? Instead of like no, I say no. Instead of
Yeah.
what's another diphthong?
Aye.
Yeah, no. I know. No.
Yeah. Oh, that
And
does make
I'm
a lot
gonna
of sense.
try everything. But sometimes I don't because again, when I talk to mostly Americans, my accent gets closer to RP. It's not RP, but it's closer to RP, so I actually do end up having diphthongs. But depending on like, how thick my accent is, I don't have diphthongs, and I monophthongize everything, like even triphthongs. Like I say ta instead of tower.
Ta.
Just ta.
It's like a suggestion of the word tower.
Yeah.
I do like it. I like how subtle it is. I feel like it's you know how sometimes you get like a fancy meal and it doesn't taste strongly? It's like, oh, this is like fancy words. It's like it's just ta. It's not tower. You know what I mean? It's not salty fried food. It's a lightly salty fresh herb of ta. Is that mean? Am I being mean?
Oh, it's fine.
Okay, I don't mean to be mean. I really like I like it. It's like a fancy way to say things.
I make fun of American accents all the time. You're good.
We deserve it. We deserve it.
Oh yes,
Rural.
Southern especially Southern American accents. Mostly.
Yeah, we get our good licks in up north here too. See, us northerners, we never separated. The South was like they actually took part in the getting rid of like unification. Like, oh, the North and the South are friends now. The South is like, yeah, we're friends now. The North is like, no, you're still the South. Okay, we're up here, you're down there. That's very clear. It's not good, but it is true. What's weird is that California isn't South.
California isn't south.
No.
It's like it's west, I suppose it is.
Yeah, it's nearly the state that goes the lowest.
I
And it's-
only know what California is because it's right next to the wasteland, also known as Arizona, where Agma's from.
You're correct. It is scary there.
Arizona is the wasteland. I keep telling him all the time. He says like, "No, it's fine." What do you mean it's fine? You have
Okay.
cacti everywhere. You have huge hornets. And,
You're correct.
Like it's hotter than the Sahara Desert.
Yeah, I've
Like
been to.
how is this not a wasteland?
It is. If you've lived for a little bit, even a week in one of those cities down there, it's
want to.
scary. It's
I have
scary.
made a firm decision that I will never go to Arizona. Thank you very much.
That's
No.
fair. It is a
Australia
literal.
seems like a more hospitable place than Arizona.
It is. You are 100. Arizona is scary. It's flat, right? It's flat. You can see as far as your eyes allow you.
God.
And it's all this, it's just dirt.
Yeah,
It's
but
just-
I mean, Agnes sometimes shows pictures of it. Look at the vegetation, and I'm like, what do you mean vegetation?
There's
like
one
2
tree.
shrubs there,
Yeah.
and maybe like a lonely tree, and the rest is just dirt and rocks and sand.
It's
not-
terrifying.
and cacti, obviously, that's like the most vegetation you get there. And they get like 10 days of rain a year, 10 days.
Yeah, we have like both extremes. It gets very cold here and very hot.
Hmm.
I'm not going to disclose exactly where, but it's like the Pacific Northwest. You know what I mean?
Pacific is, I need to think a bit. That's the other
Top left.
ocean.
Yeah, the top left.
West, yeah. I always need to think with west. I know where west and east are because, like, when you look at them on the compass, they form the word "we." That's how I remember. West is
Nice.
left. East
That's
is
smart.
Right if it's not. And the only reason why I know where left and right is because I know I'm right-handed. So I go like, okay, what hand do I write with? It's this one, so this is right.
Nice.
Unironically, if it weren't for that, I would not know where left and right was. I always have to think.
That's a big one. I've had siblings, or family, I should say, that have that same problem where like left and right is hard.
Mm-hmm.
And it's really hard for me to grasp that because I never even remember learning left and right. I feel like I've known it since I was 2 years old.
Yeah, for me, it's this thing with what hand to write with, so that helps. I know I'm right-handed. Thank goodness. Otherwise, well,
You know what's cursed? You know how I remember west is to the left?
how
They rhyme.
west. What? It's not even the perfect rhyme.
It's not even a perfect rhyme. I know that's why it's horrible, but west and left, they rhyme. And I'm like, well, right and east don't rhyme. Right and west don't. Okay, it's got to be left and west.
Oh my god.
Casazanis. What?
Whatever works, I suppose.
It's true. It's true. Casazanis says, "What's up? Why full integer? Very verbose. Imagine saying that writing compilers is easy." I love the I love the journey that we take through the little intro messages.
I mean,
Cas-
you can write integer. You can spend some time implementing type aliases.
yeah.
Make for that.
Casazanis says, just like right and left. Yeah. Just like right and left. Implementing compilers. It's just like knowing left and right. It's easy. I've never heard right and left. That's like, it broke my brain a little.
Right and left. Yeah, it's kind of. It's always left and right, isn't it?
Because we're American, or I'm American, we're English. So left to right is like the default.
Oh, I suppose because writing. That's a good point.
That's the
That is
only
a good
reason.
point.
But it's also like YouTube, the scroll bar goes from left to right, and that's like time.
Yeah, I suppose because true. It's mostly left to right. Probably ultimately because of writing. That makes sense actually. Didn't
That's
even think
true.
about that.
The crazy causes. All right. Well, oh, by the way, Casazanis, exactly what Saraid said. Why full integer? Because that's what we wrote. If you want to go in,
Technically, I would have used int, but
that's right. So if you go into source parser, then you can just define a different type right here. Boink. Get rid of that. Now you have int. And so if you want to make your own little fork and do that, you can do that.
God, using long.
Yeah, I
think
know
we
it's
also
bad.
need to go through the entire thing and yeet all uses of long and replace them within 6040 because I've had another set of compiler warnings the other day that telling me, hey, why are you using this is not like long is not a int64. That's different types. I got a compiler out of it. Because on Linux int64 is long. Not long, it's long. That's long and long are different types even though they have the same size because that's how the C type system works.
Ugh.
Brilliant, isn't it?
Yeah, that's one word. Oh yeah, you can just change this right here in your own local distribution and fork it, make your own little int version of the language. It's really easy. Or
Yeah, don't forget to change it in like the 34 places below that too.
yeah, I mean, I figured I figured that would be clear. If you change integer once, you gotta change it everywhere. Boink. Do that.
This is
Replace
another
those.
place where I can tell the difference between how we write passes. I would definitely not use the name there. I would use an integer like a type struct and pass that in.
I see.
Because that's what I. If you look at my passes, they have like TI8, TI16, TI32. They have like the primitive types are
Their
like
own type.
pointers. And
That's
I'd
crazy.
pass in a pointer to the type struct here. And that would be the obvious way for me of doing it. So
So to me, a type, the only way a user can declare it is through a symbol. So the symbol is the fully defined type in my brain. This is the full type structure, is integer. Because that's all that people write, is they go integer A. Well,
to me,
technically they
it's
go
kind
A
of the
integer.
obvious because I conceive of it more like C does with type defs. If you have an unnamed struct and a type def, the unnamed struct is the actual type. The type def is just a name for it that's like in the symbol table, but the actual thing is something else and has nothing to do with the name. That's how I typically conceive of things and functions. They're structs, and the name is just a mapping from the symbol table. It has nothing to do intrinsically with the actual thing. That's how I think about it, and I think you think of it very differently.
I do. To me, it's like you should be able to conjure the data of the type just based on the one word that you input as source code.
Yeah, again, it's a very Lisp way of thinking about this.
Yep. Yep.
About symbols, whereas in C or C++, you don't even have that notion to begin with, really.
There are no symbols.
No, there is
There are
no
identifiers.
identifiers, yeah.
There's type identifiers, there's variable identifiers, there's function identifiers.
Yeah.
There's operators, unary and binary. There's
And lots of others.
unignored stuff like white space and commas. I guess commas aren't ignored, but they're
They're not. I mean, yeah, I know what you mean.
implementing C without commas wouldn't be game changing.
I mean, you couldn't use you couldn't use comma expressions, and that would be kind of sad because I like comma expressions. I've probably rewritten some of your code to use comma expressions sometimes because I like to use that in like while loops. If you have an assignment in
Yeah.
a while loop about like foo equals something comma foo instead of wrapping the entire thing in parentheses again because I don't like too many parentheses. I try to reduce the use of brackets as much as I can. That's why I typically also don't write braces around the body of an if I can avoid it.
Whereas I just go like full clarity.
Yeah. So if I were designing this language, for instance, I would just allow if expression, and I wouldn't require the second expression to be a block.
So these braces.
Yeah, I would just make it so you could yeet the braces and could just write if n less than 2, 1.
How would this work?
I mean, no, if you have more than one expression, obviously you need something in there. Yeah, that, basically. And what I do, though, sometimes is I make it optional. You can insert a then between the condition and the body, but it's optional. Because the parser doesn't know after the condition. Because the parser doesn't need it. It's just there for visual clarity. So if you want it, you could put it there. But you don't have to. You can also just write if n less than 2, 1. Because the parser knows when an expression ends or begins. It's unambiguous. It's a bit hard to read without the then. That's why I like allowing it. But I typically just use this. Because
It feels like it's missing. I feel like the code is gone. Oh no, there's a cat.
I like it. It's
Oh,
less
it's late.
cluttered with like unnecessary symbols.
I understand that. To me, I'm kind of the
Or
opinion.
I like less code is better.
So I'm kind of that opinion when it comes to like syntax of built-in features. So like a string, it makes sense that you use the quotes, right? So you would never say like, oh, I want to make a language where there's no quotes for strings.
That would be horrible. I mean,
That's-
actually, no, that wouldn't be horrible. That would be Perl, but let's not go there.
That's the equivalent of saying like, oh, an if doesn't have a brace. That'd be like, wait, then how do you write the thing? That's how it works. So so my brain goes like, these aren't removable, and if you remove them and like have a 1 here, if you just have if 1, this, like, I know there's supposed to be an expression, don't worry about it.
Yeah.
But if you just have like if 1, it loses its meaning. And then if you have then you have like this whole other keyword.
Yeah.
Oh my god, I should go. It's fine. Stupid cat.
For me, it's just really that when I look at a language, I immediately think about the structure and everything. I see, okay, this is a block expression. This is another expression. Yeah, I look at it that way. And for me, it's clear that there is a, like, I see how it's parsed, and I know that there's like
Yeah.
a break between the two expressions, even without the braces.
That makes sense. And like stack-based languages have a lot of that. You'll have like
I suppose.
and 2 less than if, and then you would have
Yeah.
dot dot dot, and then or like else dot 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 phi,
Yeah.
which I agree that this syntax doesn't bother me because I understand exactly what you're saying, where it's like you understand how the parser is working. It's like, oh, n is
Yeah.
pushed, 2 is pushed, less is pushed. If this, then blah blah blah. Then there's stuff here, and then till the else and or the phi. So you have that same like built-in parsing, but for ifs without braces,
Yeah.
which is impressive because I don't have that. I lose track of like, wait, what is happening? Even if I just write, like, even with indents, I still lose track of like what is going on here.
I see.
And it's mainly in this place right here, 1. It's like, wait, is n less than, like, is this a continuation of the condition, or is it? And I think with your then, that may solve a lot of things.
Yeah, that, and I also tend to write, if it's a continuation, I write the operator at the beginning of the line. So if it were 2 plus 1, I wouldn't write less than 2 plus line break 1. I'd write less than 2 line break plus 1. That way you see, okay, there's more stuff going on.
I see. Okay.
Yeah. That way it's clear that it's
And then the then.
continuation.
Okay.
I tend to do that, though sometimes I don't if it's like obvious that it's a continuation. If it's like inside the condition, if
Oh no.
it's like 20, it's like an or with like 20 cases or whatever.
Kazana says, I skipped a ton of their messages. I think I wrote right and left because I use right as a primary hand. That's a very interesting thing. That makes a lot of sense that it'd be in your brain first. It's like, oh, right, I use my right hand. Especially if you deal with that all the time or tell people like, yeah, I'm right-handed, or have done it recently. Anyway, east and west doesn't make sense anyway. Imagine having no magnetic pole. What? Castellanos, kappa. Oh no, please. Full clarity all the way. So that's definitely about the braces. Braces are clear and readable. Imagine Python. Lol. Yeah, let's make it all white space based now.
Indentation doesn't matter. It's just separate. It's like the syntax is the same, except that instead of a block, you allow any expression.
Yeah, there's no braces. Because then, in this case, I mean, how it should be parsed is this is a block expression with an expression inside of it. It's not parsed like that.
I know you don't pass it a lot, and I think like C wouldn't pass it a lot either. I think I pass it like that typically if it's that, and I'd pass this as a block expression.
Which is the smart way to do things, and it's how like the official grammar would be built of the language. That'd be the way to do things, unless you're just going to explicitly require this symbol, which is fine as well. But yeah, Kastana says, well then 4 characters and then is 4 characters and braces is 2 characters.
Yeah, but braces are a very unusual punctuation mark, and then is a very natural word. It's easy on the eyes for me. Just have then.
That's arguable. I write curly braces by hand a lot.
If I have like 3 or 4 sets of nested braces, like I can't tell what's going on anymore. I have to like read it very carefully.
Interesting. So to me,
a complicated if with like a lot nested and ors, like I need to like take a break and like look at it carefully. That's also with Lisp. I like if I see 6 parentheses at the end of the line, I have no idea how many levels deep I am. Lisp. I lose track of that immediately. If it weren't for indentation and auto formatting, I would have no idea what was going on.
I kind of understand that, but I have definitely gained an accruity where like you can tell that this is the end of the if. Oh, that's the end of the unless, right?
Yeah,
But that's
I'd have to like backtrack and count the parentheses. If it weren't for the indentation, I can tell because of the indentation, obviously. But if it weren't for
see,
that,
that's why I use forward sexp and backward symbolic expression, right?
I see.
So you can use Control Alt F and B, and if you're in one, it'll just go to the end. But if you're at the end of one, it'll go to the end of the next one, and so on. So if you go to the, if I keep just pressing B, then you see there's no previous symbolic expression within this list. But then if I exit the list with a regular backward char, Control B, then I can once again continue my previous. So if I'm within anywhere, like backward word, I can go, oh, just spam previous symbolic expression, and I get to like, okay, this is the beginning, and then I start from there. That's funny that I'm looking at code that says the functions that I'm talking about.
What?
Amazing.
I tried using like Control P and Control N the other day, but it's just really awkward. I'm just gonna stick with the arrow keys.
Oh no. So, do you see in the bottom right the Control N next line and previous line?
I see backward word.
Here, bottom right,
Oh,
way bottom
with
right.
I see.
Yeah.
Control P.
So that's the what I hit last. You'll notice I
Yeah.
only use Control P, Control A, Control N, Control F, B.
So weird. I like.
So right now I'm holding Control with my right thumb because of my keyboard, and then I'm typing P N F B A E. You know what I mean?
For me, the problem is they're like all over the place. Like the arrow keys are right next to each other.
Well, you have to move your hand physically to touch the arrow keys from typing.
Yeah. I
That's-
don't have a problem with that.
I don't have to do that. You don't have a
I
problem
typically-
with that.
I typically don't edit stuff that quickly. I'm not a fast typer, so I think more. I'm like, okay, I need to do something here, and then, okay, I need to go down here, and then I need to think about what I'm gonna go there, and I do that while I go there. And I don't need to type that much typically, so it works out for me typically.
I see. I have a very bursty. Kazana says he uses mouse, not like this. I mean, I use the mouse to like highlight something when I'm talking about it, and I talk with the mouse a lot, where I shake it and go, "Oh, like this? Huh? You know what I mean?"
I use it a lot for like stuff like go to definition. I will control click on a symbol instead of doing like I think it's alt dot. I think is go to definition in C line.
Oh no.
That I'll just control click on it.
So I pretty much the whole time I'm in Emacs, my hands don't move off the keyboard and from where they are. They stay in one spot.
Well, the thing for me is also when I mouse over a symbol, I get like the documentation for it, and or if it's a type, how big it is and stuff like that.
Me too.
So I use that a lot.
See, I have the same thing just with the cursor. Wherever the cursor is, the echo area tells me some data about it. Like insert has any amount of arguments.
I see.
And then and egglet works the same way if I'm in parser.c. So if I look at
Yeah.
ice, then you can see ice is actually isimple 2 vargs
Yeah, I
unreachable.
know. I've used Emacs before for C and C++. I know about that. For
I
me, it's
didn't
what
know. I didn't know if you used egglet before. Egglet is very specific with this echo area. LSP
Sure if
mode.
it is, actually, but I've used something that does that in Emacs.
'Kay.
I'm not good at Emacs. I'm configuring. I can know how to write like simple Emacs modes, and I use Emacs if I don't have any other editor or for LaTeX.
That's fair.
That's it.
I use
A program language, I usually use one of the JetBrains IDEs if I can. Or actually, obviously, if I'm working in Lisp, I'll use Emacs because it's kind of made for that.
Kasanis says, gotta go. See you later. I'll see you, Kasanis. Thanks for stopping in. We gotta go too. I should have been out an hour ago.
It's almost been 8 hours. Jeez.
I know. That happened fast, didn't it?
Yeah, it does. It
Zoomed
really
right by.
does.
So much more to do.
Never mind.
Okay. I actually probably should go now, or otherwise people are going to get mad at me.
Alright,
Matter.
alright. I don't know.
I'm already like texting them like,
Yeah,
it's fine.
to
It'll-
do.
soon. You almost ready? Yeah. What does that mean? Almost.
Not much.
All right. Anyway,
Alright.
thank you so much, especially you, Sir Aid, for being so fantastical today. I had a great old time.
It's fun.
It was fun. I laughed a lot. Tsoding knows about us.
Oh yeah.
It's
Yeah.
like we've been graced by the gods, so we are going to be blessed on the rest of our journey and have no issues, no bugs, no memory
Ooh.
leaks.
That'll be
We're good.
something.
Oh, if only, if only.
Mm.
But no, we implemented named functions, and we laughed along the way, and I think that's the most important part. We had a fun old time.
Mhm.
Anyway,
Now that we've made functions,
Ooh.
we can actually. Can we do pure functions now? I'm not sure. I need to think about that. Actually, I think we can now. We can do because the problem earlier was that we didn't have the name of the function. So now we actually can check what function is being called, and we can check if the function is pure, and if the call is unused, we can remove the entire call, and if the function is unused, we can remove the entire function
oh,
eventually.
that's
Which
beautiful.
wasn't possible before because we couldn't find the functions too easily because of the naming problems,
That's right,
and-
because the call wouldn't match up with the actual definition.
Yeah. And something else I was gonna say. What was it? Something else about optimization. Oh yeah. It's still annoying because you'll have to find the function every time. So it would be nice if that was in the IR, ASD, or whatever.
Yes, so I think we should make it where what you said, where we have the IR calls, they're actually just pointers to the IR function.
Yeah.
And I think to do that, we're just going to have to make code gen work differently when it comes to variables, which means we're probably going to have to refactor the ASD, which means we're probably, etc.
Yeah.
It's going to lead us down the line.
If you want to recursive descent pass, I can do that in a day. If you're interested.
We're good.
With so many recursive descent passes, it would basically just be like the IR passer.
It may not be a bad idea, but we'll see how it goes. If the parser keeps getting in the way and it's like we can't do things that we want to, it's not worth it to keep my stupid program I wrote for no reason. You know what I mean? It's just mine. That's the only reason it's there, is because I wrote it. So if it gets in the way, we'll definitely get rid of it. I'm going to try and not hold on to my darlings. I'm going to try and get rid of them.
I'm just more comfortable with my recursive descent passes that have the BNF comments everywhere, because that means if you change the grammar, you change the BNF, you update the BNF in the parser, and then you know immediately what you have to change.
It's true.
You can
So
very easily add a syntax somewhere and just introduce another function that passes that. It's very easy for me typically to update the language and okay, we add a keyword here. Sure, easy.
And I think that's between most people familiar with compilers, is they go, oh, that's a recursive descent parser. This is happening here. And it's it's a common pattern that everyone can understand.
Yeah, you can look at it and you immediately know what it does, where it does it, and how it does it.
Yes. And I think that we can get there with this type of parser, whatever it's called. It's just that it would require a restructuring of what is taught in computer science programs or what is focused on.
I will still say that some of the concepts used in the past are just not really commonly used outside of maybe lists, because the concept of a symbol anywhere really in from the lexing process to maybe code gen is not really something you have in C or C++. Like a C or C++ parser lexer will not have the concept of symbols the way you use it, basically as token types almost. I'm not quite sure. There's some weird mixture between token types and node types or whatever, or on parser states too. It's a mixture of everything, sort of.
You are exactly correct. It's a mixture of everything. The lexer doesn't do anything. The parser,
Yeah, Alexa doesn't do much. It just checks what does a token end. It doesn't try to find out what the hell this is.
it's literally just
Then
get the
Pass
next
has to check
lexeme.
every time. What is this?
Well, so would the lexer. It's no different.
Yeah, I mean, it's
And
easier if you don't have to worry about that in the parser, in my opinion. You can just go, okay, is this token? Instead of worrying what does this token actually look like. Like you don't have to care about what
Yeah.
the actual text of the program looks like. You just have to know, okay, semantically it's this type of token.
I'd say that's accurate.
Like that separation between Lexa and parser, where the Lexa just takes the input stream, produces tokens, and the parser doesn't have to worry about what the actual program looks like or how
And-
it's spelled or anything of that like that.
And I have made languages like that. As you saw earlier, we went through a few of them. The old ones.
And if you have token types like that and an end of file token, for instance, you don't have this entire problem with, oh, are we at end of file or not? Because the parser doesn't have to check for that. It just gets an end of file token. And if it hits end of file where it still needs to pass something, then that's going to error automatically because that code will look for a certain token and end of file is not the token it's looking for. So it will tell you wrong token. And that just happens automatically. You don't need to handle end of file manually. The only thing you need to do is produce an end of file token and it just sort of takes care of itself.
It is more elegant in that regard. But I'll say that this way is simple. It's not easy to use, it's simple.
Simple, yeah, that's what we were talking about like a while ago.
You're exactly correct. It's simple, yes. You can understand it and you can go, okay, this just breaks down this into this.
Yeah,
But-
it's simple, but it's harder to use, I'd say.
From the parser's point of view, it's harder to use.
Yeah,
But from like the developer's point of view, it's easier to write and maintain.
it's kind of a trade-off because certainly
100%.
the Lexa is a lot simpler than my Lexas and it's easier to write. However, the parser, because of that, is disproportionately more complicated to write.
Maybe not disproportionately.
Maybe not, but it's more complicated. Like my
Yes,
Lexa will be like 500 lines
100%.
of code, but the parser is fairly easy to read because of that, because it doesn't have to worry about any of that.
Whereas for me, the lexer is like,
Everything is in the parser, and Lexa does basically nothing.
yep. And then I took pieces of the type checker and put it in the parser so that we can just stop parsing if we encounter bad errors, fatal errors, which is going to be like a whole problem if we try and make an LSP with this compiler. But
Yeah, that's though I feel like that's a perfectly fine thing to do, at least when you're starting out, because trying to like recover from errors and any of that is like a mess. And it's I also usually just write passes that abort whenever they hit an error, or at least like throw an exception. Not abort the program, but like,
abruptly quit.
passing.
Abruptly quit.
They stop passing is what I mean.
Yeah.
So you can throw a set jump or whatever. So it's that. Like reporting multiple errors at once. I usually do that in the type checker. Just type check everything and then report all of the errors as I type check, and then you'll get multiple errors maybe, but not in the parser. That's usually how I do it, and I'm just lazy in that regard. You could certainly try and write a parser that tries to sort of recover from errors and maybe keep parsing and maybe report some more errors. But I always feel like if you've hit a syntax error anyway, then who knows how you're gonna try and parse the rest. Like,
Exactly.
it's messy and it's not something that I want to be concerned with when I start writing something. So
It's true.
An interesting idea, but it's not a priority. And also LSPs typically also just stop if there's a problem, at least in like a function. I suppose you could just skip to the end of the block or something, but if you like make a typo somewhere, delete something in C line, it will not syntax highlight the rest of the function. It'll just be white. Because it's like, no, screw you. I'm not gonna try and make sense of
It gave
that.
up.
Lost. Best you're gonna get is like tokens. If is still gonna be red because it knows if is if.
That's true. Until you start using tree sitter. All right. Well, I've said I'm going to go probably 18 times.
Yeah,
Let's wrap it up.
yeah.
Let's get the thing going. Whoa.
8-hour stream, Jesus Christ. If we keep going like this, we're gonna do a 24-hour stream on accident at some point.
You just made the announcement and you don't even know it. Oh no. A 24-hour stream on accident. That sounds so pog. It sounds like
Yeah.
something that's gonna happen though.
Other people plan for that, make it a challenge. With us, it just happens, sort of. We just
We just accidentally did it.
like. I mean, 8 hours. It's like a third of the way there. Let's be honest.
It honestly, if I like took a bathroom break, 8 more hours wouldn't be insane. I mean, it would because I don't
right
have.
now it would be because I'm pretty tired now. But in general, no.
See, I have a weird thing where it's like, I don't get tired until I tell myself, like, you have to sleep now. It's time to shut down, time to start sleeping. Otherwise, I just keep going. I'm
I
on.
notice like a time when I start getting a headache. That's when I know I need to go to bed, and that's kind of setting on right now. So,
We'll get you a Tylenol and tucked in. All right. Thank you so much, everybody, for watching. We did things today. You saw them, and hopefully you learned something. That's it. Bye.